Hello and welcome to IO Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head
chance to save somebody when they need you, when they need you. Go against the grain, don't be afraid. Yeah, all it takes is being brave. Yeah, all it takes is being brave.
Good morning, everyone. My name is Tom Greenaway, and I'm a partner developer advocate from Google Sydney with a focus on the indexability of progressive web applications.
Hi, everyone. I'm John Mueller. I'm a Webmaster Trends analyst from Zurich in Switzerland. It's great to see so many of you here, even at this early hour.
Now, as you can imagine, John and I have a lot of experience with the work web developers must do to ensure their websites are indexable, which is another way of saying whether a web page can be found and understood by search engines, to what it takes for a modern JavaScript-powered website to be properly indexed by search crawlers, and especially Google Search. And I'm excited to tell you that in this talk, we're announcing a bunch of cool new stuff, including a new change to Google Search policy, a new approach for rendering HTML to search crawlers, and even a new Google Search Console tool. It sounds like a lot of stuff, right? Well, that's because it is. So let's get started. Now, a long time ago, before I joined Google, I was building e-commerce sites. And I personally felt there was a lot of mystery at times behind Google Search, especially on the topic of indexability. I would wonder, why do some of my pages appear in Google Search and some don't? And what's the difference between them? Will JavaScript be rendered correctly? Will JavaScript rendered content appear properly and be indexed? And is lazy loading an image safe to do? These are really critical questions. And as developers ourselves, we understand the frustration behind this mystery. So today, John and I are going to do something we very rarely do at Google. We're going to pull back the curtain a little bit and reveal some new pieces of information about how Google Search sees the web and indexes it. And with this new knowledge and a few new tools, you'll have concrete steps you can take to ensure the JavaScript-powered websites you're building are visible to Google Search. Now, I want to remind you that this talk is about modern JavaScript-powered websites. And typically, these websites will be powered by a JavaScript framework, such as Angular, Polymer, React, or Vue.js. And who doesn't love a great web development framework that's easy to use and helps you build your sites faster and works great for your users? But it's important to recognize that some of these frameworks use a single-page app configuration model, meaning they use a single HTML file that pulls in a bunch of JavaScript. And that can make a lot of stuff simpler, but if you don't watch out, look at what the default template for a new Angular project looks like. As you can see, the default project template is pretty basic. It shows you how to use Angular to render a header, an image, and a few links. Nice and simple. How could this possibly be a problem from an indexability perspective? Well, let's take a peek behind the scenes at the HTML. This is it. Take a good look. When viewed in the browser, the default sample project had text, imagery, and links. But you wouldn't know that from looking at this initial HTML that's been delivered from the server, now would you? The initial HTML that's been sent down is actually completely devoid of any content. See here in the app root? That's all there is in the body of the page except for some script tags. So some search engines might assume that there's actually nothing here to index. And to be clear, Angular isn't the only web framework that serves an empty response on its initial server-side render. Polymer, React, and Vue.js have similar issues by default. So what does this mean for the indexability of our websites from the perspective of Google Search? Well, to answer that question better, we'll take a little step back and talk about the web in general, why search engines exist, and why search crawlers are necessary. Perhaps a good question to start with is, how big is the web? Well, we can tell you that we've actually found over 130 trillion documents on the web. So in other words, it's really big. And as you know, the aim of all search engines, including Google, is to provide a list of relevant search results based on a user's search query. And to make that mapping of user queries to search results fast and accurate, we need an index, similar to the catalog of a gigantic library. And given the size of the web, that's a really complex task. And so to build this index to power our search engine, we need another tool, a search crawler. And traditionally, a search crawler was basically just a computer and a piece of software that performed two key steps. One, it aims to find a piece of content to be crawled, and to do this, the content must be retrievable via a URL. And once we have a URL, we get its content and we sift through the HTML to index the page and find new links to crawl as well. And thus the cycle repeats. So let's look at that first step, the crawling, and break it down. Oh, and yes, as an Australian, I felt it was imperative that I include some spiders in my talk. So this is the cutest possible one I could find. John, what do you think? No, you're not convinced? OK, well, I have a few more in the deck, so maybe you'll come around. So to ensure the crawling is possible, there are some key things to keep in mind. Firstly, we need URLs to be reachable, as in there shouldn't be any issue when the crawler wants to request the web pages and retrieve the resources necessary for indexing them from your web server. And secondly, if there are multiple documents that contain the same content, we need a way to identify the original source, otherwise it could be interpreted as duplicate content. And finally, we also want our web pages to have clean, unique URLs. Originally, this was pretty straightforward on the web, but then the first single-page apps made things a bit more complicated. So let's go over each of these concepts. First, for the reachability of URLs, there's a simple, standard way to help search engines find content that you're probably familiar with. You add a plain text file called robots.txt to the top-level domain of your site, which specifies which URLs to crawl and which to ignore. And I say URLs because these rules can prevent JavaScript from being crawled too, which could affect your indexability. And this example also gives us a link to a sitemap. A sitemap helps crawlers by providing a recommended set of URLs to crawl initially for a site. And to be clear, there's no guarantee these URLs will get crawled. They're just one of the signals that search crawlers will consider. OK, but now let's talk about that duplicate content scenario and how search crawlers deal with this situation. Sometimes websites want multiple pages to have the same content, right? Even if it's a different website. For example, some bloggers will publish articles on their website and cross-post to services like Medium to increase the reach of their content. And this is called content syndication. But it's important for search crawlers to understand which URL you prefer to have indexed. So the canonical metadata syntax shown here in the HTML allows the duplicate documents to communicate to crawlers where the original authoritative source for the content lives. And we call that source document the canonical document. And traditionally, URLs for the web started out quite simple. Just a URL that was fetched from a server with some HTML. But then, of course, Ajax came along and just changed everything. Suddenly, websites could execute JavaScript, which could fetch new content from the server without reloading the browser page. But developers still wanted a way to support back and forward browser navigation and history as well. So a trick was invented which leveraged something called the fragment identifier. And its purpose is for deep linking into the subcontent of a page, like a subsection of an encyclopedia article. And because fragment identifiers were supported by browsers for history and navigation, this meant developers could trick the browser into fetching new content dynamically without reloading the browser page, and yet also support the history and the navigation we love about the web. But we realized that using the fragment identifier for two purposes, subsections on pages and also deep linking into content, it wasn't very elegant. So we moved away from that. And instead, another approach was proposed, to use the fragment identifier followed by an exclamation mark, which we call the hashbang. And this way, we could discern the difference between a traditional URL using the fragment identifier for the subcontent on a page versus a fragment identifier being used by JavaScript to deep link into a page. And this technique was recommended for a while. However, nowadays, there is a modern JavaScript API that makes these old techniques less necessary, and it's called the History API. And it's great because it enables managing the history state of the URL without requiring complete reloads of the browser, all through JavaScript. So we get the best of both worlds, dynamically fetch content with clean traditional URLs. And I can tell you that from Google's perspective, we no longer index that single hash workaround, and we discourage the use of the hashbang trick as well. OK, well, that's crawling out of the way. Now let's move on to the indexing step. So web crawlers ideally want to be able to find all the content on your website. If the crawlers can't see some content, then how are they going to index it? And the core content of the page includes all the text, imagery, video, and even hidden elements like structured metadata. In other words, it's the HTML of the page. But don't forget about that content you dynamically fetch either. This could be worth indexing as well, such as Facebook or Disqus comments. Crawlers want to see this embedded content too. And also, this might seem really obvious, but I want to emphasize that at Google, we take HTTP codes pretty seriously, especially 404 not found codes. If crawlers find a page that has a 404 status code, then they probably won't even bother indexing it. And lastly, of course, a crawler wants to find all the links on a page as well, because these links allow the crawlers to crawl further. So now let's just talk a bit about those links quickly, because honestly, they're some of the most important parts of the web. How do search crawlers like Google find links? Well, I can't speak for all search crawlers, but I can say that at Google, we only analyze one thing: anchor tags with href attributes, and that's it. For example, this span here that I've just added, it won't get crawled because it's not an anchor. And this additional span I've added, even though it's an anchor, it doesn't have an href attribute. But if you are using JavaScript, such as with the history API that I mentioned earlier, to navigate the page purely on the client and fetch new content dynamically, you can do that, so long as you use the anchor tags with href attributes, like in this last example. Because most search crawlers, including Google, will not simulate navigation of a page to find links. Only the anchor tags will be followed for linking. But wait, is that really everything? In order to have sifted through the HTML to index the page, we needed to have the HTML in the first place. And in the early days of the web, the server likely gave us all the HTML that was necessary. But nowadays, that's not really the case. So let's insert a step between crawling and indexing, because we need to recognize that the search crawlers themselves might need to take on this rendering task as well. Otherwise, how will the search crawler understand the modern JavaScript-powered websites we're building? Because these sites are rendering their HTML in the browser itself using JavaScript and templating frameworks, just like that Angular sample I showed you earlier. So when I say rendering, I don't mean drawing pixels to the screen. I'm talking about the actual construction of the HTML itself. And ultimately, this can only ever happen on either the server or on the client, or a combination of the two could be used, and we call that hybrid rendering. Now, if it's all pre-rendered on the server, then a search engine could just index that HTML immediately. But if it's rendered on the client, then things get a little bit trickier, right? And so that's going to be the challenge that we'll be discussing today. But one last term, you might be wondering, what is Google Search's crawler called? Well, we call it Googlebot, and we'll be referring to it a lot in this talk. And I think another detail to note is that I said that a search crawler is basically just a computer with some software running on it. Well, obviously, maybe in the 90s that was the case, but nowadays, due to just the sheer size of the web, Googlebot is comprised of just thousands of machines running all this distributed software that's constantly crunching data to understand all of this continuously expanding information on the web. And to be honest, I think we sometimes take for granted just how incredible Google Search really is. For example, I recently learned that with the Knowledge Graph, which is a database of all the information we have on the web, it actually maps out how more than 1 billion things in the real world are connected, and over 70 billion facts between them. It's kind of amazing. Okay, well, now that we know the principles of a search crawler, let's see how these 3 different key steps, crawling, rendering, and indexing, all connect. Because one crucial thing to understand is the cycle of how Googlebot works, or how it should ideally work. As you can see, we want these 3 steps to hand over to one another instantly. And as soon as the content is fully rendered, we want to index it to keep the Google Search index as fresh as possible. This sounds simple, right? Well, it would be if all the content was rendered on the server and complete when we crawl it. But as you know, if a site uses client-side rendering, then that's not going to be the case, just like that Angular sample I showed you earlier. So what does Googlebot do in this situation? Well, Googlebot includes its own renderer, which is able to run when it encounters pages with JavaScript. But rendering pages at the scale of the web requires a lot of time and computational resources. And make no mistake, this is a serious challenge for search crawlers, Googlebot included. And so we come to the important truth about Google Search we would like to share with you today, which is that currently, the rendering of JavaScript-powered websites in Google Search is actually deferred until Googlebot has the resources available to process that content. Now, you might be thinking, okay, well, what does that really mean? Well, I'll show you. In reality, Googlebot's process looks a bit different. We crawl a page, we fetch the server-side rendered content, and then we run some initial indexing on that document. But rendering the JavaScript-powered web pages takes processing power and memory. And while Googlebot is very, very powerful, it doesn't have infinite resources. So if the page has JavaScript in it, the rendering is actually deferred until we have the resources ready to render the client-side content. And then we index the content further. So Googlebot might index a page before rendering is complete, and the final render can actually arrive several days later. And when that final render does arrive, then we perform another wave of indexing on that client-side rendered content. And this effectively means that if your site is using a heavy amount of client-side JavaScript for rendering, you could be tripped up at times when your content is being indexed due to the nature of this two-phase indexing process. And so ultimately, what I'm really trying to say is, because Googlebot actually runs two waves of indexing across your content, it's possible some details might be missed. For example, if your site is a progressive web application and you've built it around the single-page app model, then it's likely all your unique URLs share some base template of resources, which are then filled in with content via AJAX or fetch requests. And if that's the case, consider this. Did the initially server-side rendered version of the page have the correct canonical URL included in it? Because if you're relying on that to be rendered by the client, then we'll actually completely miss it, because our second wave of indexing doesn't check for the canonical tag at all. Additionally, if the user requested a URL that doesn't exist, and you attempt to use JavaScript to send the user a 404 page, then we're actually going to miss that too. Now, John will talk more about these issues later in the talk, but the important thing to take away right now is that these really aren't minor issues. These are real issues that could affect your indexability. You know, metadata, canonical tags, HTTP codes. As I mentioned at the beginning of this talk, these are all really key to how search crawlers understand the content on your web pages. However, just to be clear, not all web pages on a website necessarily need to be indexed. For example, actually on the Google I/O schedule website, there is a listing and filter interface for the sessions. And we want search crawlers to find the individual session pages, but we discovered the client-side rendered deep links weren't being indexed because the canonical tags were rendered in the client, and the URLs were fragment identifier based. So we implemented a new template with clean URLs and server-side rendered canonical tags to ensure the session descriptions were properly indexed, because we care about that content. And to ensure these documents were crawlable, we added them to the sitemap as well. But what about the single-page app, which allows for filtering sessions? Well, that's more of a tool than a piece of content, right? Therefore, it's not as important to index the HTML on that page. So ask yourself this. Do the pages I care about from the perspective of content and indexing use client-side rendering anyway? Okay, so now you know. When building a client-side rendered website, you must tread carefully. As the web and the industry has gotten bigger, so too have the teams and companies become more complex. We now work in a world where the people building websites aren't necessarily the same people promoting or marketing those websites. And so this challenge is one that we're all facing together as an industry, both from Google's perspective and yours as developers. Because after all, you want your content indexed by search engines, and so do we. Well, this seems like a good opportunity to change tracks. So, John, do you want to take over and tell everyone about the Google search policy changes and some of the best practices they can apply so we can meet this challenge together?
Sure. Thanks, Tom. That was a great summary of how search works. Though I still don't know about those pictures of spiders. Yeah, kind of scary. But Googlebot, in reality, is actually quite friendly. Anyway, as Tom mentioned, the indexing of modern JavaScript-powered websites is a challenge. It's a challenge both for Google as a search engine and for you all as developers of the modern web. And while developments on our side are still ongoing, we'd like to help you to tackle this challenge in a more systematic way. So for that, we'll look at three things here. The policy change that we mentioned briefly before, some new tools that are available to help you diagnose these issues a little bit better, and lastly, a bunch of best practices to help you to make better JavaScript-powered websites that also work well in search. So we've talked about client-side rendering briefly and server-side rendering already. Client-side rendering is a traditional state where JavaScript is processed on the client. That would be the user's browser or on a search engine. For server-side rendering, the server, so your server, will process the JavaScript and serve mostly static HTML to search engines. Often, this also has speed advantages. So especially on lower-end devices, on mobile devices, JavaScript can take a bit of time to run. So this is a good practice. For both of these, we index the state as ultimately seen in the browser. So That's what we pick up, and we try to render pages when we need to do that. There's a third type of rendering that we've talked about in the past. It starts in the same way, in that pre-rendered HTML is sent to the client, so you have the same speed advantages there. However, on interaction, or after the initial page load, the server adds JavaScript on top of that. And as with server-side rendering, our job as a search engine is pretty easy here. We just pick up the pre-rendered HTML content. We call this hybrid rendering. This is actually our long-term recommendation. We think this is probably where things will end up in the long run. However, in practice, implementing this can still be a bit tricky, and most frameworks don't make this easy. A quick call out to Angular, since we featured them in the beginning as an example of a page that was hard to pick up. They have built a hybrid rendering mode with Angular Universal that helps you to do this a little bit easier. Over time, I imagine more frameworks will have something similar to make it easier for you to do this in practice. However, at least at the moment, if your server isn't written in JavaScript, you're going to be dealing with kind of double maintenance of controlling and templating logic as well. So what's another option? What's another way that JavaScript sites could work well with search? We have another option that we'd like to introduce. We call it dynamic rendering. In a nutshell, dynamic rendering is the principle of sending normal client-side rendered content to users and sending fully server-side rendered content to search engines and to other crawlers that need it. This is the policy change that we talked about before. So we call it dynamic because your site dynamically detects whether or not the requester is a search engine crawler, like Googlebot, and only then sends the server-side rendered content directly to the client. You can include other web services here as well that can't deal with rendering. For example, maybe social media services or chat services, anything that tries to extract structured information from your pages. And for all other requesters, so your normal users, you would serve your normal hybrid or client-side rendered code. This also gives you the best of both worlds and makes it easy for you to migrate to hybrid rendering for your users over time as well. One thing to note, this is not a requirement for JavaScript sites to be indexed. As you'll see later, Googlebot can render most pages already. For dynamic rendering, our recommendation is to add a new tool or step in your server infrastructure to act as a dynamic renderer. This reads your normal client-side content and sends a pre-rendered version to search engine crawlers. So how might you implement that? We have two options here that help you to kind of get started. The first is Puppeteer, which is a Node.js library which wraps a headless version of Google Chrome underneath. This allows you to render pages on your own. Another option is Rendertron, which you can run as a software as a service that renders and caches your content on your site as well. Both of these are open source, so you could make your own version or use something from a third party that does something similar as well. For more information on these, I'd recommend checking out the I/O session on Headless Chrome. I believe there's a recording about that already. Either way, keep in mind rendering can be pretty resource intensive. So we recommend doing this out of band from your normal web server and implementing caching as you need it. So let's take a quick look at what your server infrastructure might look like with a dynamic renderer integrated. Requests from Googlebot come in on the side here. They're sent to your normal server, and then perhaps through a reverse proxy, they're sent to the dynamic renderer. There, it requests and renders the complete final page and sends that back to the search engines. So without needing to implement or maintain any new code, this setup could enable a website that's designed only for client-side rendering to perform dynamic rendering of the content to Googlebot and to other appropriate clients. If you think about it, this kind of solves the problems that Tom mentioned before. And now we can be kind of confident that the important content of our web pages is available to Googlebot when it performs its initial wave of indexing. So how might you recognize Googlebot requests? This is actually pretty easy. So the easiest way to do that is to find Googlebot in the user agent string. You can do something similar for other services that you want to serve pre-rendered content to. And for Googlebot, as well as some others, you can also do a reverse DNS lookup if you want to be sure that you're serving it just to legitimate clients. One thing to kind of watch out for here is that if you serve adapted content to smartphone users versus desktop users, or you redirect users to different URLs depending on the device that they use, you must make sure that dynamic rendering also returns device-focused content. In other words, mobile search engine crawlers, when they go to your web pages, they should see the mobile version of the page, and the others should see the desktop version. If you're using responsive design, so if you're using the same HTML and just using CSS to conditionally change the way the content is shown to users, this is one thing you don't need to watch out for, because the HTML is exactly the same. What's not immediately clear from the user agents is that Googlebot is currently using a somewhat older browser to render pages. It uses Chrome 41, which was released in 2015. The most visible implication for developers is that newer JavaScript versions and coding conventions like arrow functions aren't supported by Googlebot. And with that, also any API that was added after Chrome 41 currently isn't supported. You can check these on a site like Can I Use? And while you could theoretically install an older version of Chromium, we don't recommend doing that for obvious security reasons. Additionally, there are some APIs that Googlebot doesn't support because they don't provide additional value for search. We'll check these out too. All right. So you might be thinking, this sounds like a lot of work, John. I don't know. Do I really need to do this? So a lot of times, Googlebot can render pages properly. Why do I really have to watch out for this? Well, there are a few reasons to watch out for this. First is if your site is large and rapidly changing. For example, if you have a news website that has a lot of new content that keeps coming out regularly and requires quick indexing. As Tom showed, rendering is deferred from indexing. So if you have a large and dynamic website, then kind of the new content might take a while to be indexed otherwise. Secondly, if you rely on modern JavaScript functionality, for example, if you have any libraries that can't be transpiled back to ES5, then dynamic rendering can help you there. And that said, we continue to recommend using proper graceful degradation techniques so that even older clients have access to your content. And finally, there's a third reason to also look into this. In particular, if you're using social media sites, if your site relies on sharing through social media or through chat applications, if these services require access to your page's content, then dynamic rendering can help you there too. So, when might you not use dynamic rendering? I think the main aspect here is balancing the time and effort needed to implement and to run this with the gains that are received. So remember, implementation and maintenance of dynamic rendering can use a significant amount of server resources. And if you see Googlebot is able to index your pages properly, then if you're not making critical high-frequency changes to your site, maybe you don't need to actually implement anything special. Most sites should be able to let Googlebot render their pages just fine. Like I mentioned, if Googlebot can render your pages, then probably you don't need dynamic rendering for that site. Let's take a look at a few tools to help you figure out what the situation is. When diagnosing rendering, we recommend doing so incrementally. First, checking the raw HTTP response, and then checking the rendered version, either on mobile or on mobile and desktop, if you serve different content, for example. Let's take a quick look at these. So, looking at the raw HTTP response, one way to do that is to use Google Search Console. To gain access to Google Search Console and to a few other features that they have there, you first need to verify ownership of your website. This is really easy to do. There are a few ways to do that, so I'd recommend doing that regardless of what you're working on. Once you have your site verified, you can use a tool called Fetch as Google, which will show the HTTP response that was received by Googlebot, including the response code on top and the HTML that was provided before any rendering was done. This is a great way to double check what is happening on your server, especially if you're using dynamic rendering to serve different content to Googlebot. Once you've checked the raw response, I recommend checking how the pages actually render. So the tool I use for this is the mobile-friendly test. It's a really fast way of checking Google's rendering of a page. As I mentioned, the name suggests that it's made for mobile devices. So as you might know, over time, our indexing will be primarily focused on the mobile version of a page. We call this mobile-first indexing. So it's good to already start focusing on the mobile version when you're testing rendering. We recommend testing a few pages of each kind of page within your website. So, for example, if you have an e-commerce site, check the home page, some of the category pages, and some of the detail pages. You don't need to check every page on your whole website because a lot of times the templates will be pretty similar. If your pages render well here, then chances are pretty high that Googlebot can render your pages for search as well. One thing that's kind of a downside here is that you just see the screenshot. You don't see the rendered HTML here. What's one way to check the HTML? Well, new for I/O. I think we launched this yesterday. We've added a way to review the HTML after rendering. This is also in the mobile-friendly test. It shows you what was created after rendering with the mobile Googlebot. Includes all of the markup for links, for images, for structured data, any invisible elements that might be on the page after rendering. So, what do you do if the page just doesn't render properly at all? We also just launched a way to get full information about loading issues from a page as well. On this part within the mobile-friendly test, you can see all of the resources that were blocked by Googlebot. So this could be JavaScript files or API responses. A lot of times, not everything needs to be crawled, kind of like Tom mentioned. For example, also, if you have tracking pixels on a page, Googlebot doesn't really need to render those tracking pixels. But if you use an API to pull in content from somewhere else, and that API endpoint is blocked by robots text, then obviously we can't pull in that content at all. An aggregate list of all of these issues is also available in Search Console. So when pages fail in a browser, usually I check the developer console for more information to see more details on exceptions. And new for I/O, one of the most requested features from people who make JavaScript-powered sites for search is also showing the console log when Googlebot tries to render something. This allows you to check for all kinds of JavaScript issues. For example, if you're using ES6 or if you just have other issues with the JavaScript when it tries to run. This makes my life so much easier because I don't have to help people with all of these detailed rendering issues that much. Desktop is also a topic that still comes up. As you've seen in maybe some of the other sessions, desktop isn't quite dead. So you can run all of these diagnostics in the rich results test as well. This tool shows the desktop version of these pages. So now that we've seen how to diagnose issues, what kind of issues have we run across with modern JavaScript-powered sites? What patterns do you need to watch out for and handle well on your side? So remember Tom mentioned at the beginning of the talk something about lazy loading images and being unsure if they're indexable. Well, it turns out they're only sometimes indexable. So it was good to look at that. Depending on how lazy loading is implemented, Googlebot may be able to trigger it, and with that may be able to pick up these images for indexing. For example, if the images are above the fold and your lazy loading kind of runs those images automatically, then Googlebot will probably see that. However, if you want to be sure that Googlebot is able to pick up lazy loaded images, one way to do that is to use a NoScript tag. So you can add a NoScript tag around a normal image element, and we'll be able to pick that up for image search directly. Another approach is to use structured data on a page. When we see structured data that refers to an image, we can also pick that up for image search. As a side note, for images, we don't index images that are referenced only through CSS. We currently only index images that are kind of embedded with the structured data markup or with image tags. Apart from lazy loaded images, there are other types of content that require some kind of interaction to be loaded. What about tabs that load the content after you click on them, or if you have infinite scroll patterns on a site? Googlebot generally won't interact with a page, so it wouldn't be able to see these. There are two ways that you can get this to Googlebot, though. Either you can preload the content and just use CSS to toggle visibility on and off. That way, Googlebot can see that content from the preloaded version. Or alternately, you can just use separate URLs and navigate the user and Googlebot to those pages individually. Now, Googlebot is a patient bot, but there are a lot of pages that we have to crawl, so we have to be efficient and kind of go through pages fairly quickly. When pages are slow to load or render, Googlebot might miss some of the rendered content. And since embedded resources are aggressively cached for search, rendering timeouts are really hard to test for. So to limit these problems, we recommend making performant and efficient web pages, which you're hopefully already doing for users anyway, right? Anyway, in particular, limit the number of embedded resources and avoid artificial delays like timed interstitials like here. You can test pages with the usual set of tools and roughly test rendering with the mobile-friendly testing tool. And while timeouts here are a little bit different for indexing, in general, if the pages work in the mobile-friendly test, they'll work for search indexing too. Additionally, Googlebot wants to see the page as a new user would see it. So we crawl and render pages in a stateless way. Any API that tries to store something locally would not be supported. So if you use any of these technologies, make sure to use graceful degradation techniques to allow anyone to view your pages, even if these APIs are not supported. And that was it with regards to critical best practices. Now it's time to take a quick circle back and see what we've seen. So, first, we recommend checking for proper implementation of best practices that we talked about. In particular, lazy loaded images are really common. Second, test a sample of your pages with the mobile-friendly test and use the other testing tools as well. Remember, you don't need to test all of your pages. Just make sure that you have all of the templates covered. And then finally, if pages are large and if sites are large and quick changing, and you can't reasonably fix rendering across the site, then maybe consider using dynamic rendering techniques to serve Googlebot and other crawlers a pre-rendered version of your page. And finally, if you do decide to use dynamic rendering, make sure to double-check the results there as well. One thing to keep in mind, indexing isn't the same as ranking. But generally speaking, pages do need to be indexed before their content can appear in search at all. I don't know, Tom, do you think that covers about everything?
Well, it was a lot to take in, John. There was some amazing content. But I guess one question I have, and I think maybe other people in the audience have this on their mind as well, is it always going to be this way, John?
That's a great question, Tom. I don't know. I think things will never stay the same. So, as you mentioned in the beginning, this is a challenge for us that's important. Within Google Search, we want our search results to reflect the web as it is, regardless of the type of website that's used. So our long-term version is that you, the developers, shouldn't need to worry as much about this for search crawlers. So circling back on the diagram that Tom showed in the beginning with deferred rendering, one change we want to make is to move rendering closer to crawling and indexing. Another change we want to make is to make Googlebot use a more modern version of Chrome over time. Both of these will take a bit of time. I don't like making long-term predictions, but I suspect it'll be at least until end of year until this works a little bit. And similarly, we trust that rendering will be more and more common across all kinds of web services. So at that point, dynamic rendering is probably less critical for modern sites. However, the best practices that we talked about, they'll continue to be important here as well. How does that sound, Tom?
Yeah, it sounds really great. I think that covers everything, and I hope everyone in the room has learned some new approaches and tools that are useful for making your modern JavaScript-powered websites work well in Google Search. If you have any questions, we'll be in the Mobile Web Sandbox area together with the Search Console team. And alternatively, you can always reach out to us online as well, be it through Twitter, our live office hours hangouts, and in the Webmaster Help Forum as well. So thanks, everyone, for your time.
Thank you.
Down, down, down. Pull you.
Good morning and welcome back to I/O Live. It's our third and final day of our Developer Festival. Now there are still so many great sessions and sandbox demos ahead, so let's get to it.
Good afternoon, everyone. We're going to talk more about new capabilities we're releasing, as well as the improvements we're making to the platforms and tools you use every day.
Today, we are excited to announce the new app model for Android. Using the Android App Bundle, a new publishing format, you can dramatically reduce app size. We're announcing Android Jetpack, the next generation of Android APIs to accelerate Android development. Jetpack is a set of libraries and tools. Jetpack's APIs are integrated with the IDE too. For instance, Android Studio now includes a navigation editor, which works with the library. You told us, work on emulator boot time.
Ready, set, go. I was not cheating. It was not running in the background.
Slices are a cool new way to drive re-engagement. We wanted these to be easy to build, so you'll find templates that are rich and flexible. And because it's Jetpack, slices work on 95% of devices.
And starting today, you can deeply customize the appearance of your action. First, we're making it even easier for you to promote your action with something new we call action links. Right there at the bottom. These are hyperlinks that you can use from anywhere that point directly into your action. Once users opt in, Action Notifications gives you a way to connect with them about new features and content. These notifications work on the phone even if users don't have your Android app installed, and you'll be able to re-engage with your users on speakers, smart displays, and other assistant-enabled devices. After somebody engages with your action, you can prompt them to add your action to their routine with just a couple of taps.
And we're incredibly excited that Service Worker, the underlying new API that makes PWAs possible, is now supported on all major browsers, including recently Edge on Windows and Safari on both desktop and mobile. This is probably the most important leap forward for the web in the last decade. Today, we're launching Lighthouse 3.0, which makes Lighthouse's performance metrics even more precise and its guidance even more actionable. I'm happy to share that AMP is evolving in some big ways. Now, all AMP content benefits from a fast, free, privacy-preserving cache that optimizes page loads. But they've had these google.com URLs. So we're fixing that with a new standard called web packaging. We're expanding Chrome OS to support developers with the ability to securely run Linux apps on Chrome OS. So this means that many of your favorite tools, editors, and IDEs now work on Chromebooks.
We're proud to announce Material Theming, a major update to the material design system. Today, we're also releasing 2 new tools to make it faster to go from design to implementation. Material Theme Editor. This plugin for the popular application Sketch helps designers create and customize a unique material theme. This is the tool used by product teams at Google to review and comment on design iterations. To make material yours, get started at material.io.
Cloud TPUs are now available to everyone, and getting started is as simple as following this link. We've released the MLKit in beta, an SDK that brings Google's machine learning capabilities to mobile developers through Firebase. We believe success in AI should be determined by your imagination, not your infrastructure.
Predictions applies ML to your analytics data and predicts the future behavior of your users so you can take proactive actions to optimize your app. For example, you can lower the difficulty of your game for users who are likely to abandon it, or send special offers to users who are likely to spend. We're bringing together Google's machine learning technologies from across Google and making that available to every mobile developer working on Android and iOS. And since MLKit is available through Firebase, it's easy for you to take advantage of the broader Firebase platform.
We're rolling out a major update to ARCore to help you create even richer, more immersive and interactive experiences. That's why we've created SceneForm, a brand new 3D framework that makes it easy for Java developers to create ARCore applications. Today, we're introducing augmented images, a new capability in ARCore that makes it possible to attach AR content and experiences to the physical images in the real world. With Cloud Anchors, we actually allow multiple devices to generate a shared, synchronized understanding of the world so that multiple phones can see and interact with the exact same digital content in the same place at the same time.
Boy, I'm delighted to be here today and have a chance to talk to you about what is one of the biggest challenges we faced in computing, opportunity to rethink how we build computers and how we move forward. You know, there's been a lot of discussion about the ending of Moore's Law. The first thing to remember about the ending of Moore's Law is something Gordon Moore said to me. He said, all exponentials come to an end. It's just a question of when. And that's what's happening with Moore's Law. If we look at what does it really mean to say Moore's Law is ending? What does it really mean? Well, look at what's happening in DRAMs. That's probably a good place to start because we all depend on the incredible growth in memory capacity. And if you look at what's happened in DRAMs, for many years we were achieving increases of about 50% a year. In other words, going up slightly faster even than Moore's Law. Then we began a period of slowdown. And if you look at what's happened in the last 7 years, this technology we were used to seeing boom, the number of megabits per chip, more than doubling every 2 years, is now going up at about 10% a year, and it's going to take about 7 years to double. Now, DRAMs are a particularly odd technology because they use deep trench capacitors, so they require a very particular kind of fabrication technology. What's happening in processors, though? And if you look at the data in processors, you'll see a similar slowdown. Moore's Law is that red line going up there, on a nice logarithmic plot. Notice the blue line. That's the number of transistors on a typical Intel microprocessor at that date. It begins diverging slowly at first, but look what's happened since in the last 10 years, roughly. The gap has grown. In fact, if you look at where we are in 2015, 2016, we're more than a factor of 10 off had we stayed on that Moore's Law curve. Now, the thing to remember is that there's also a cost factor in here. Fabs are getting a lot more expensive, and the cost of chips is actually not going down as fast. So a result of that is that the cost per transistor is actually increasing at a worse rate. So we're beginning to see the effects of that as we think about architecture. But if the slowdown of Moore's Law, which is what you see all the press about, is one thing, the big issue is the end of what we call Dennard scaling. So Bob Dennard was an IBM employee, was the guy who invented the one transistor DRAM. And he made a prediction many years ago that the energy, the power per square millimeter of silicon would stay constant. Would stay constant because voltage levels would come down, capacitance would come down. What does that mean? If the energy, if the power stays constant and the number of transistors increases exponentially, then the energy per transistor is actually going down. And in terms of energy consumption, it's cheaper and cheaper and cheaper to compute. Well, what happened with Dennard scaling? Well, look at that blue line there. The red line shows you the technology improving on a standard Moore's Law curve. The blue line shows you what's happening to power. And you all know, I mean, you've seen microprocessors now, right? They slow their clock down, they turn off cores, they do all kinds of things, because otherwise they're going to burn up. They're going to burn up. I mean, I never thought we'd see the day where a processor would actually slow itself down to prevent itself overheating. But we're there. And so what happens with Dennard scaling is it began to slow down starting about 97, and then since 2007, it's essentially halted. The result is a big change. All of a sudden, energy, power becomes the key limiter. Not the number of transistors available to designers, but their power consumption becomes the key limiter. That requires you to think completely differently about architecture, about how you design machines. It means inefficiency in the use of transistors in computing, inefficiency in how an architecture computes is penalized much more heavily than it was in this earlier time. And of course, guess what? All the devices we carry around, all the devices we use are running off batteries. So all of a sudden, energy is a critical resource, right? What's the worst? The worst thing that happens is your cell phone runs out of power, your smartphone runs out of power. That's a disaster, right? But you think about all the devices we walk around with. They're hooked up to battery. Think about the coming era of IoT, where we're going to have devices that are always on and permanently on, which are expected to last 10 years on a single battery by using energy harvesting techniques. Energy becomes the key resource in making those things work efficiently. And as we move more and more to always-on devices with things like Google Assistant, you're going to want your device on all the time, or at least you're going to want the CPU on all the time, if not the screen. So we're going to have to worry more and more about power. But the surprising thing that many people are surprised by is that energy efficiency is a giant issue in large cloud configurations. This shows you what the typical capital cost would be like for a Google data center. You'll notice that green slice there, those are the servers, but look at the size of that red slice. That red slice is the cost of the power plus cooling infrastructure. Spending as much on power and cooling as you're spending on processors. So energy efficiency becomes a really critical issue as we go forward. And the end of Dennard scaling has meant that there's no more free lunch. For a lot of years, we had a free lunch. It was pretty easy to figure out how to make computation more energy efficient. Now it's a lot harder. And you can see the impact of this. This just shows you 40 years of processor performance. What's happened to unit processor, single processor performance, and then multiprocessor performance. So there were the early years of computing, the beginning of the microprocessor era. We were seeing about 22% improvement per year. The creation of RISC in the mid-1980s. A dramatic use of instruction-level parallelism, pipelining, multiple issue. We saw this incredible period of about 20 years where we got roughly 50% performance improvement per year. 50%, that was amazing. Then the beginning of the end of Dennard scaling. What did that caused everybody to move to multi-core. What did multi-core do? Multi-core shoved the efficiency problem from the hardware designer to the software people. Now the software people had to figure out how to use those multi-core processors efficiently. But Amdahl's law came along, reared its ugly head. I'll show you some data on that. And now we're in this late stage period where it looks like we're getting about 3% performance improvement per year. Doubling could take 20 years. That's the end of general purpose processor performance as we know it, as we're used to for so many years. Why did this happen? Why did it grind to a halt so fast? Well, think about what was happening during that RISC era where we're building these deeply pipelined machines, 15, 16, 17 stages deep pipelines, 4 issues per clock. That machine needs to have 60 instructions that it's working on at once. 60 instructions. How does it possibly get 60 instructions? It uses speculation. It guesses about branches, it yanks instructions, and tries to execute them. But guess what happens? Nobody can predict branches perfectly. Every time you predict a branch incorrectly, you have to undo all the work associated with that misprediction. You've got to back it out, you've got to restore the state of the machine. And if you look inside a typical Intel Core i7 today, on integer code, roughly 25% of the instructions that get executed end up being thrown away. Guess what? The energy still got burnt to execute all those instructions. And then I threw the results away, and I had to restore the state of the machine. A lot of wasted energy. That's why the single processor performance curve ended, basically. But we see similar challenges when you begin to look at multi-core things. Amdahl's law, Gene Amdahl wrote Amdahl's law more than 40 years ago. It's still true today. Even if you take large data centers with heavily parallel workloads, it's very hard to write a big, complicated piece of software and not have small sections of it be sequential, whether it's synchronization or coordination or something else. So think about what happens. You get a 64 processor multi-core in the future. Suppose 1%, just 1% of the code is sequential. Then that 64 processor multi-core only runs at the speed of a 40 processor core. But guess what? You paid all the energy for a 64 processor core executing all the time, and you only got 40 processors out of that, slightly more than half. That's the problem. We've got to break through this efficiency barrier. We've got to rethink how we design machines. So what's left? Well, software-centric approaches. Can we make our systems more efficient? It's great that we have these modern scripting languages. They're interpreted, dynamically typed. They encourage reuse. They've really liberated programmers to get a lot more code written and create incredible functionality. They're efficient for programmers. They're very inefficient for execution. And I'll show you that in a second. And then there are hardware-centric approaches, what Dave Patterson and I call domain-specific architectures, namely designing an architecture which isn't fully general purpose, but which does a set of domains, a set of applications really well, much more efficiently. So let's take a look at what the opportunity is. This is a chart that comes out of a paper by Charles Licensson and a group of colleagues at MIT called There's Plenty of Room at the Top. They take a very simple example, admittedly, matrix multiply. They write it in Python. They run it on an 18-core Intel processor. And then they proceed to optimize it. First, rewrite it in C. That speeds it up 47 times. Now, any compiler in the world that can get a speed up of 47 would be really remarkable, even a speed up of 20. Then they rewrite it with parallel loops. They get almost a factor of 9 out of that. Then they rewrite it by doing memory optimization. That gives them a factor of 20. They block the matrix. They allocate it to the caches properly. That gives them a factor of 20. And then, finally, they rewrite it using Intel AVX instructions, using the vector instructions in the Intel core, right? Domain-specific instructions that do vector operations efficiently. That gives them another factor of 10. The end result is that final version runs 62,000 times faster than the initial version. Now, admittedly, matrix multiply is an easy case, small piece of code, but it shows the potential of rethinking how we write this software and making it better. So what about these domain-specific architectures? Really, what we're going to try to do is make a breakthrough in how efficient we build the hardware. And by domain-specific, we're referring to a class of processors which do a range of applications. They're not like, for example, the modem inside your cell phone, right? That's programmed once, it runs modem code, it never does anything else. But think of a set of processors which do a range of applications that are related to a particular application domain. They're programmable, they're useful in that domain. They take advantage of specific knowledge about that domain when they run, so they can run much more efficiently. Obvious examples, doing things for neural network processors, doing things that focus on machine learning. One example. GPUs are another example of this kind of thinking, right? They're programmable in the context of doing graphics processing. So for any of you who have ever seen any of the books that Dave Patterson and I wrote, you know that we like quantitative approaches to understand things, and we like to analyze why things work. So the key about domain-specific architectures is there is no black magic here. Going to a more limited range of architectures doesn't automatically make things faster. We have to make some specific architectural changes that win. And there are 3 big ones. The first is we make more effective use of parallelism. We go from a multiple instruction, multiple data world that you'd see on a multi-core today to a single instruction, multiple data. So instead of having each one of my cores fetch separate instruction streams, have that separate caches, I've got one set of instructions and they're going to a whole set of functional units. It's much more efficient. What do I give up? I give up some flexibility when I do that. I absolutely give up flexibility. But the efficiency gain is dramatic. I go from speculative, out-of-order machines, what a typical high-end processor from ARM or Intel processor looks like today, to something that's more like a VLIW that uses a set of operations where the compiler has decided that a set of operations can occur in parallel. So I shift work from runtime to compile time. Again, it's less flexible, but for applications when it works, it's much more efficient. I move away from caches. So caches are one of the great inventions of computer science, one of the truly great inventions. The problem is, when there's low spatial and low temporal locality, caches not only don't work, they actually slow programs down. They slow them down. So we move away from that to user control local memories. What's the trade-off? Now somebody has to figure out how to map their application into a user-controlled memory structure. Cache does it automatically for you. It's very general purpose. But for certain applications, I can do a lot better by mapping those things myself. And then finally, I focus on only the amount of accuracy I need. I move from IEEE to the lower precision floating point, or from 32 and 64-bit integers to 8-bit and 16-bit integers. If that's all the accuracy I need, I can do 8 integer operations, 8-bit operations, in the same amount of time that I can do one 64-bit operation. So considerably faster. But to go along with that, I also need a domain-specific language. I need a language that'll match up to that hardware configuration. We're not going to be able to take code written in Python or C, for example, and extract the kind of information we need to map to a domain-specific architecture. We've got to rethink how we program these machines. And that's going to be high-level operations. It's going to be a vector-vector multiply, or a vector matrix multiply, or a sparse matrix organization, so that I get that high-level information that I need, and I can compile that down into the architecture. The key in doing these domain-specific languages will be to retain enough machine independence that I don't have to recode things, that a compiler can come along, take a domain-specific language, map it to maybe one architecture that's running in the cloud, maybe another architecture that's running on my smartphone. That's going to be the challenge. Ideas like TensorFlow and OpenGL are a step in this direction, but it's really a new space. We're just beginning to understand it and understand how to design in this space. You know, I built my first computer almost 50 years ago, believe it or not. I've seen a lot of revolutions in this incredible IT industry since then. The creation of the internet, the creation of the World Wide Web, the magic of the microprocessor, smartphones, personal computers. But the one I think that is really going to change our lives is the breakthrough in machine learning and artificial intelligence. This is a technology which people have worked on for 50 years, and finally, we made the breakthrough. And the basis of that breakthrough, we needed about 1 million times more computational power than we thought we needed to make the technology work. But we finally got to the point where we could apply that kind of computer power. And the one thing, this is some data that Jeff Dean and Dave Patterson and Cliff Young collected that shows there's one thing growing just as fast as Moore's Law: the number of papers being published in machine learning. It is a revolution. It's going to change our world, and I'm sure some of you saw the duplex demo the other day. I mean, in the domain of making appointments, it passes the Turing test in that domain, which is an extraordinary breakthrough. It doesn't pass it in the general terms, but it passes it in a limited domain, and that's really an indication of what's coming. So how do you think about building a domain-specific architecture to do deep neural networks? Well, this is a picture of what's inside a tensor processing unit. The point I want to make about this is, if you look at this, what uses up the silicon area, notice that it's not used for a lot of control. It's not used for a lot of caching. It's used to do things that are directly relevant to the computation. So this processor can do 256 by 256. That is 64,000 multiply accumulates, 8-bit multiply accumulates every single clock. Every single clock. So it can really crunch through, for inference things, enormous amounts of computational capability. You're not going to run general purpose C code on this. You're going to run something that's a neural network inference problem. And if you look at the performance, and you look at here, we've shown performance per watt. Again, energy being the key limitation, whether it's for your cell phone and you're doing some kind of machine learning on your cell phone, or it's in the cloud, energy is the key limitation. So what we plotted here is the performance per watt. And you see that the first generation tensor processing unit gets roughly more than 30 times the performance per watt compared to a general purpose processor. It even does considerably better than a GPU, largely by switching from floating point to lower density integer, which is much faster. So again, this notion of tailoring the architecture to the specific domain becomes really crucial. So this is a new era. In some sense, it's a return to the past. In the early days of computing, as computers were just being developed, we often had teams of people working together. We had people who were early applications experts, working with people who were doing the beginning of the software environment, building the first compilers and the first software environment, and people doing the architecture. And they were working as a vertical team. That kind of integration, where we get a design team that understands how to go from application to representation in some domain-specific language to architecture, and can think about how to rebuild machines in new ways to get this. It's an enormous opportunity, and it's a new kind of challenge for the industry to go forward. But I think there are enough interesting application domains like this where we can get incredible performance advantages by tailoring our machines in a new way. And I think if we can do that, maybe we'll free up some time to worry about another small problem, namely cybersecurity, and whether or not the hardware designers can finally help the software designers to improve the security of our system. And that would be a great problem to focus on. Thank you for your attention, and I'm happy to answer any questions you might have. Thanks. Okay, who's got
This is I/O Live, and I'm Timothy Jordan. I'm standing here with Ricardo, who's working on a really cool machine learning project that he's going to tell us about. Hi, Ricardo.
Hey, hello, hi everyone.
Could you give us an overview of the work that you're doing?
Yes, so we are working on, and we managed to close a technology to give us visibility on how a small molecule is interacting not with just a piece of your genome, the usual design, but on the entire proteome, and with the best approximation we can get. A nice assay, biological test, and this is giving us visibility that we never had before. So we are working to release a database where these small molecule interactions are going to map to all our genome. This, I think, will open up a complete new design principle of small molecules, new exciting algorithms, and better precision in therapeutics.
Awesome. Now, this is a really big problem with a really big solution. What about an everyday problem that you would love to solve with machine learning?
I think we'll be probably choosing my food. So today we get to a grocery store, to a restaurants, we pick our food mostly by use. So we are used to buy a specific kind of things and we repeat over and over again. But if I have in my calendar or my agenda, when I go to the gym, if I have meetings, I have my Fitbit or my sleeping wearable device that tells me if I slept a lot or if I'm close to 40. I love someone to solve that. We should eat this, this, and that, and remember that you have a early meeting. Don't eat too much or too late tonight, or drink some milk, or get some vitamin D in winter. Boom! I will change my life.
I would probably still sneak in some gummy bears, though.
You can totally tweak the algorithm and add a dot in the neural net, so you can pick up some sugar if you like it.
Awesome, Ricardo. Thanks so much for joining us and sharing your story.
Thanks for everyone being here. Thank you.
And thank you for watching I/O Live. Now that we've heard a little bit more about what ML is being applied to, let's go check out some of the technology behind all this machine learning research, shall we? Head on over to the ML Sandbox. Let's do that. That was awesome. Hi, and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Magnus. Magnus, how you doing?
Hi, I'm fine, Timothy. How are you?
I am really good. We're in the ML booth. It's my favorite booth.
Yep.
Don't tell the other booths that.
Of course not. It's exciting in here.
So, in this sandbox, we are looking at, right now, we're in a track, and there's cars going around.
Exactly.
What's happening here?
This is a self-driving car track. These are actually something called Donkey Car. We'll post the link later on to these things. You can build them yourself. There are full instructions on the internet. It's built on Raspberry Pi, and we put a TensorFlow Lite model on there, running Keras, and then we train them around this track, and they're capable of going around like this.
That's really cool.
Yeah, it's amazing. So Raspberry Pi was just a supported platform by TensorFlow Lite, so it's really opens up a lot of possibilities to do these kinds of things. So it's really, really exciting.
Well, and this is just so delightful. I saw them training it earlier where there's just a phone on it, and he was operating it with another phone, and then the autonomous vehicle used that model built on those driving instructions.
Exactly. So it takes images when it's going around the track, and then it's using those images to train the car so it knows where to go and also how fast to go in each of the segments of the track.
That's really cool.
Yeah.
All right, what else do we got going on in this sandbox?
So as we heard from the keynote, we just launched a new version of the TPU V3. Should we check that out?
Yes.
Cool.
Over there?
Yeah.
Let's do it. Wait a second. I think I see Zach Stone over there. Is that Zach?
That's right.
You think we can get him over here? So this is TPU V3.
That's right. This is our latest and greatest TPU. This is just a part of the TPU pod that contains many boards like this.
How many?
Enough to deliver more than 100 petaflops of compute. That's kind of hard to think about, 100 petaflops.
How do you contextualize 100 petaflops?
So it's not quite apples to apples, but some of the top supercomputers in the world are only doing, a few more than 100 petaflops. And so we use reduced precision that's appropriate for machine learning. So like I said, this is not a direct comparison, but there are very few computers in the world that can do more than that many mathematical operations per second.
That's really cool. And we were talking to Jeff yesterday. He mentioned that this is the first liquid-cooled component in our data centers.
That's right, to the best of my knowledge. This is the largest scale liquid cooling system that we've deployed here at Google.
That's exciting, and it's really pretty.
I'd love to have one of these in my living room. On my wall. All over my house, actually. That would be great.
So a little bit more background on what people are doing or will be doing with something like this soon.
Sure. Well, so today, if you look over here, that second generation system, that's a cloud TPU. Anybody with a GCP project, there's no more requesting quota, waiting in line. Anybody today can start up a cloud TPU and use one of our open source reference models for image recognition, for speech recognition, for machine translation, language modeling, even generating images from scratch, pixel by pixel. And it all runs on this amazing self-contained supercomputer here. That's 180 teraflops over there. And so that's pretty exciting. We're trying to make machine learning acceleration affordable and accessible to everybody. And then we are just relentless about pushing the envelope of performance with these new generations of hardware like you're seeing here.
Awesome, Zach. Thank you so much.
Anytime.
All right, Magnus, what's next?
Okay, cool. Let's go over and check out an object detection robot at the TF Lite stand.
I love robots. Let's do it.
So basically here we have a TensorFlow Lite model running on a Raspberry Pi. This is a very cheap and easy to find computer. And what we've done with it is we've added a servo motor, or two servo motors, that can actually point the camera in different directions. So the TensorFlow Lite model detects objects, and then it tries to center them on the screen. So it's like a virtual camera person that's able to keep things in frame as they move. So if you take the apple or the banana and you put it in the frame, it will start to actually move the camera.
So what this thing is doing is that it's presenting us with words, and then it knows related words by having been trained on a huge data set that puts those words close together. And then we use our brains to do the association, and if the answers are matching each other, then I'm successful, otherwise I'm not.
And this seems like, just fun, but what's represented there is like a dramatic reduction in the work to build something like this, because the associations are created by a model rather than a whole bunch of people working all those rules together.
Yeah, exactly. And these models, they actually exist pre-built, so you can actually reuse one in your own app. You should definitely check out a technology called TensorFlow Hub on tensorflow.org, where we have these types of models available. The classical example for this relationship is if you take Paris and then you add France and then you subtract Italy, what do you get?
Something else?
You get Rome, right?
Sure.
Exactly. And that's how we calculate the distances between these vectors. So Paris is related to France in the same way that Italy is related to Rome.
Okay.
Yeah. So I'm playing a game here, and I need to associate things with the word here and bring it down into the grain area here. As you can see, I wasn't. So school, what is association to school for you? Pupil?
Homework?
Yeah. Pupil is fine, okay, because that's nice. I took that out. Now, so what the machine learning algorithm knows, it knows about all of these associations. So garden is related to hose, shoe is related to
foot.
Foot. Yeah, good job, Timothy.
Thank you,
The
Magnus.
newspaper is, what should we do? New York Times? Whoa. Yeah, it's a newspaper, right? So I bring these words down, and eventually it's going to build up. So I got to get faster and faster at these things. Horse, riding. Okay, so let's see here. We now have hamster, hamster, fluffy. Fluffy worked, yeah. Motorcycle, fast. No, motorcycle.
Riding.
Ride. Well, yeah, that's right. Summer, winter, hot. Summer, hot.
Thanks for the tour, Magnus.
You're so welcome, Timothy.
And if you'd like to learn more about TensorFlow, head on over to tensorflow.org. If you'd like to learn more about any of our developer products, sign up at g.co/dev/form. See you next time.
Hello, IO Live. Todd Kerpelman here, and I am here with Jonathan Huey, who is a principal software engineer over at Nest. Hi, Jonathan.
Hi.
So what is this that we've got behind us here, this open thread stuff? What is that all about?
Yeah, so Thread is an open IP-based mesh networking protocol for low-power connected IoT devices. OpenThread is an open source implementation of that protocol, and it's available on GitHub. It's an open development model. Everybody can contribute, anybody in the public, not just Nest. And so what we're showing here is a bunch of devices, 10 different platforms, running OpenThread, operating in a single IPv6 mesh network, all communicating together, right? We have a Raspberry Pi in the corner that connects this to a Wi-Fi network and communicates via the cloud. All of these devices are communicating their topology information within that mesh to the cloud, and we display that on this display here, so you can see a full connected mesh network with devices here. What we're showing here is a thread sniffer. So this is a standard Wireshark. It's capturing all the traffic operating in this mesh network that is used to maintain this topology.
Cool. So if I were a developer that were looking to make a device that worked in a smart home, I could basically take any of these microprocessors here and use OpenThread as my way to make sure that my device hooks up with everything else in the home.
That's exactly right. As I mentioned, OpenThread now supports 10 different radios. And in fact, many of the silicon vendors actually provide direct customer support of OpenThread on their radios. So I would encourage you, if you're already working with a favorite silicon vendors of yours, to reach out directly to that silicon vendor and ask about OpenThread.
And what are some of the cool features about OpenThread? What makes it sort of an interesting networking protocol?
The first is that it supports IP, and which means it's the same technology that is used to connect any other internet-connected device. And that makes it really convenient. For example, when you're developing using standard Linux, you can use standard sockets APIs to communicate with your devices. But more importantly, because you're using IP, it means you can build solutions that utilize multiple link technologies, such as Wi-Fi, cellular, and Thread, with a single application layer communicating end-to-end. You do not have to have application gateways in between, which often represent a single point of failure. And with Thread, because there's no stateful application gateways, you can have multiple connections into and out of the network that makes it really resilient and have no single point of failure.
That is very cool. And I noticed there's this QR code here behind me. What does that do?
Yeah, so Thread by default requires you to have security enabled, which is actually one of the key differentiators. And because security is always enabled, you need to have a very user-friendly process of getting that device securely onto the network. And so what the QR code does is it enables a mobile app. You just turn it on, you scan the QR code, and it'll securely connect with that joining device to provide the security credentials to get that device onto the network.
I think I've used that when I've set up my own Nest devices. It makes things super convenient.
Exactly. It's very similar to what we do in Nest. In fact, the commissioning protocol was designed following the principles that we use at Nest, so it really does enable a great user experience.
Very nice. And so what is Nest doing with OpenThread?
Yeah, so if we move over here, Nest is actually enabling a number of products with OpenThread. The first is a connected deadbolt for your door. It only communicates via Thread. It's got no other connectivity technology with it. And because it's using Thread, it can actually last for years on AA batteries. And I can do a quick demo here. So if I open up my mobile app, hold down the button, we'll see the door unlock, and there it goes. And that's all happening over Thread. Of course, the mobile is communicating over Wi-Fi. It goes to a Thread border router to this battery-powered device.
Would that work if my phone were not connected to the Wi-Fi?
It would work. So, yeah. So as I mentioned, our application layer operates over any IPv6 network. So it just happens that this mobile phone is only on Wi-Fi. But if it was connected to cellular, that would work as well.
Very cool. That is very interesting. And if I were a developer and I were interested in finding out more about OpenThread to use in my products, where would I go?
Yeah, so we have a website at openthread.io. We have our source code at github.com/openthread. And you can reach us at Google Groups at openthread-users.
All right, so if you're interested in making your own cool internet-connected device that, I don't know, does something amazing that I haven't thought of yet, go ahead on over to openthread.io and check it out for yourself. Thank you very much, Jonathan.
Thank you very much.
Bye, y'all.
sitting out on the rocks. Watch the water roll, easy breezy go, till the tide gets too high. I want the sun, want the wind, want the water in my head. Don't need no one telling me sit up straight, stand over there. Wanna run, wanna fly, feel like I am everywhere. So drop it cold and away we go. I want the sun, want the wind, want the water in my head. Don't need no one telling me sit up straight, stand over there. Wanna run, wanna fly, feel like I am everywhere. So drop it cold and away we go. I want the sun. I want the sun.
Use inside of a view group, you can pull that common code out into an extension. And what this extension does is enhance a type that we don't control, the view group type. We're allowed to essentially create a member function that's not actually a member function. It actually turns into a static function in the bytecode with the functionality that we want to enhance. And so we can take our original code that had the explicit for loop in it and use this new member to create a more concise version of what we intended to do. It is actually visually distinguished from a normal member function, that it's italicized. If you use Darkula, it'll actually be yellow. But it's semantically equivalent to calling a member, or the intent is to feel semantically equivalent. And so oftentimes when you start talking about extension functions, you think, well, if this is so useful, why don't we just put the function directly on ViewGroup? Why doesn't ViewGroup just offer a for each and a for each index that takes in a lambda? And really the reason is because of the lambda. When we pass a lambda in Java 8 or in Kotlin, by default that has to create an anonymous class, which eats up methods and causes class loading. Kotlin, however, provides language functionality which allows us to eliminate that lambda's allocation. By marking the function as inline, the body of the extension gets copied into the call site, and we have a zero overhead abstraction. Let's take a look at another example. In API 23, we were able to get a system service based on a class type. And in 27.1 of the support libraries, a context compat version of this was added that allowed it to work on all API levels. We can pull this into an extension that is also inline like the previous one, but doesn't contain a lambda. What this one has that's different is something called reified. Now this is a compiler trick. And what that trick does is it forces the type information of the generic to be known at compile time so that it can be made available at runtime. And so this is what allows us to take where we would otherwise be calling class.java on Notification Manager, we can now abstract that away behind this extension. And so our calling code now becomes simplified to just be able to pass the generic. And because it's reified, we have the implementation of that has access to be able to call class.java. So if we want to update the padding of a view, just where we're only specifying 2 of the 4 parameters, in this case, we want to update both the left and the right. We have to pull out the existing padding for the top and the bottom because Android requires you to specify all 4. This is something that we can remedy, again, using an extension function. The key here is that for each of the arguments on this new function that we've defined, we're specifying a default. And that default will be used when a value is not provided for that argument. So it allows us to take the calling code where we're specifying all 4 and now specify them as just 2. But the problem here is that we've eliminated 2 of the arguments, but since we're only supplying 2, Kotlin takes that as meaning the first 2, and the latter 2 are the ones where the defaults are used. This is not what we intended. We intended to do left and right, which are the first and third. Another language feature comes to help here, which is named arguments, named parameters, rather. By specifying the name of the parameter, we're able to tell the compiler which of the two arguments we're specifying and allow it to fill in the defaults for the others. OK, Android APIs have a bunch of composite types. These are things like point, rectangle, pair, even the location class. These composite types are just wrappers around smaller individual pieces of data. In this case, I'm calling an API which has a rectangle, which is a composite around the left, top, right, and bottom values of a rectangle. And if you need to do calculations based on the values inside of these composite types, you have to pull them out into individual values or variables in order to do that calculation, and then potentially put them all back together. So with the help of the extension, we can avoid this. This one is a little bit different. We have a new keyword called an operator. An operator means that Kotlin will allow us to use a special call site syntax. And each operator function has a very specific name, a well-known name. You can't just make up any name. And the name defines which call site syntax that you're intending to create. In this case, it's called component. And component allows us to use a feature of Kotlin called destructuring. And so our original code, which had to individually pull out the 4 different components, can now use this call site syntax where the rectangle is automatically unpacked into the 4 values and assigned to 4 variables with the names that we choose. What's really nice about this is that if you don't care about ones later on, you can omit them. And if you don't care about ones in the middle, you can specify them as underscore. And so if we just need to pull out 2 of the values, we can do that very succinctly. OK, an experienced Kotlin user might know that, well, I guess we flipped through. Can we go back a slide? OK. So this is some code that shows how we can determine whether or not a string contains only digits. It basically just loops through the characters using Kotlin's for-in syntax, checks whether it's a digit using an extension function on character, and then sets a value to true or false whenever it detects a non-digit. If you're an experienced Kotlin user, you might know about the all function, which exists on string, which encapsulates the same looping and allows you to specify a predicate, which in this case is the isDigit. It's actually an inline function, so it desugars into the exact same thing we would have wrote in the previous slide. But what's interesting is that Android actually has a built-in function for this, and I suspect that a lot of people don't actually know this exists. And so this is something that we can actually take and turn into an extension, but you start to wonder, like, is this actually worth its weight in an extension? What value do we gain by turning this static method that we can call into an extension? Well, for one, it changes the way that we invoke to feel a lot more natural and idiomatic in Kotlin. Sure, but still, is there really value that we extract from this? The biggest one that I think we gain from this is that when you're in the IDE, you have your string, and you're wanting to go and determine whether or not it's, you're wanting to make this query as to whether or not it contains only digits. If you didn't know that static method on TextUtils was there, you probably would never find it. When it's extension, if you start typing in the IDE, it will actually show this extension in autocomplete, where it's much more discoverable than otherwise. So you just press enter and you get it. All right, so I covered a few extensions here. I just wanted to remind you a bit of the power of these extensions. The fact that we are leveraging language features that exist only in Kotlin, not in the Java language. And actually, some of these examples we're going to keep coming back to throughout the rest of this talk. So all of the extensions that I just showed are part of the Android KTX library that we announced in early February. There's been 2 releases since then, and as of Tuesday, it's now part of Jetpack. It's part and versioned with Jetpack. So on Tuesday, Core KTX is now 1.0 Alpha 1. It's going to be versioned and released with future Jetpack libraries. So we called this Core KTX when we launched, which was kind of a weird name. It didn't make sense. This was for extensions for types only in the framework. A lot of people suggested, can we add support library stuff? And we were very adamant about saying no. That should hopefully make a lot more sense now. But even this isn't exactly true, because Core KTX initially depended on support compat. Support compat is there to provide backwards compatibility versions of things that are in the Android framework. And so earlier I showed the example with context compat. That's something that came from support compat. And so now with the Jetpack rebranding and the Android X packages, support compat has become Core, and so now Core KTX lines up with Core. So we kind of knew what we were doing back when we started this, and now it's only starting to pay off. Along with the other Jetpack libraries, there's actually a few new KTX libraries that are launching with it. So we have ones for Fragment, Collection, SQLite. For the newer components, navigation and work runtime. I'm going to touch on how you can discover these a bit later, but I want to talk a bit about scoping, about how we determine whether or not something should go into one of these libraries. All right, so in Core KTX 0.3, we offered an extension that looks like this. If you look at its signature, it's an operator, and it operates on color, and the name is plus. So this allows us to use the normal plus syntax for compositing 2 colors together. So the signature, it's definitely an extension. But the body of this looks very different than the other extensions we looked at. There's a significant amount of code in here. If you look inside support compat, which is now Core, there is a color utilities class. And that color utilities class has a method called composite colors that works on integer colors. It allows you to take a foreground and a background and turn them into a single color. So this is a perfect candidate for placing the implementation of what that extension function was into this class so that everyone can use it, so that it can be used from the Java language or the Kotlin language. And so in Core KTX 1.0, this actually has been rewritten to just delegate to that color utils. So the Java language users get that functionality, but the Kotlin users get the enhanced syntax. And if you look at the extensions that we talked about so far, the bodies of them, the implementation of these functions, they're all trivial. They're exceedingly trivial, and that's by design. And this gets me into covering some of the principles that we want to that we define that KTX extensions should have. And so this first one is that we want to adapt functionality that already exists. And if we want to add any new features, those should be redirected upstream to a place where they're language agnostic, where both languages can take advantage of them. Other examples of this was there was some HTML compat stuff and a path iterator that were implemented first in Core KTX that have since moved upstream into Core to be able to be used in both languages. Another thing that's common to all these extensions is that they're marked as inline. The reason that we do inline on the first one, the one at the top, is that we want to avoid the lambda allocation. For the second one, because we're using reified generics, we're actually forced to use inline by the compiler. The third, the component ones, and the very bottom one are all inline, mostly because they're just aliases to what you would otherwise write if the extension didn't exist. If we look at an example of something that's not inline in Core KTX, we have this iterator extension to ViewGroup, which allows us to use Kotlin's for-in syntax to iterate over the views in a view group. This is not inline for a very specific reason, and that is because it defines, the implementation of this function defines an anonymous class. If we were to inline this, that means that every time you use it, an anonymous class would be defined at your call site. And so this would increase your deck size, method count, and class loading. We explicitly make this not inline because we want that single implementation to be reused by all of the callers. So we default to an extension being inline unless there are allocation reasons. And I should note that this is really only for KTX-style extensions. In normal Kotlin code, this is not a good recommendation. You don't want to default to inline because it has the potential to lead to actually having a negative effect on your code rather than a positive one. All right, so earlier when we showed this extension, I talked about how the inline modifier coupled with the fact that there's a lambda allows this extension to be a zero overhead abstraction. In the reified case, we get the ability to have a more declarative version of the lookup at the call site without having to specify the : class.java. For updating the padding, we get to use default values to not have to specify each of the arguments, and name parameters to specify which subset of arguments we want to actually provide. For the destructuring case, we get the fancy syntax that allows us to pull apart the component variables out of a composite object. This is useful. This is enabled by the fact that we have operator overloading in Kotlin. We also talked about how we were able to add the plus for color. For this one, we're aliasing an extension to a static method, and this is just to help improve discoverability for built-in helpers that you might otherwise not know exist. And then for types that are collection-like but not actually collections, we have the ability to turn them into pseudo-collections where we can use the affordances of the language as if they were actual collections. And so each one of those has a very Kotlin-specific language feature that it uses. And we want to make sure that all of these extensions that we're defining leverage some feature of the Kotlin language that doesn't otherwise exist for Java callers. We want to resist trying to fix an API just by creating extensions for it, but rather enhance it to become more pleasant to use by leveraging these Kotlin-specific features. OK, one of the suggestions we get quite frequently is to take something like setOnClickListener and write an extension which allows you to call it using something like click or onClick. This allows the calling code to, instead of having to call setOnClickListener, we get the shorter version of click. Are we leveraging a feature of the language here? Well, we're leveraging extension functions, but not really. We're really just creating a shorter alias. What value are we extracting from this extension? Well, we're typing a few less characters, but really it's all auto-completed anyway. But even worse, what precedent will we be setting here by adding this extension? Are we going to do this for every listener? And so this is a great example of something we explicitly do not want to do in the KTX libraries. If you're not familiar with the term, we call this code gulf, where you have a desire to create the shortest code possible. This is something we do not want to do. We're not here to just make the code shorter. OK, there's another one that gets suggested every now and then and that I've seen people using. With Android, because of the different API levels we have to support, you very frequently see these if checks around the SDK int. So it can be tempting to pull this out into an extension where you have a little bit more declarative version of this. We move the comparison into an extension function. It's an inline function, so we don't have the overhead. The lambda is the last parameter, so we get the nice Kotlin call site syntax. And it turns our if statement from this into this. Now, this by itself is not too terrible. We're really not leveraging any of the language features again, similar to the last one. It's still kind of an alias, but at least this one you can argue a little bit more for its merits. But there's a problem. While these two statements are equivalent, what happens when, for one thing is that you can at least static import SDK in, and then they're a little bit closer. So that's one reason why this is less justified. But one thing is that an if statement is a very primitive construct of a programming language. And because an if statement is not just an if statement, there's constructs like else. So what if your requirements change such that you need to alter the behavior on these two different versions? Well, if you were using this extension that you wrote, in order to support this case, you either have to change back to using an if statement, or you have to modify the function where maybe it takes two lambdas now, one for the case where you're above 19, one for the case where you're not. Because we're now taking two lambdas in this function, we've lost the special trailing lambda syntax where we now have to pass them as arguments inside the parentheses, whereas before we didn't. So immediately this extension starts falling apart. If we introduce another conditional branch, maybe we need to vary the behavior across APIs in 3 different ways. Well, there's really no way that we can make the extension do this. The other thing that is different about this extension compared to the if statement is that we're assuming the conditional that we want to check is greater than or equal to. That the behavior we want to run in the lambda, we only want to run on 19 plus. Well, a lot of times some of the if statements, again, SDK int, will be less than or equal to. And so now we need a second extension in order to support that use case. So this is another example of something that we're not looking to do. We don't want to optimize for just a single use case or a specific use case where the extension only supports one way of doing something, and then when you need to move to something more complex, you have to revert to the original behavior. We want the extensions to allow you to express everything you would need to express if it didn't exist. OK, so all the extensions we've been talking about thus far have been ones that are in the core KTX library. I don't want to go through a ton of the extensions that are in these other libraries. Again, I'm going to show you how you can discover them in a bit. But I want to touch on one. So for the fragment KTX, we have an extension which encapsulates transactions. We move the begin transaction and the commit function calls into an extension. We use the fact that we can use an inline function and a lambda again to turn this into a zero overhead thing. Our calling code then becomes a little bit shorter, where we now use the transaction with a lambda body. So if you've used fragments, you'll know that commit is not the only commit function. There's actually more than one. And so we can model this by doing something like allowing you to supply a Boolean as to whether or not you want to allow state loss or disallow state loss when you're committing. This is really easy to accommodate. But it sort of goes against something I said earlier where, and we can update our call site to be able to use this. It sort of goes against something I said earlier, though, where I talked about minimizing the impact of the implementation of these extensions. Since this is an inline function, and then we've now put a conditional inside that inline function, that conditional is being inlined into all of the call sites. And so all the call sites now have to have that conditional inside of them. So is this actually a bad thing? Well, if we look at the bytecode that gets generated from the call site when we specify allow state loss true, you don't really have to understand bytecode to understand what's going on here. There's essentially 3 function calls. The first one is begin transaction. The second one is that replace, which was inside the Lambda. And the third one is just a call to commit allowing state loss. There's no if statement here. There's no conditional. And that's because since this is an inline function, and since the argument is a Boolean, the compiler actually knows at compile time what value you're supplying. And so since it knows at compile time, it can actually do dead code elimination and eliminate the branches that can never possibly be executed. And so you actually get, in bytecode, what's equivalent to what you otherwise would have written. There's actually more commit functions. There's one which allow you to commit now and commit, so we can also support that by adding an additional Boolean. And the same thing happens here, even though they're now nested. Dead code elimination will make it so that there is only one function call in the resulting bytecode. OK, as part of this effort of all these releases at I/O, one of the things that we've done is start creating a Kotlin-specific view of the libraries that we publish and the Android framework itself. So if you see in that blue box there, when you visit the reference docs, it'll actually show you that it'll ask you if you want to view a Kotlin-specific version of the platform or Android X libraries. And also, if you scroll down in that left navigation pane, at the very bottom, we have links to them as well. And what these are a Kotlin view of these libraries. And so when you're browsing through, say, the Fragment package, you'll be able to see the extensions for Fragment inside the documentation. It's no longer completely separate. One thing that's missing right now is that we don't actually tell you the Maven coordinates of the artifact that these come from. That's coming soon. And also the extensions in core KTX, which extend the platform types, don't yet show up on the platform docs. But this is something that we wanted to get out to show you that it's being worked on. And so hopefully those two things will be coming soon. All right, I want to touch on, I'm here to talk about Android KTX, but Kotlin extensions, there's nothing Android specific about it. What we're doing is building extensions to try and make these libraries more Kotlin friendly. And that's something that any library can do. And so I want to talk about the ways that we think about how we can make libraries more Kotlin friendly that apply to both the Android libraries, but also apply to libraries that you might be writing or you might be using. The first way to make a library really Kotlin friendly is just rewrite the whole thing in Kotlin. I mean, obviously this isn't feasible for every library, but it's certainly an option for some. If it's a library that's private to your app, it's in your repository or it's internal to your company, and you're already using Kotlin, this is a viable option. Doesn't seem like something that's totally viable for, say, the Android framework, and I'm not quite sure we're at the stage where an Android X library could do this. Maybe a future Android X library could be written in Kotlin. That seems like a strong possibility. What we've chosen to do with most of the things that we publish is sibling artifacts. So the main library remains written using Java language, and we ship Kotlin language features as a sibling artifact. What's great about this is you don't force the Kotlin standard library onto your consumers unless they explicitly want it. You can curate the extensions to be exactly what's needed to augment your API. You can do that either in your own app, or you can publish a set of extensions for a library that someone else publishes. But is this the only, are these the only two options? I want to take a look at something that I think will lead into a third, somewhat hybrid option. And I'm going to go back to this simple alias extension where we've taken the static method defined in the Java language and turned it into an extension method in the Kotlin language. If we look at the implementation of this class on the Java side, I've included the first line, because we can see that it immediately dereferences the argument that we pass in. As soon as we pass in a string, it says, what's the maximum number of characters that I can iterate over in order to determine whether or not there are digits. And so if you've been using Kotlin with Java APIs, you might know that this means that the parameter is going to be exposed as what's called a platform type. It has unknown nullability. But from the implementation, we know right away that this method simply cannot accept null values. And the way that we would fix this is by adding the non-null annotation. And so what this annotation does is it informs the Kotlin compiler that there's a restriction, that there's special behavior that it needs to take into account, where it needs to enforce that no one passes a potentially nullable value or null into this method. And so this is enabling a language feature in Kotlin that simply doesn't exist in Java. Now, you can use tools that will allow this enforcement to work for Java, but it's not intrinsic to the language itself. So if we can do something like that for nullness, if we can add this annotation for nullness to inform the Kotlin compiler that it needs to change its behavior when we invoke this method, can we do this for something else? Say, I want to take this static method where the first argument is really the receiver, and can I say that this is actually going to be an extension function when invoked from Kotlin? And what this allows us to do, potentially, is eliminate the need to have this explicitly defined extension at all, right? This extension only exists to change the calling convention, to inform the compiler that we want to allow you to call it in a different way. And so now we're left with just this. The Kotlin compiler sees that annotation, just like it saw the non-null annotation, infers something from it, and allows you to call it in a way that's more idiomatic for that language. In the bytecode, we get what we otherwise would have written, right? We still get the call to the static method, and the receiver becomes the first argument. How about this example? One thing you might have noticed is that this extension is named update padding, not set padding. Now, we can actually call this extension set padding. But the problem is that it will only work for a subset of arguments. So in this case, where we're just passing left and right values, we could call that set padding and it would work fine. But if we passed left, right, and then top, bottom, we'd be supplying 4 arguments. And the Kotlin compiler is going to see that the real set padding also accepts 4 arguments, and it's going to prefer calling the real one. And the real one doesn't have named parameters, so you're going to get a compilation error. That's the reason we have to name this update padding. If we look at the real set padding, simple method that takes 4 integers, what if we could inform the Kotlin compiler that these parameters have names associated with them? Now, it would be nice to infer this just from the parameter names directly, not have to specify the redundancy. But I'll argue that, for one, it's very nice being explicit about these names in the annotation. In Java 8 bytecode, there actually is a way for you to supply, to retain parameter names. So the Kotlin compiler could, in theory, use those. But one problem is that then it becomes an all or nothing thing. You have to opt into this behavior, and then suddenly every parameter name across your library is set in stone. Whereas with annotations, it's something that you could incrementally migrate. So this has the potential to solve the naming part, where now we can call the real method from Kotlin and specify the 4 arguments in any order that we want based on what names we provide. How about the default value? What if we could pass in, what if we could specify an expression, a Kotlin expression, which allowed the compiler to supply a default when one wasn't supplied for you, by you? This would change our original extension calling convention from calling our extension to actually just using the real method. And then in the bytecode, we get the thing that we started with, the thing that our explicit extension would inline to, but now the extension doesn't have to exist. The metadata that we added in the form of annotations informed the Kotlin compiler that we wanted to enhance our ability to call this function in a Kotlin-specific way, leveraging the Kotlin features. And so we're able to do so. This is something, so Kotlin has this process, which is called keep. It's Kotlin evolution and enhancement process. And just this morning, we proposed these annotations as keep 110. So this is something we're proposing to add to the Kotlin compiler so that it can understand these annotations. We have extension function and extension property, which are for static methods. Default value, which allows supplying default values for parameters. And then KT name, which allows you to provide an alternate name for methods, fields, or parameters. Now, it's very important to note that this is extremely early. These names might change. The semantics might change. This may never actually be accepted into the Kotlin compiler. We have been working with the JetBrains team for quite a while on this, and it's actually already, some of this is already prototyped inside the Kotlin compiler. We really think this would be a way that we could enhance the Android framework for Kotlin callers without actually having to go and rewrite the Android framework, or at least its API, in Kotlin, which is really not feasible. And it's also important to note that while this is an option, assuming that it actually makes it into the Kotlin compiler, it doesn't totally solve every problem that our existing extensions are solving. We determined these annotations that we proposed in Keep 110 through looking through a bunch of open source libraries, looking through our own libraries, and seeing what we thought would be the most useful extensions, what the pattern of Java methods were, such that they would want to be turned into extensions. And so the latter two really are complementary. The big advantages of the annotations is that you retain the single source of truth. You don't have to really know Kotlin. You don't have to add Kotlin compiler to your build system. You don't have to publish sibling artifacts. Even if you're a pure Java library, you can add these annotations and just enhance your API so that Kotlin callers get the more idiomatic syntax. All right, so to sum up, Core KTX is now part of Android Jetpack, versioned with Android Jetpack, released with Android Jetpack. There's a few new artifacts, as you can see here on the screen. There's definitely more coming. Notable ones that we think are missing are slices and view model. So I would not be surprised to see artifacts for those in the coming months. Please check out the Kotlin version of the reference document. The reference. This is extremely early. This required changes in DACA and how we produce docs, and so it's something we just wanted to get out there and show you as a preview. This is definitely something that's being actively worked on. There's a new component on the Android bug tracker for Android KTX. Because Core KTX and all the KTX libraries are now part of Jetpack, the source of truth has moved into the Android support repository. We're going to be migrating the GitHub issues on the GitHub project over to this bug tracker in the coming weeks. But it's important to note that we're still going to be accepting pull requests to the GitHub repo and syncing things back out to the GitHub repo. It's just that the issues will no longer be the source of truth on GitHub. It will be on the Android bug tracker. The keep was proposed. I created the pull request about an hour ago. Please go check that out. The document contains a lot more detail about examples. And like I said, the annotations that were chosen are the ones that we think have the most impact. But at the bottom of the document, you'll see that there's, if something like this gets accepted, there's a potential for future enhancement of even more. The link to that should be this. I made this link last night before I submitted it, so hopefully it's accurate. And that's it. Thank you.
Anything else finally for battery?
How about that battery? Well, we are all power users, unfortunately, which means we need to keep working on things that we can do at a platform level to preserve battery for users to get longer battery life. A couple of the things that are interesting that are going on in this release includes app standby buckets. So we determine the level of activity that a user has with an application, and based on that activity level, we expose capabilities of the platform to that application or not. It may not be appropriate for an application that the user hasn't actually run for a while to be taking up CPU and battery, doing this thing in the background that probably the user didn't want them to be doing. So that's one thing. Another is background restrictions. So if we notice that applications have bad behavior characteristics, things like holding wake locks for a very long period, which means the system can't go to sleep, or waking up frequently, or using services when they're not on power that they shouldn't be as frequently as they are, then they'll be propagated into a list that the user can see through settings and then disable background capabilities for that app to make sure that the user has control of how much battery is being used.
Okay, cool. So we covered slices, battery, anything else exciting in P?
Well, there's exciting and there's necessary. One of the necessary things that's there is that we're preventing applications from calling private APIs. It is possible now to call APIs which are not in the public platform, but through Reflection or JNI, you can get to these methods anyway, and we allow that because we didn't have a way to really stop that. You can sort of query this and go for it. Well, now in the ART runtime, we can detect that you are calling these methods from an application when they shouldn't be, and we can prevent that. So in the preview release, which we encourage everybody to pick up and play with, we have these methods in a light gray or dark gray list, which means that you're going to get either a warning in the log or a toast popping up on the screen. So if your application is calling these and shouldn't be, you're going to get a warning about it. But when that release comes out, it'll be on a blacklist, and we'll simply stop it from being called. So the call to action would be, go run with the preview release for Key and make sure that your application is safe from these. And if it's not, then either fix your application, or if it is some facility that you absolutely need, then maybe it's something that we can work on and we can put it on a whitelist instead, but you need to tell us that information, which is why we have the preview, so give us that feedback.
Okay, great. There's this Android there, no?
That's a totally different topic. I think we need to talk about text.
Yeah,
Because
what about text?
Text happened in my larger toolkit team, so I understand that. In fact, you understand that. I want to ask you about text. So what happened in text?
So in text, we released a few new APIs. Now you can pre-measure text. So this means that you can move all of that measuring work that takes quite a lot of time from rendering a character to a background thread.
And why is that helpful?
Well, because then the text is displayed faster. So faster rendering means less frames skipped.
Sure. So it's also good because if it's time for you to display the text and then you have to measure it, it's not very helpful, but a lot of times you know ahead of time when you're going to need that, so you can actually ahead of time shove it off to a background thread so that by the time you need it, then you can display the text, which is awesome. What else we got?
We added a new feature for the user, the magnifier.
Yep.
And we also added an API for that. So we now have 3 methods, magnifier, show, update, and I think dismiss. And this means that if you're developing your own custom views that also display text, you can also show that magnifier in your custom view.
Also, it's not limited to text. That's the cool thing, is we are using it for text because we wanted to make it easier for people to manipulate the cursor. But you can use it for whatever you want. If you need a zoomed in view, that API is general purpose.
Okay, that's great. And I think we also added some more improvements on Smart Linkify. Do you know more about that?
I do. Smart Linkify is like Linkify, except it's smarter. So we already have the ability to create links in a block of text for you if we detect things like phone numbers and addresses. That's been there forever. But now through machine learning models that we have on the system, which are used for things like smart text selection, we can detect more complex entities there. Like you may select a word which is part of a larger phrase, which we detect because of this entity detection in the model. You can ask Linkify to detect those as entity links as well.
Can I now go back to this? Because it feels like it's looking over our shoulder.
Yes. Okay.
So what's with the Android with a jetpack?
Well, that would be Android Jetpack. So Android Jetpack is a set of components as well as architectural guidance for helping developers build better Android applications. I would say all Android developers are familiar with a lot of what is in Android Jetpack already, because we have taken all the goodness of support library and put it under this banner, and we are going to continue to add to that, specifically with the intent of making Android development better and easier. So I'll give you some examples. One of the big ones, one of my favorite things about support library is AppCompat and the way that we baked in the releases for certain APIs into the package names. So now we have package names like V4 and V9 with some of the APIs. We don't even support those releases anymore. So I think all of the existing developers don't even think about it. That's just noise at the top of their file, right? It's one of those imports they never look at. But I think if you're new to Android, or if you're looking at the documentation, I think it's terribly confusing. So we're doing a major refactor where we turn all those package names into Android X dot whatever to be a little more sensible. Major effort. It will require refactoring on our side, a lot of it, but also on developers' sides, but we're giving tools in Android Studio to help with that. The other part of it is the existing architecture components are a big piece of it, things like lifecycle support and Room, view model. All of that stuff is good. Also the new paging library, which went 1.0 this week, paging in Recycler View. And we have two new things. Actually, they're to our sides here at the demo table. We have Navigation Controller and we have Work Manager. Navigation Controller makes it easier to create the links of the flow of your application. It makes things like up versus back easier. And we also have a tool in Android Studio where you can visualize this and create those links. So it's sort of an integration of the APIs as well as the tool for making this complex application flow a lot easier to develop. And then Work Manager is about an easier way for creating and executing background tasks. So before we would recommend, well, Job Scheduler is really good for scheduling things at particular times, you know, when Wi-Fi is there, when you're charging, whatever. And that works really well if you're on KitKat and above. What if you're on an earlier release? Well, we also have Job Dispatcher, which is in the Play Services APIs. Well, what if you're on a device that doesn't have Play Services? Well, then you're probably rolling your own solution. So applications would need to do all three of these. Work Manager is an attempt to have a simpler, more elegant, fluent API for doing all this stuff that handles all of that for you.
Great, so lots of new things, both in Android, but also with Jetpack. So check out all the videos that we have from Google I/O, and also check out the documentation on developer.android.com. Thank you, Chet.
Thank you, Florino.
Android Jetpack is here to accelerate Android development by facilitating a modern app architecture, eliminating boilerplate code, simplifying complex tasks, and providing robust backwards compatibility.
Jetpack consists of architectural guidance supported by a set of libraries and tools in 4 key areas of Android development: architecture, UI, behavior, and foundation. Each Jetpack component is individually adoptable, but are built to work well together.
Jetpack builds on the popular architecture components we introduced last year. These components facilitate a highly testable, robust app architecture while individually addressing developer pain points, such as lifecycle management or data persistence. We've also added 3 new architecture components: Paging, Navigation, and Work Manager. Paging facilitates gradual, on-demand data loading from a local or network data source, allowing apps to work with large datasets, including support for Recycler View.
Navigation provides a framework to build app flows that comply with Android design guidelines, with proper behavior for up and back buttons, support for deep linking, automated fragment transactions, support for the overflow menu, navigation drawer, and bottom navigation. This is combined with a powerful graphical editor included in Android Studio to allow you to visualize, design, and test app navigation graphs.
Work Manager makes it easy to schedule one-off or periodic asynchronous tasks. Tasks can execute in order, in parallel, or in even more complex configurations. It's also easy to query for the state of tasks and to provide constraints, such as requiring unmetered network or charging. Perhaps most importantly, Work Manager takes care of compatibility issues, so you know that no matter what platform the user is on, tasks are scheduled efficiently and with system-wide health in mind.
UI components like animation, transitions, layouts such as constraint layout, text, emoji, and fragments, along with the TV leanback library, the Where UI library, and the Auto library are now part of Jetpack.
Behavior includes support for evolving Android areas such as notifications, permissions, and sharing. Jetpack adds support for slices, which allow your app to expose templatized pieces of itself to integrate with other apps, such as Google Search and Assistant.
Foundation includes AppCompat, libraries for automated testing, and new Android KTX Kotlin extensions, which make Android development with Kotlin more concise, idiomatic, and modern.
And we're just getting started with Android Jetpack. We have a roadmap of useful libraries and tools in development to help your Android projects take flight. To get started, check out developers.android.com/jetpack.
It's a whole new world. It's a whole new world. It's a whole new world. It's a whole new. Can you feel it getting better all the time? Can you feel it getting better? Can you feel it getting better all the time?
Hi everyone! Hello! Welcome to this TensorFlow session about reinforcement learning. So this is Johan, I'm Martin, and today we would like to build a neural network with you. Do you know about neural networks? If I say, a serious question, if I say softmax or cross entropy, raise your hand if you know what that is. Like half the audience. Okay, very quick primer. This is a neural network, okay? Layers of neurons. Those neurons, they always do the same thing. They do a weighted sum of all of their inputs. And then you can layer them in layers. The neurons in the first layer, they do a weighted sum of, let's say, pixels, if we are analyzing images. The neurons in the second layer will be doing weighted sums of outputs from the first layer. And if you are building a classifier, let's say here probably you want to classify those little square images into airplanes and non-airplanes, you will end up on a last layer which has as many neurons as you have classes. And if those weights are configured correctly, we'll get to that, then one of those neurons will have a strong output on certain images and tell you this is an airplane, or the other one will have a strong output and it will tell you, no, this is not an airplane. Okay? There is one more thing in this, there are activation functions. So a little bit more details about what a neuron does. For those who like it, you have the full, right here. You have the full transfer function here. So you see it's a weighted sum plus something called a bias. That's just an additional degree of freedom. And then you feed this through an activation function. And in neural networks, that is always a non-linear function. And to simplify for us here, only two activation functions that count. So for all the intermediate layers, the white layers, ReLU. That's the simplest function you can imagine. You have it on the graphic, okay? Just this. It's non-linear. We love it. Everyone uses that. Let's not go any further. On the last layer, though, if you are building a classifier, typically what you use is the softmax activation function, and that is an exponential followed by a normalization. So here I have a different classifier that classifies in 10 classes, and you have your weighted sums coming out of your 10 final neurons. And what you do in softmax is that you elevate all of them to the exponential, and then you compute the norm of that vector of 10 elements, and you divide everything by its norm. The effect of that, since exponential is a very steeply increasing function, is that it will pull the winner apart. I made a little animation to show you, like this. This is after softmax, this is before softmax. So you see much clearer which of those neurons is indicating the winning class. Okay? That's why it's called softmax. It pulls the winner apart like a max, but it doesn't completely destroy the rest of the information. That's why it's a soft version of max. Okay, so just those two activation functions. With that, we can build the stuff we want to build. So now, coming out of our neural network, we have our, let's say here, 10 final neurons producing values which have been normalized between 0 and 1. We can say those values are probabilities, okay? The probability of this image being in this class. How are we going to determine the weights in those weighted sums? Initially, it's all just, random. So initially, our network doesn't do anything actually so useful. We do this through supervised learning. So you provide images which you have labeled beforehand. You know what they are. And on those images, your network is going to output this set of probabilities.
but you know what the correct answer is because you are doing supervised learning. So you will encode your correct answer in a format that looks like what the network is producing. It's the simplest encoding you can think of. It's called one-hot encoding. And basically, it's a bunch of zeros with just one 1 in the middle at the index of the class you want. So here to represent the 6, I have a vector of zeros with a 1 in the 6th position. And now, those vectors look very similar. I can compute the distance between them. And the people who studied this in a classifier, they tell us, don't use any distance, use the cross-entropy distance. Why? I don't know. They are smarter than me. I just follow. And the cross-entropy distance is computed like this. So you multiply element by element, the elements of the vector, the known answer from the top, by the logarithm of the probabilities you got from your neural network. And you then sum that up across the vector. This is the distance between what the network has predicted and the correct answer. That's what you want if you want to train a neural network. You get this, it's called an error function or a loss function. From there on, TensorFlow can take over and do the training for you. You just need an error function. So in a nutshell, those are the ingredients in our pot that I want you to be aware of. You have neurons. The neurons do weighted sums. You have only 2 activation functions that you can use, either the ReLU activation function on intermediate layers, or if you build a classifier on the last layer, softmax. And the error function that we are going to use is the cross-entropy error function that I had on the previous slide. OK? All good on this? Bit of code. This is how you would write it in TensorFlow. So there is a high-level API in TensorFlow called Layers, where you can instantiate an entire layer at once. You see, I instantiate the first layer. Here has 200 neurons and is activated by the ReLU activation function. It's this layer here. And this also instantiates the weights and biases for this layer in the background. You don't see that. It's in the background. I have a second layer here, which is this one is just 20 neurons. Again, ReLU activation function. And this I need to do this little final layer. So it's a dense layer again with 2 neurons. And even if you don't see it on the screen, it is activated by softmax, but you don't see it because I use its output in the cross-entropy function, which has softmax built in. So it is a softmax layer. It's just that you don't see written softmax in the code. Finally, this here is my error function, which is the distance between the correct answer here, one-hot encoded, and the output from my neural network. Once I have that, I can give it to TensorFlow, pick an optimizer, ask it to optimize this loss, and the magic will happen. So what is this magic? TensorFlow will take this error function, differentiate it relatively to all the weights and all the biases, all the trainable variables in the system, and that gives it something that is mathematically called a gradient. And by following this gradient, it can figure out how to adjust the weights and biases in the neural network in a way that makes this error smaller, that makes the difference between what the network predicts and what we know to be true smaller. That's supervised learning. So that was the primer. Now, what do we want to build? Today, we would like with you to build a neural network that plays the game of Pong. But just from the pixels of the game. It's notoriously difficult to explain to a computer the rules of a game and the strategies and all that. So we want to do away of all that and just give it the pixels and find some learning algorithm that will, where it will learn to play this game. And of course, that is not the goal in itself, because figuring out how to program a pedal to win Pong is super easy. You just always stay in front of the ball, you know, and you win all the time. And actually, we will train again such a computer-controlled agent. The goal here is to explore learning algorithms, because this has applications, hopefully, way beyond Pong. So this looks like a classifier. We just learned how to build a classifier. You know, we have the pixels, we will build a neural network, and it has 3 possible outcomes. This is a position in which you want to go up, stay still, or you want to go down. Okay, let's try to do this by the book in a classifier. So we have a single intermediate layer of neurons, activated with ReLU, of course, and then a last layer where there's 3 neurons activated by softmax. We use the cross entropy loss, so you have the function here. It's the distance between the probabilities that this policy network, it's called a policy network, predicts, probability of going up, still, or going down, and the correct move. But what is the correct move? I don't know. Do you know, Johan?
No, Martin. You're exactly right here. Unlike in the supervised learning problem, we actually don't know what's the correct move to play here. However, the environment requires that we keep making moves of going up or staying still or moving down to progress the game. And so what we're going to do is we're going to sample the move, which means picking one of the 3 possible moves of moving the pedal up, staying still, or going down randomly. But not completely randomly, though. We're going to pick the move based on the output of the network. So for example, if the network says the output probability of going up is 0.8, then we should make it so that there's 80% of chance we choose to move up as our next move.
All right, so now we know how to play the game. The policy network gives us probabilities. We roll a loaded dice and pick from that, and we know what next move to play. But initially, this network is initialized with random weights. So it will be playing random moves. How does that inform us about the correct move to play? I need to put the correct move in my formula.
That's right. So in this case, we really want the correct move to mean moves that will lead to winning.
Yeah.
We don't know that until somebody has scored a point. And so that's what we're going to do. Only when someone, either our pedal or the opponent pedal, has scored the point, do we know we have played well or not. So whenever somebody scores, we're going to give ourselves a reward. If our pedal scores the point, we'll give ourselves a +1 reward point. And if the opponent pedal scores, then we give ourselves a -1 reward point. And then we're going to structure our loss function slightly differently than before. Over here,
once again,
over here you see a loss function very much like the cross entropy function we saw before. Now in the middle here is the main difference, where instead of the correct label in the supervised learning problem, we're just going to put the sampled move in there.
So the move we played.
The move that we happen to play. And well, some of the moves might not be really moves that will help us. And so that's why every loss value is multiplied by the reward out front. This way, moves that eventually lead to a winning point will get encouraged, and moves that lead to a losing point will be discouraged over time.
Okay, so you do this for every move. I can see how with this little modification, it could lead to some learning, but putting back my mathematician's hat on, I see a big problem here. You have this sampled move. That is a picking operation, a sampling operation. You pick 1 out of 3. That is not differentiable. And to apply, you know, the minimization and gradient descent and all that, the loss function must be differentiable.
You're right, Martin. Asking a hard question here. The sample move here, it actually does depend on the model's weights and biases, but the sampling operation is not differentiable. And so we're not going to differentiate that. Instead, we're going to look at the sampled moves as if they are constants. And then we play many games across many moves to get a lot of data, treating all of these sampled moves as if they are constant labels. And only differentiating the probabilities that are output by the model in blue here on the screen. And those probabilities directly depend on the model's weights and biases, and we can differentiate those with respect to the weights and biases. This way, we still get a valid gradient, and we can apply gradient descent techniques.
Oh, okay, so you kind of cheated The part that is problematic, just regard it as constant. You're going to play many games with the same neural network, accumulate those played moves, accumulate those rewards. Whenever you know that you scored a point, you accumulate those rewards, and then you plug that in, and you only differentiate relatively to the predicted probabilities. And yes, you're right. That still gives you a gradient that depends on weights and biases, so we should be able to do that. OK, I get it. This is clever. So this will actually train, probably very slowly. Here we want to show you the minimum amount of stuff you need to do to get it to train. But in the minimal amount, there are still two little improvements that you always want to do. The first one is to discount the rewards. So probably if you lost a point, you did something wrong in the 3, 5, 7, 10 moves right before you lost that point. And probably before that, you bounced the ball correctly a couple of times, and that was correct. You don't want to discourage that. So it's customary to discount the rewards through time, backwards through time, with some exponential discount factor, so that the moves you played closest to the scoring point are the ones that count the most. So you see here we discounted them with a factor of 1/2, for instance. And then there is this normalization step. So what is that?
Yeah, that's very interesting. So in experiments that we noticed, putting in the normalization step really helped training to make learning faster. There are probably multiple ways to think about this. The way I like to think about this is in the context of playing a game. You see, at the beginning of the time, the model only had randomized weights and biases, so it's going to make random moves. So most of the time, it's not going to make the right move. Only once in a while, it's going to score a point, but that's really by chance, by accident. And most of the time, it's going to lose points. And we really want to find a way to naturally put more weights to the very rare winning moves there, so that I can learn what are the correct moves. And performing this normalizing the reward step here naturally gives a very nice boost to the rare winning moves, so it does not get lost in a ton of losing moves.
OK, so let's go. Let's train this. We need to play the game and accumulate enough data to compute everything that we need for this function here. OK? So those are the sampled moves, we need the rewards, and we also need those probabilities, which the network can compute from us from the pixels. So we are going to collect the pixels during gameplay. That's how our collected data set looks like. Okay? You have one column with the move you actually played, one column where you would like to see the probabilities predicted at that point, but you will actually going to store just the game board and run the network to get the probabilities, and a last column with the rewards. You see there is a +1 or -1 reward on every move that scored a point, and on all the other moves, you discount that reward backwards in time with some exponential discount. So that's what we want to and once you have this, maybe you notice in the formula, you just multiply those 3 columns together and sum all of that. That's our loss. That's how the loss is computed. Let's build it. You implemented this demo, so can you walk us through the code?
Let's do that. So up here, you see a few TensorFlow placeholders. You should really think of them as function arguments that are required to compute output values for a model. And so with 3 placeholders for the input, 1 for the observation. And remember, this really means the difference between 2 consecutive frames during a gameplay. And the action...
Oh, yes, because we didn't say that actually. Just in the game of Pong, you don't really train from the pixels because you don't see the direction of the ball from just the pixels.
Exactly.
But you train from the delta between 2 frames, because there you see the direction of the ball. That's the only wrinkle we are doing here, which is specific to Pong. All the rest is reinforcement learning, vanilla reinforcement learning that applies to many other problems.
That's right.
Yeah.
And for the actions placeholder, it's just going to hold all the sampled the moves that the model happened to decide to play. And the rewards placeholder will collect all the discounted rewards. Now, with those as inputs, we're ready to build a model. The network is really simple. It's like the one Martin showed before. It has a single dense layer, a single dense hidden layer with the activation of the ReLU function, 200 neurons, followed by a softmax layer. You don't really see calling a softmax function here. And that's really because the next step, the sampling operation, already takes in logits, which is the values you get before you call softmax function. And it can perform multinomial sampling, which just means you will output a random number of 0, 1, or 2 for the 3 classes that we need output based on the probability specified by the logits.
And this one has the softmax built in. So
already built in internally.
So this is a softmax layer, okay?
Right.
You don't see it on the code, but it is. Okay, and just a parenthesis for those not familiar with TensorFlow. TensorFlow builds a graph of operations in memory. So that's why out of multinomial we get an operation, and then we will have an additional step to run it and actually get those predictions out. And placeholders are the data you need to put in when you actually run a node to be able to get a numerical result out. Okay, so we have everything we need to play the game. Still nothing to train. So let's do the training part. For training, we need a loss function. So our beloved cross-entropy loss function, computing the distance between our actions, so the moves we actually played, and logits, which are from the previous screen. That's what the network predicts from the pixels. And then we modify it using the reinforcement learning paradigm. We modify it by multiplying this per move loss by the rewards, by the per move rewards. And now, with those rewards, moves leading to a scoring point will be encouraged, moves leading to a losing point will be discouraged. So now we have our error function. TensorFlow can take over. We pick one of the optimizers in the library and simply ask this optimizer to minimize our loss function, which gives us a training operation. And when we will, on the next slide, run this training operation, feeding in all the data we collected during gameplay, that is where the gradient will be computed, and that's the operation, when run, that will modify the weights and biases in our policy network. So let's play this game. This is what you need to do to play one game in 21 points. So the technical wrinkle is that in TensorFlow, if you want to actually execute one of those operations, you need a session. So we define a session. And then, in a loop, we play a game. So first, we get the pixels from the game state, compute the delta between 2 frames. OK, that's technical. And then we run session.run this sample operation. Remember, sample operation is what we got from our picking multinomial function. So that's what decides the next move to play. Then we use a Pong simulator here from OpenAI Gym. We can give it this move to play, and it will play the move and give us a new game state, give us a reward if we scored a point, and give us information on whether this game in 21 points is finished. Okay? That's all we need. Now we simply log all that stuff. We log the pixels, we log the move we played, we log the reward if we got one. So we know how to play one game, and we will play many of those games to collect a large backlog of moves, right?
That's right. Playing games in reinforcement learning, or in our experiment, really is a way of collecting data. Now that we have collected a lot of data, playing one game, or maybe 10 games, why not? We can start processing rewards as we plan to. We will discount the rewards so that the moves that did not get any reward during gameplay now gets a discounted reward based on whether or not they eventually led to winning or losing points and how far they are from the moves that actually won or lost a point. And then we normalize those rewards as we explained before. Now we're ready. We have all the data in place. We have observations. That's the differences between game frames. The actions that we happen to play, and the rewards, so that we know if those actions were good or bad. And then we're ready to call the training op. And training op is what we saw a couple slides before, where we had optimized already initialized, and this is going to do the heavy lifting and compute the gradients for us and modify the weights just slightly. Suppose we play 10 games, we modify the weights slightly, and then we'll go back and play more games to get even more data and repeat the process. And the expectation or the hope is that the model will learn to play a little bit better every time.
I'm a bit skeptical. Do you really think this is going to work?
Well, sometimes we see the model actually learn to play a little bit worse, so we'll see.
Okay, live demo?
Live demo.
let's go. Let's run this game. So this is a live demo. I'm not completely sure that we are going to win, but we shall see. So brown on this side is the computer-controlled paddle. Very simple algorithm. It just stays in front of the ball at all times. So there is only one way to win. Its vertical velocity is limited, so you have to hit the ball on the very side of the paddle to send it at a very steep angle, and then you can overcome the vertical velocity of the opponent. That's the only way to score. On the right, in green, we have our neural network controlled agent, and it's slightly behind now. So we'll see if it wins. And if you want, I want this side of the room to cheer for brown, and this side of the room to cheer for AI. Okay? So it's very even right now. Yeah, go, go, go. AI is winning. AI is winning. I'm happy because this is a live demo. There is no guarantee that AI will actually win. One thing that is interesting here, actually, is that this is learning from just the pixels. So initially, the AI had no idea of even what game it was playing, what the rules were. It had even no idea which paddle it was playing. Okay? And we didn't have to explain that. We just give the pixels, and on scoring points, we give a positive or a negative reward, then that's it. From that, it learns. And you see those emerging strategies, like what I said, hitting the ball on the side and sending it at a very steep angle is the only way of winning. And it picked that up. We never explained it. It's just an emerging strategy. This is looking good.
Pretty close. Yeah.
It's looking good. It's a bit close, but it's looking good. You think we'll win? Okay, next point, I want a loud cheer when AI wins. Because I hope this is going to work. Hey, 20? Okay, one more. Yeah, we won.
We've done it.
Good job, Johan. This is fantastic. All right. So, what was going on during gameplay? Actually, remember how this network was built? Right here. So neurons in this very first layer, they have a connection to every pixel of the board. They do a weighted sum of all the pixels in the board, all right? So they have a weight for every pixel, and it's fairly easy to represent those weights on the board and see what those neurons are seeing on the board. So let's try to do that right here. Oops. We picked 8 of those 200 neurons, and here we visualize, superimposed on the board, the weights that have been trained. And the untrained eye doesn't see much in here, so maybe you can enlighten us, Johan.
This is really interesting, Martin. We're looking at what the model sees, or rather what the model cares about when it sees the game pixels that we gave it. You see that one of the neurons apparently had learned pretty much nothing. It's still looking like a white noise at the beginning of initialization.
Yeah, bad pupil here. Didn't
listen.
So
it probably did not contribute much to the gameplay. But for all the other neurons, you see some interesting patterns there. We see a few things that the model seems to put a lot of weights on. It cares a lot about where the opponent paddle is and where it's moving. And also cares about the ball's trajectory across the game board. And quite interesting, it also cares a whole lot about where its own paddle is on the right. Because like Martin pointed out before, at the beginning of learning, the model didn't even know which paddle it's playing. And so it has to learn to remember that's an important piece of information to be able to play game well. And when you think about this is really consistent with how we human beings would believe consists of important informations to be able to play the game well.
So we wanted to show this to you, not to show our prowess at Pong, although it worked, but mostly to explore training algorithms. And you see, mostly in neural networks, you do supervised training. And in nature, well, sometimes when we teach people, it looks like supervised training. Probably in class, the teacher says, this is the Eiffel Tower, and the pupils say, oh, okay, that's the Eiffel Tower, and so on. But if you think about a kitten jumping on a fur ball and missing it, and jumping again until it catches it, and there is no teacher there. It has to figure out a sequence of moves, and it gets a reward from catching the ball or not catching it. So it looks like in nature there are multiple ways of training our own neural networks, and one of them is probably quite close to this reinforcement learning way of teaching. Johan, you built this model. Is there some other thoughts it inspired you?
Yeah, I have a sort of technical insight maybe for you as a takeaway message. In running experiment, we see that there are some steps which are not differentiable. Particularly in this case, sampling a move out of the probability output from a network and playing the game and getting a reward back. Yes, those factors really do depend on the model itself, but in a non-differentiable way. And so even with the powerful tools like TensorFlow, you wouldn't be able to very naively build a loss function and then run gradient descent training. But there are ways to get around it, and that's exactly the techniques we're showing today.
So what you're saying is that reinforcement learning can solve many more problems than just Pong, and it's a way of getting around some non-differential step that you find in your problem.
You should be able
to do that. That's great. That's great. So where is this going? We want to show you a couple of things from the lab, because this has had mostly lab applications. And then one last thing. What is this?
This is very interesting, everyone. What we're witnessing here is a human expert of pancake flipping trying to teach a robotic arm doing the same thing. And there's a model in the back supporting a robotic arm whose output controls the joints movement or the motors in it, what angle, what speed to move toward. And the goal of this is to flip the pancake. And the pancake is not just any regular pancake, but rather it's instrumented with sensors so that it knows if it's been flipped, if it landed on the floor or on the table or back in the frying pan.
Doesn't seem to be working.
It's trying, it's trying. In another experiment.
And so what is the reward here?
The reward probably is that if you flip the pancake correctly, then you get a positive reward, and otherwise negative reward.
Okay.
And speaking of reward function, in another experiment, I was going to say, the experimenters set the reward to be a small amount of positive reward for any moment the pancake is not on the floor. And that machine learned, but what it learned was to flip the pancake as high as possible to maximize pancake airborne time. Never thought I would say something like that. That way it can maximize the reward just because it takes a long time for it to land on the floor.
So that's kind of funny, but actually it's a nice illustration of the fact that you can change the learned behavior by changing your loss function.
Exactly. The model learns.
That's how you teach it stuff.
Now it has learned.
Oh, nice. Yeah, cool. We know how to play Pong and flip pancakes. That's significant progress. DeepMind also published this video. So they used reinforcement learning, and they built those skeletal models. Here, the neural network is predicting the power to send to the simulated muscles and joints of these models. And the reward is basically a positive reward whenever you manage to move forward, and a negative reward when you either move backward, or when you fall through a hole, or when you just crumple to the ground. The rest is just reinforcement learning, as we have shown you today. So all of these behaviors are emerging behaviors. Nobody taught those models. And look, you have some wonderful emerging behaviors. It's coming in a couple of seconds. Look at this jump. After this, those are nice jumps, but there is a much nicer one. In a second, you will see a jump, really athletic jump, with the model swinging arms to get momentum, then lifting one leg, cushioning right here. Look at this. This is a fantastic athletic jump. It looks like from the Olympics, and it's a completely emerging behavior.
But Martin,
what is it with the arm movements?
If this is an optimized way of walking and running, why do I not see people doing this? I mean, I could, but...
Well, you know, there are multiple ways of running. Probably the loss function didn't have any factor discouraging useless movements. So again, by modifying the loss function, you get different behaviors. And actually, one last one, not this one. This one is kind of funny. Yeah, still playing around. But I like look here. It figured out how to run sideways. This is fantastic. Yes, there are two ways of running, and it did figure out how to move sideways. This one you've probably seen. This is move 74 in game 4 of AlphaGo versus Lee Sedol. And that's the one move that Lee Sedol played that was called the God move, and he's world famous for just that. He played one correct move and managed to win one game against AlphaGo. He lost 4-1, which is fantastic. And AlphaGo also uses reinforcement learning, not exactly in the same way. Here, it wasn't entirely built out of reinforcement learning, okay? Because for turn-based games, the algorithm for winning is actually quite easy. You just play all the moves to the end and then pick the ones that lead to positive outcomes. The only problem is that you can't compute that. There are too many of them. So you use what is called a value function. You unroll only a couple of moves, and then you use something that looks at the board and tells you this is good for white and good for black, or good for black. And that's what they built using reinforcement learning. And I find it interesting because it kind of emulates the way we humans solve this problem. This is a very visual game. We have a very powerful visual cortex. When we look at the board, Go is a game of influence, and we see that in this region, black has a strong influence. In this region, white has a strong presence. So we can kind of process that. And what they built is a value function that does kind of the same thing and allows them to unroll the move to a much shallower depth. Because after just a couple of moves, their value function, built using reinforcement learning, tells them this is great for white or good for black. So these are results from the lab. Let's try to do something real. So some application. What if we build a neural network? It's a recurrent neural network. Okay, that's a different architecture of neural network, but for what you have to know, it still has weights and biases in the middle, okay? And this neural network, recurrent neural networks, are good for producing sequences. So let's say we build one that produces sequences of characters. And we structure it so that those characters actually represent a neural network. Yeah, a neural network is a sequence of layers. So you can figure out a syntax for saying, this is my first layer, this is how big it is, and blah, blah, blah. So why not produce a sequence of characters that represents a neural network? What if then we train this neural network on some problem we care about? Let's say spotting airplanes in pictures. So this will train to a given accuracy. What if now we take this accuracy and make it a reward in a reinforcement learning algorithm? So this accuracy becomes a reward, and we apply reinforcement learning, which allows us to modify the weights and biases in our original neural network to produce a better neural network architecture. It's not just tuning the parameters, we are changing the shape of the network that works better for our problem, the problem we care about. We get a neural network that is generating a neural network for our specific problem. It's called neural architecture search, and we actually published a paper on this. And I find this a very nice application of a technology designed initially to beat Pong.
So Martin, you're saying we have neural networks that learn to build other neural networks.
Yeah.
That's deep, man.
Yeah. So Johan, to finish, you built this demo. So can you tell us a word about the tools that you used?
Yeah, definitely. So we use TensorFlow for the model itself, and TensorBoard for tracking the metrics of during the process of training. I really didn't want to run the training on my laptop, but I probably could, so I used the cloud machine learning engine for the training. The model that was playing the game that we saw before the live demo took maybe about 1 day of training to accomplish that.
And so with ML Engine, you have this job-based view, and you can launch 20 jobs with different parameters.
In fact, that's what I did.
And just let them run. And it's just practicality, right? It will tear down the whole cluster when every job is done and so on.
That's right. Worry-free.
Yeah, I use ML Engine a lot as well for that. There are many other tools in cloud for doing machine learning, but one we just launched is AutoML Vision. That's one when you do not program. You just put in your labeled data, and it figures out the model for you, and now you know how it works. And also, this uses lots of CPU, GPU cycles. So cloud TPUs are useful when you're doing neural architecture search, and they are available to you as well now. So thank you. That's all we wanted to show you today. Please give us feedback. We just released this code to GitHub, so you have the GitHub URL. If you want to train a Ponk agent yourself, go and do it. You can take a picture there. And if you want to, the URL is still on the screen. If you want to learn machine learning, I'm not going to say it's easy, but I'm not going to say it's impossible either. We have this series, a relatively short series of videos and code samples and code labs called TensorFlow Without a PhD that is designed to give you the keys to the machine learning kingdom. So you go through those videos. This talk is one of them, and it gives you all the vocabulary and all the concepts, and we are trying to explain the concepts in a language that developers understand because we are developers. Thank you very much.
Son be able to live independently and give him a future. That's part of why I became an engineer, is part of why I get into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
Good afternoon, everyone. Welcome to the Android Studio Profilers session. My name is Esteban. I'm the lead of the profilings in Android Studio. And today I'm going to show you all the new features we have in Android Studio 3.2 and some of the features that we launched in Android Studio 3.1 in the profilers. Right, so I'm going to be doing a demo for most of the session, but just in case you haven't seen the profilers before, just to get an idea, how many of you have used the profilers? You know, oh, okay, that's great. Well, I was going to explain that we have these profilers in the studio, but most of you have seen them. But we have a new profiler that I'm going to be introducing today, that is the Energy Profiler. As you know, we have the monitors that show you live telemetry from the app. We have a CPU, network, memory, and the new Energy Profiler. And you can dive into any of those and, for example, inspect your network requests, see where you made the request from code, see what you actually downloaded, what was sent. You can also dive into the memory profiler, see the breakdown of the memory, see how many objects you have allocated, where you allocated them. You can also dive into the CPU profiler. I'm going to be showing some new cool features that we added there in 3.2, specifically systrace. Again, I'm going to ask the question, how many of you have used systrace before? OK, cool. Now systrace is, we started with the first steps of integrating systrace into the Android Studio CPU profiler. I'm going to be demoing that in a few moments. And last but not least is the new Energy Profiler that will guide you in finding problems in your app that could lead to energy profiling, energy issues. I'll talk more about that at the end of the session. And with that, that's it. That's all the slides that I have. So I'm going to move to the demo now. And I have to make a disclaimer. So all the features that I'm going to be demoing today are in Android Studio 3.2 Canary. And there is a reason why they are not in the stable release yet. So we might be in for a bumpy ride, but I wanted to show you what we have. And you know, if it crashes, we just keep it between us and people watching on YouTube, and that's it. All right. So I wrote last week this clock app. It's a simple clock app that has the clock. It has a stopwatch that you can click and does something. And it has a timer. And I want to profile it with you guys. So let's first start with Network Profiler. So this app has a lot of features that a clock app should not have. For example, it needs internet access. It needs to access location. It has a lot of things, so we can demo this. So please do not write the clock app like this. So one of the features it has is you can change the background. So if the internet connection is good enough, this thing is going to start downloading some images right now. There we go. You can dive into the Network Profiler. You surely have seen this before. And you can see all the network requests that have been done. You can click on them and see the actual payload. Something new that was added in 3.1 is the ability for us to see what we send. Not just what we receive, but we can see the payload or the custom headers that we use. In this case, I have one custom header that says Google I/O. There is another new feature in 3.1 for the Network Profiler, and that is the threads view. So as you see here, we show you the requests in a timeline. But if you choose threads view, what you can see is on which thread, and let me close this so we have more space. There we go. So you can see each request on which thread it was made. And if we have more like this, I'm using a standard asynchronous task, which uses a default executor that will run them sequentially, and you can see them. And if they were reusing the same thread, you can see them too. But if in your app you have a more complex threading with network requests, you can use this view to see what's going on. So those are the two new features on the Network Profiler that we've added in 3.1. And now I'm going to move to the Memory Profiler. Let me go to the live session. If you have seen this view before, we split up how much memory you are using into different components, but we also show you the number of objects you have allocated. If you are profiling on an Android Oreo phone or newer, we have, and this is super cool, we have a feature called live allocation tracking. Remember back in the day, it was probably last year, when you had to do allocation tracking, you had to click on a button to record the allocations and then you would see them? Well, if we wanted to know what happened here, we can see that the object line is going up, it's being garbage collected, it's going up, and it's being garbage collected. Just if you want to see what's happening, just select a range, and we will have the information of every single object that was allocated there, at which time it was allocated, and where in your code it was allocated. And you can slide this window, and you can see this thing changing. So if I slide it over a garbage collection period, you will see which objects were deallocated. Let me close this window. There we go. We can see that there was a lot of strings deallocated. So we can start actually having a look at this app and see how bad it is written. For example, if I select this and I want to see what was allocated, I can see that there were a lot of strings allocated. I can click on any one of those and see where I allocated them. And I allocated them inside a non-draw. This is not a good idea. If you have a custom view and you allocate a lot of strings there, bad things will happen. And we'll see more about that through the CPU profiler. But this is already starting to tell us signals about what my app is doing wrong. Another new thing that we added in 3.2 is the ability to see JNI global references. This is very important because a lot of memory leaks occur because one JNI global reference is created, and we don't know when we created it, and we don't know where it is. So when you select a range, what I have here in my app, every time I download an image, I run a filter through it in C++ to darken it so the font can be seen. And I have a global reference there, and I hope I did it right? So we have a special heap, which we call the JNI heap, that when you select it, you can see all the global references that existed in this range of time. In this case, I have this int array, and I know I created one, but it should have been gone. So let me go live here and select a range. And here it is. This is my global, this is every image that I downloaded. I'm still holding a JNI global reference to it, and I can actually navigate to the C++ line of code where I created that global reference I never let go. So I hope this is useful to track down problems with global references in JNI. And one more thing. You probably have been seeing all the time on the left that we have a new panel called the Sessions panel. Well, now we allow you to see previous sessions that you have been profiled, so you can navigate back and compare previous runs. So if you're working on optimizing your app and say, what did I change? You can go back and see previous sessions. At the end of the demo, hopefully we can go back and see what we optimized and what happened. But that opened the door for us to do things like this. Now we can import a file. I'm going to import a heap dump. And this heap dump is being imported directly into the new profilers, and it creates what we call a fake session for it. And you can analyze the heap dump as you are used to in the profilers. You can also import traces for CPU, and everything we can export, we can import too. So that's pretty handy this is new in 3.2. Cool. And this is what I wanted to show for memory. And now we're going to go to CPU and spend most of the time there. Right. Where am I? This is the live session. And I'm going to show you one feature that we have. All right. So one thing that we wanted to add was the ability to profile since the beginning. So if you've used the profilers, you notice that if you want to profile your app startup, you have to quickly go to the CPU profiler and click record so you can see what's happening. Well, in 3.2, what you can do is if you go to the profiling tab, we have an option that says start recording a method trace on startup. So I have this ticked. You can choose the configuration that you want. In this case, I'm going to use sample Java configuration. And I'm going to rerun the app. Cool. Now, you can see that the app restarted. The profilers took me directly to the CPU profiler, and there is already a capture in progress from the very beginning of the app. So I'm going to stop it now, and we're going to investigate what happened there. It'll take a few seconds to get the data. Cool. I don't know if you can see the resolution on that screen, but let's have a look and see that I'm going to select the very beginning of the app. In fact, you can see that the capture started even before our telemetry could start getting data from the app, right? Our telemetry started here, but the app started before, and we can see the data. And if we keep zooming in there, you can see the first onCreate of my main activity. And even before that, we can see when all the dexes were loaded and the very, very beginning of your app. So with this mechanism, you can profile from the very beginning and optimize the startup time of your app. Cool. But let's have a look at this capture and see if those strings we saw before are actually causing some problems. One of my favorite views in the CPU profiler is the flame chart. The flame chart aggregates all the call stacks that have the same beginning. So you can see it's basically the top-down tree, but in a visual way. And you can see that one of the biggest things is my own draw. The way I wrote this app is on every frame, I'm rendering everything again. That's not a good way of doing it, but it's a really good example for the profilers. So you can see that I'm rendering, and there is a lot of things at the top that have to do with string formatting. And this could be the source of our string problem that we saw before. So it's another symptom that your app is not doing well. One thing that I always say about our profilers is that we cannot really tell you what's wrong in your app. We can only tell you what your app is doing, and then it's up to you to say, oh, I didn't expect this to happen. Because as you can see, my app looks fine, but under the hood it's not. So let's say you have a bug on a label that you put wrong, and it's in a different position. You run your app, you see it there, and say, oh, it's wrong, I need to fix this. But if you have something like a performance issue wrong, you won't see it. You won't see it until, even, we'll talk about battery later, and you will see it in the field, right? So we want our profilers to be another window to your app so that you can run your app while seeing the profilers, and then you see the problems there because something that you did not expect starts showing up, like me doing a lot of string formatting inside an on-draw call. Cool, so let's go to the code where I have my, can you see? Yeah. Cool, so I have my own draw, and I have a function called drawTime where I draw the time on my app. And I wrote a function called drawTimeString that uses string formatting to draw the time, and that's probably not a good idea. So, oh, that's just, it's a coincidence. I have another function that draws the time without using strings, and we're going to try it. Oh, before we do that, let me show you one thing that we have here. So, how many of you are familiar with this line of code, trace.begin section? Raise your hands. Cool. So, what this line does, and together with the end section, they will create a systrace event that then you can use systrace to see. So before I make my optimization, I'm going to show you what happens if I take a capture using the system trace method. Cool. So this is running systrace under the hood, and you don't have to go to the Python script anymore and get it, and then get it back on the HTML view. We will instead show it to you right here in our app, in Android Studio. Okay. Remember what I mentioned about a bumpy ride? This is it. Oopsie. Let me restart the emulator, and we'll do it again. There we go. Please try this at home. File bugs, we will fix them. And when we get to stable, these issues will be all sorted out. There we go. I'm going to go to CPU profiler and use system trace. Second time's a charm. OK, so we have system trace here. Let me select and zoom into the selection. Cool. One thing that you notice here, that first of all, we have a new section there called the kernel section, where we show you all the CPUs. And if you pay close attention, we re-render all the thread information, getting all the data from systrace. So before, the thread information, we get sampling the proc file system. So it's not very accurate. But as soon as you take a systrace capture, you can see exactly what your thread is doing at every moment. And more than that, if I select one of those, we highlight above on which CPU your thread is being scheduled. So you can look at thread contention or other things that are kicking you out of the CPU. There is a fundamental difference in the way we show systrace here with the way you see it in the HTML view. Here, we focus on your app. So everything here that is highlighted green, even the dark green, is just your app. You can still go and see the other events and see what is taking CPU or why you're being kicked out. But we focus on your app. We show you the threads of your app so you don't have to navigate that gigantic HTML page. And we use all the other things that you know about other captures. We use them for systrace. For example, flame chart or a top-down view. So let me zoom in to a moment in time. There we can see our frames. So I have here, let me zoom in more and choose actually my main thread. There we go. So we can see the choreographer do frame, and further down we can see the on draw on my custom component. And we can see the draw time. Remember in the code, let me go back to the code and show you. In draw time, we have clock draw time around the section, around my time string. And you can see that I'm rendering it 3 times, one for every section of my app. And we can quickly see how long each one of those is taking, right? So I'm taking 38 milliseconds to render a frame. If you want your app to render at 60 frames per second, you have to render under 17-ish milliseconds. Now, I'm way over that. In fact, one of my calls to draw time is taking 11 milliseconds. So my app is not doing well. It looked OK, but imagine you ship this and people complain. This is one of the things that I was mentioning about. You look at your app, but look at it through the profiler glass to see if it's doing OK. Cool. Now, let's optimize and take another systrace capture. I'm going to change the implementation of draw time. Now, instead of using strings, I'm using my custom formatting. Instead of using a string format, I'm using my custom formatting. We'll run it again with these changes, and we'll run it through systrace and see how that affected my app. Cool, there it is. I'm going to go to the CPU profiler. Systrace is chosen for me. And I'm starting a capture. Just a few seconds should do, because there are a lot of frames that happen in there. Cool, we have it here. Right. Main thread selected. Let's zoom into a specific frame. We have the choreographer do frame in the framework. And then it goes down to the clock on draw. And you cannot see anymore the draw time functions, because they're tiny, tiny specs on there. Each one of them now taking 71 microseconds. And the on draw is 13 milliseconds now. Woohoo! So we did that. Now, I'm still under 60 frames per second because my app is bad in other places. But at least we optimized one part of it. Cool. And that's systrace. And let me mention again sessions. So remember I said we can go back and compare? Well, I have my previous sessions here on the left. And we can see the previous systrace run that we did. So here it is. I can select it again and look at the main thread and see how bad my draw time was, and then go back to the currently running session. And you can keep all of this. And of course, if you right-click, you can export the trace and send it on a bug, or on a heap dump. You can export these things right here from the session panel. So let me click this. Right. And that's our, we have 20 minutes. And that's our integration with systrace. So there is another way of capturing CPU data that is through an API in the debugger Let me go to the line of code. Here it is. So I have my stopwatch, and I'm going to change it so every time that I start my stopwatch, I'm going to run start method tracing, and every time that I stop it, I'm going to stop method tracing. I need to import the debug class, and I'm going to rerun the app. Now, before this, once you run this API, you had to go and fetch this file and open it in either any of your favorite profilers that can open a trace file. But right now, if I'm the CPU profiler and I use my stopwatch, this is what happens. So now I'm taking a capture, and the studio profilers detected that a capture is being taken place, and we're showing you theirs. And when I stop it, I don't need to go and fetch the file from anywhere. We pull it from the device, and we show it right there. So if I start and stop, and I start and stop, all these captures that are actually overriding each other because they use the same file on device, we're pulling it and showing them on Studio. So that's super handy when you want to profile exactly a moment in time. You can navigate to all of them, and you can see them here in the sessions panel too. So it's pretty cool. One more thing, we added in 3.1, where am I? Another way of capturing CPU usage using the C++ sampling tool called SimplePerf. If you go to documentation in AndroidDevelopers.com, you will find documentation about SimplePerf. We have a version of SimplePerf inside Android Studio and allows you to sample C++ code and see the entire call stack of your C++ program. I'm not going to demo that because I don't have a lot of C++. Cool. So that's CPU profiling. And let me move to the energy profiler now. So energy is tricky. Energy is tricky because there are two main sources that use energy on your phone. Well, the screen is obviously, I'm not even counting the screen. The screen is bad. It uses a lot of energy, but the user is using the phone. So if you're using a game, right, it's all the time using the screen. But the battery drain problems usually happen when we use CPU or network when the user is not aware of this. Or maybe when we as developers are not aware of this. So let me go live. I'm using a fair amount of CPU on this app. And if I go into the energy profiler, we classify this as light use of energy. We will show you here things that, this is a theoretical model, right? So we show you things that represent how much energy you would be using on a modern phone. I'm not profiling how much energy the emulator is using, obviously, but this is for us to see, okay, I'm doing well or I'm not doing well. I'm going to show you some things that show up here. But obviously, the two big factors are CPU and network. And it's not, the obvious thing is, okay, just don't use CPU and network. But how, right? Or why am I using that in the field? And the problem is not actually when we use it. The problem is that we don't know we're using it. So let's say I have a wake clock that runs amok, and we don't know where it is, and that's using CPU. Or I have an alarm that I didn't set up correctly, and that is waking my app, and I'm making network requests. So it's not about the actual energy. It's about all these things that you could be doing incorrectly that could cause battery drain in the long term. And this is part of what I was saying before, that if you look at your app, if you look at my app, seems to be running, seems to be fine. If I were to push this app to the Play Store and you install it on your phone, this is going to be the most expensive battery-speaking clock you ever have on your phone. I'm going to drain your battery, right? And I don't know it when I'm seeing this. So by looking at the profilers, we can see that constantly this is draining CPU, and we can start investigating why. Like I said, the common mistakes are I have a wake clock that I don't release, or I have an alarm. So we wanted to give you a window so you can see these things happening. The same way if you have a label in the wrong place, you can see it. We want to show you if you have an alarm that you didn't cancel or you have an alarm in the wrong place, we're going to show you that. So let me show you this piece of my app where I have a timer. So here I can run, let's say, a 10-second timer. And you can see at the bottom of the energy profiler that there is a yellow line that showed up. If I put the tooltip on it, that's an alarm or a job. We show you both there. And you can see that when the timer stopped, the alarm went away. And if I start the timer again, I have the alarm. And this, actually, when I was developing this, was useful for me to see, OK, am I doing it right? When I stop the timer, does my alarm go away? When I start again, do I call it back? So this allows you to see this. Please don't use alarms for a timer on a clock. I also have a wake clock on my stopwatch. Again, don't use wake clocks for stopwatch. And you can see that when I start it, I acquire a wake clock, and when I stop it, I let it go, and I can see that it's working fine. If the red line keeps going, I have a bug, right? My app will look the same, and I will ship it, and people will have problems, but you can see it through this window that whether it's fine or not. And we also track location. So if you are acquiring location like I'm doing now, we have this purple line that shows you that you're acquiring location. The emulator has a really handy feature that you can actually tell it when to send a location event. So in our model, we show you that that is actually using energy. And again, you can see it in the purple bar, and if I stop it, there we go. The purple bar is gone. But more than that, as you are used to in our profilers, we can select a range, and we can show you that you had an alarm, that you had a location request. If I move back, we can select the wake clock, and I'll do it in a second. More than that, I can show you where the location was acquired, which kind of provider. I'm using a GPS provider, so we can see that. We can see the interval times that I chose, where in the code I triggered it. I have a toggle location that happens when I click the button. And if I click on the alarm, not only I can see when I set it the first time, but when I reset it, when I cancel it, so you can see all the places in the code that that was triggered, so I can debug problems when this is not happening correctly. Let me go back and show you the wake clock. It's right there. I select. You can see the wake clock. And you can see every time that I started and I stopped the stopwatch, I was acquiring and releasing the wake clock. And you can see all the call stacks for that when that happened. So this is the power of this. This is not to say, OK, you're using a lot of battery. Well, yeah, I'm a game. I want to use battery, so it's fine. The power of this is so that you can see that your app is doing what you think it's doing. And if it's not, you should go and fix it. So cool. That's Energy Profiler. Let me show you one more thing that I want to show you. On the left, we have the sessions panel. And let's go back in time. I can stop a current session like this. And then you can click on older sessions. And we can start comparing all the captures that we did back from when I started the talk here. And this was the first time we ran it. And we keep all this information until you restart Studio. So you can compare runs. And let me show you the last thing. And I want to close with that. I'm going to close a few minutes earlier. All right. Like I said before, I'm rendering every frame. I'm doing something that I should not be doing. That is, I'm invalidating the view all the time. And that is using a lot of CPU. So let's go back to my activity where I have the code that does this. So I have my model that I update every frame, and then I invalidate all the time. My model has the ability to know when it has changed. So I'm only going to invalidate the canvas whenever something has changed. And we're going to see the impact that that has on energy, CPU, and so forth. Running the app again. There we go. You can see now that the Energy Profiler most of the time now is below light. It was above medium before. We can compare with previous sessions. But of course, when I have to render, we can see that the energy usage starts going up. This is because I'm re-rendering my view every time. And you can see the effect here. You can see it on the memory profiler too. If I go back to the memory profiler, remember that line that was going up, 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 and being garbage collected? That is gone. I do have some objects that are being created, and they will be claimed later. Like here, but it's not as it was before. Cool. And let me stop the demo and go back to the slides. All right, we have a few minutes for questions if you want to do live questions. But I wanted to close with this and say, again, our profilers cannot tell you what you did wrong. They can only show you what your app is doing. So use the profilers to look at your app and see whether what you think your app is doing is what the app is actually doing. Thank you very much, and it's open for live questions. It's working.
It's working, okay.
Yeah.
Okay, so with the integration of the system trace in the new IDE.
Hey there, IO Live. Todd Kerpelman here, and I am here in the Experiments with Google Dome with Teo Soares, who is the team lead on Experiments with Google. Welcome.
Thank you. Happy to be here.
So what is Experiments with Google?
Experiments with Google is a platform where we showcase projects that developers have made using Google technologies. We have close to 1,500 of them. A lot of them are open source. Anybody can download them and play around. Anybody can submit their own.
All right, and so here at the booth today at the Dome, you've got like some of your favorite experiments that are showing off?
Yeah, we have 10 of them. Do you want to try this one out?
I would. What is this one behind me here?
So this one is called Move Mirror, and it's a demo of a pose estimation model from Google that lets you use just any regular webcam, we're using a phone here, to find the pose data in an image. And then in this demo, what we are doing is finding an image that matches what you are doing in front of the camera from one of 90,000 images we have in a database.
Awesome. Well, let's give it a try. My kids told me about flossing, which apparently is a thing, but I'm not going to do it because I don't want to embarrass my kids that much. I'm just going to bounce side to side instead. Woo. All right, and I'm going to wave. All right, thank you. And now we're going to move on to the next one. Let's go.
So this is a game built with a Google library called TensorFlow.js that lets you train an AI right in the browser. And what we've done with it here is play a dancing game where you're going to train your little dancer using hand gestures and see how many points you can score.
And so through the power of machine learning, this is going to recognize my hand gestures all within the browser using TensorFlow.js, no like talking to the cloud or anything.
Exactly. Nothing is ever going to a server. It's all happening right in the browser.
Wow. All right. Well, I got to give that a try and make my little jelly bean guy dance. Let's do it. I'm ready. You ready? Come on, jelly bean. Dance to the left, to the right. Freak out. Left. Come on, keep dancing, little jelly bean. You can do it. Oh no! Oh, I got it wrong. All right. Look at that. I get a medal for dancing. The one and only time I will get a medal for dancing. Let's move on to the next one. So what's going on here?
This is an augmented reality experiment that lets you draw really simple things in AR. We called it Just Align. What we've done for this demo is to use Cloud Anchors, which is the new technology that we announced at this I/O, to let two phones join.
Hey there, IO Live. Todd Kerpelman here, and I am here in the Experiments with Google Dome with Teo Soares, who is the team lead on Experiments with Google. Welcome.
Thank you. Happy to be here.
So what is Experiments with Google?
Experiments with Google is a platform where we showcase projects that developers have made using Google technologies. We have close to 1,500 of them. A lot of them are open source. Anybody can download them and play around. Anybody can submit their own.
All right, and so here at the booth today at the Dome, you've got like some of your favorite experiments that are showing off?
Yeah, we have 10 of them. Do you want to try this one out?
I would. What is this one behind me here?
So this one is called Move Mirror, and it's a demo of a pose estimation model from Google that lets you use just any regular webcam, we're using a phone here, to find the pose data in an image. And then in this demo, what we are doing is finding an image that matches what you are doing in front of the camera from one of 90,000 images we have in a database.
Awesome. Well, let's give it a try. My kids told me about flossing, which apparently is a thing, but I'm not going to do it because I don't want to embarrass my kids that much. I'm just going to bounce side to side instead. Woo. All right, and I'm going to wave. All right, thank you. And now we're going to move on to the next one. Let's go.
So this is a game built with a Google library called TensorFlow.js that lets you train an AI right in the browser. And what we've done with it here is play a dancing game where you're going to train your little dancer using hand gestures and see how many points you can score.
And so through the power of machine learning, this is going to recognize my hand gestures all within the browser using TensorFlow.js, no like talking to the cloud or anything.
Exactly. Nothing is ever going to a server. It's all happening right in the browser.
Wow. All right. Well, I got to give that a try and make my little jelly bean guy dance. Let's do it. I'm ready. You ready? Come on, jelly bean. Dance to the left, to the right. Bring out. Left. Come on, keep dancing, little jelly bean. You can do it. Oh no. Oh, I got it wrong. All right. Look at that. I get a medal for dancing. The one and only time I will get a medal for dancing. Let's move on to the next one. So what's going on here?
This is an augmented reality experiment that lets you draw really simple things in AR. We called it Just Align. What we've done for this demo is to use cloud anchors, which is the new technology that we announced at this I/O, to let two phones join the same room and draw together on the same drawing. And that can happen across platforms, so we have one Android and one iPhone.
Awesome. So let's give this a try. Maybe I will hold up a phone and you can draw a little something on your other device. So let's see what you're drawing here. Oh, drawing over here. Oh, it's a smiley face. Woo! And we are chatting in augmented reality. It's the future. Thank you so much for the tour. So if I'm a developer and I want to either get inspired to make something amazing or want to show off something amazing that I have made, where do I go?
You go to g.co/experiments. That's where you find our 1,500 experiments. A lot of them are open source, or you can submit your own.
All right, sounds good. g.co/experiments. And hey, if you like this video, maybe want to see a few more like it, head on over to g.co/io/guide and see more videos just like this one. Thanks for watching. We'll see you soon.
Hey everyone, we're now in the design sandbox, and I've got Liam here who is a design advocate, and he's going to tell us all about the latest features and announcement for material design. In fact, there's some tools that we're going to take a look at, right?
Yeah, absolutely. So one of our big announcements was the idea of material theming, and that's really embodied not only in the new guidance, but also in some new tools that we have, with one of them being Theme Editor, which is part of our Sketch plugin. So I just want to do a quick demo here. You can see we have 4 existing mockups on screen, and we have a theme set up in Theme Editor. So if we switch over to that, you can do something as easy as just adjusting the color. So if you choose like a blue color, or you can choose a default material swatch, it'll automatically generate a tonal palette from that and apply it to all of our components, tuned for accessibility and style. So then we can choose an accent color. And I'll do a yellow. And then we'll just save that. And when we switch over here, it'll show us a library update is available. So we just update our symbols, and all of our colors have been systematically applied throughout all of our mockups.
That's really cool. I think particularly is this idea of the color cascading through your whole design when you just make a simple change.
Right, so it's not just taking one color and applying that to everything in the interface, it's actually drawing from this tonal palette to say, like, what is the best shade for a text field in its resting state, or what should the text label be? So it tunes that for accessibility and for style.
And can you show us one more thing, exporting this into Gallery?
Yeah, absolutely. So part of our Sketch plugin is also the ability to upload everything to Gallery. So I can just upload this as a new iteration on our existing Crane project. And once it uploads, there we go. We can just hit view. And in Gallery, it's uploaded to all of our mocks. And because we used Theme Editor, when you enter inspect mode, you can actually click on things and find what the text style is and all of the different specs that you'll need to actually implement this. So you can select something like a fab, and that will actually give you links out to both the material spec and the platform-specific implementation. So you can switch to Android if you're working on Android, and then click out and be taken right to documentation for that component.
That's really awesome. Thank you so much for showing that to us.
Yeah, thank you.
And if you'd like to find out more about material design and all the announcements from here at I/O, head on over to material.io.
Okay. Who's interested in AI?
Woo!
Me too. Me three. Okay, so I'm the moderator today. I'm Diane Green, and I'm running Google Cloud and on the Alphabet board. And I'm going to briefly introduce our really amazing guests we have here. I also live on the Stanford campus, so I've known one of our guests a long time because she's a neighbor. So let me just introduce them. First is Dr. Fei-Fei Li, and she is the chief scientist for Google Cloud. She also runs the AI lab at Stanford University, the Vision Lab, and then she also founded Sailors, which is now AI for All, which you'll hear about a little bit later. And is there anything you want to add to that, Fei-Fei?
I'm your neighbor.
That's the best. And so then the other, so now we have Greg Corrado, and actually, there's one amazing coincidence. Both Fei-Fei and Greg were undergraduate physics majors at Princeton together at the same time. And didn't really know each other that well in the 18-person class.
We were studying too
No,
hard.
it was kind of surprising to, go to undergrad together and then neither of us in computer science, and then rejoin later, only once we were here at
All
Google.
paths lead
Yeah.
to AI and neural networks and so forth. But anyhow, so Greg is a principal scientist in the Google Brain Group. He co-founded it. And more recently, he's been doing a lot of amazing work in health with neural networks and machine learning. He has a PhD in neuroscience from Stanford. And so he came into AI in a very interesting way. And maybe he'll talk about the similarities between the brain and what's going on in AI. Would you like to add anything else? Or?
No?
Yeah.
Sounds good.
Okay. So I thought, since both of them have been involved in the AI field for a while, and it wasn't, it's recently become a really big deal, but it'd be nice to get a little perspective on the history, yours in vision and yours in neuroscience, about AI and how it was so natural for it to evolve to where it is now and what you're doing. And start with Fei-Fei.
I guess I'll start. So, first of all, AI is a very nascent field. In the history of science, of human civilization, this is a field of only 60 years of age. And it started with a very, very simple but fundamental quest, is can machines think? And we all know thinkers and thought leaders like Alan Turing challenged humanity with that question, can machines think? So about 60 years ago, a group of very pioneering scientists, computer scientists like Marvin Minsky, John McCarthy, started really this field. In fact, John McCarthy, who founded Stanford's AI lab, coined the very word artificial intelligence. So where do we begin to build machines that think? Humanity is best at looking inward and ourselves and try to draw inspiration from who we are. So we started thinking about building machines that resemble human thinking. And when you think about human intelligence, you start thinking about different aspects, the ability to reason, the ability to see, the ability to hear, to speak, to move around, make decisions, manipulate. So AI started from that very core foundational dream 60 years ago, started to proliferate as a field of multiple subfields, which includes robotics, computer vision, natural language processing, speech recognition. And then a very important development happened around the 80s and 90s, which is a sister field called machine learning, started to blossom. And that's a field combining statistical learning, statistics with computer science. And combining the quest of machine intelligence, which is what AI was born out of, with the tools and capabilities of machine learning, AI as a field went through an extremely fruitful, productive, blossoming period of time. And fast forward to the second decade of 21st century, the latest machine learning booming that we are observing is called deep learning, which has a deep root in neuroscience, which I'll let you talk about. And so combining deep learning as a powerful statistical machine learning tool with the quest of making machines more intelligent, whether it's to see or is it to hear or to speak, we're seeing this blossom. And last, I just want to say, 3 critical factors converged around the last decade, which is the 2000s and the beginning of 2010s, which are the 3 computing factors. One is the advance of hardware that enabled more powerful, capable computing. Second is the emergence of big data, powerful data that can drive the statistical learning algorithms. And I was lucky to be involved myself in some of the effort. And then the third one is the advances of machine learning and deep learning algorithms. So this convergence of 3 major factors brought us the AI boom that we're seeing today, and Google has been investing in all 3 areas. Honestly, earlier than the curve. Most of the effort started even in early 2000s. And as a company, we're doing a lot of AI work from research to products.
Yeah.
And it's been really interesting to watch the divergence and exploration in various academic fields, and then the reconvergence as we see ideas that are aligned. So it wasn't, as Fei says, it wasn't so long ago that fields like cognitive science, neuroscience, artificial intelligence, even things that we don't talk about much more like cybernetics, were really all aligned in a single discipline. And then they've moved apart from each other and explored these ideas independently for a couple of decades. And then with the renaissance in artificial neural networks and deep learning, we're starting to see some reconvergence. So some of these ideas that were popular only in a small community for a couple of decades are now coming back into the mainstream of what artificial intelligence is, what statistical pattern recognition is, and has really been delightful to see. But it's not just one idea, it's actually multiple ideas that you see that were maintained for a long time in fields like cognitive science that are coming back into the fold. So another example beyond deep learning is actually reinforcement learning. So for the longest time, if you looked at a university catalog of courses and you were looking for any mention of reinforcement learning whatsoever, you were going to find it in a psychology department or a cognitive science department. But today, as we all know, we look at reinforcement learning as a new opportunity, as something that we actually look at for the future of AI, that it might be something that's important to get machines to really learn in completely dynamic environments, in environments where they have to explore entirely new stimuli. So I've been really excited to see how this convergence has happened back in the direction from those ideas into mainstream computer science. And I think that there's some hope for exchange back in the other direction. So neuroscientists and cognitive scientists today are starting to ask whether we can take the kind of computer vision models that Fei helped pioneer and use those as hypotheses for how it is that neural systems actually compute, how our own biological brains see. And I think that it's really exciting to see this kind of exchange between disciplines that have been separated for a little while.
You know, one little piece of history I think that's also interesting is what you did, Fei-Fei, with ImageNet, which is a nice way of explaining, you know, building these neural networks where you labeled all these images and then people could refine their algorithms by, go ahead and explain that just real quickly.
Okay, sure. So about 10 years ago, that the whole community of computer vision, which is a subfield of AI, was working on a holy grail problem of object recognition, which is you open your eye, you can see the world full of objects like flowers, chairs, people, you know, and that's a building block of visual intelligence and intelligence in general. And to crack that problem, we were building as a field different machine learning models. We're making small progress, but we're hitting a lot of walls. And when my student and I started working in this problem and started thinking deeply about what is missing in the way we're approaching this problem, we recognized this important interplay between data and statistical machine learning models. They really reinforce each other in very deep mathematical ways that we're not going to talk about the details here. That realization was also inspired by human vision. If you look at how children learn, it's a lot of learning through big data experiences and exploration. So combining that, we decided to put together a pretty epic effort of we wanted to label all the images we can get on the internet. And of course, we Google searched a lot. And we downloaded billions of images and used crowdsourcing technology to label all the images, organize them into a data set of 15 million images organized in 22,000 categories of objects, and put that together. And that's the ImageNet project. And we democratized it to the research world and released it open source. And then we, starting in 2010, we held an international challenge for the whole AI community called ImageNet Challenge. And one of the teams from Toronto, which is now at Google, won the ImageNet Challenge with the deep learning convolutional neural network model, and that was year 2012. And a lot of people think the combination of ImageNet and the deep learning model in 2012 was the onset of what Greg is
gave people a way to compare how they were doing.
Exactly.
And it was really good. So, yeah. And so, Greg, you've been doing a lot of brain-inspired research, very interesting research, and I know you've been doing a lot of very impactful research in the health area. Could you tell us a little bit about that?
Sure. So, I mean, I think you know, the ImageNet example actually sort of sets a playbook for how we can try to approach a problem. The kind of machine learning and AI that is most practical and most useful today is ones where machines learn through imitation. It's an imitation game where if you have examples of a task being performed correctly, the machine can learn to imitate this. And this is called supervised learning. And so what happened in the image recognition case is that by Fei-Fei building an object recognition data set, we could all focus on that problem in a really concrete and tractable way in order to compare different methods. And it turned out that methods like deep learning and artificial neural networks were able to do something really interesting in that space that previous machine learning and artificial intelligence methods had not, which was that they were able to go directly from the data to the predictions and break the problem up into many smaller steps without having being told exactly how to do that. So that's what we were doing before, is that we were trying to engineer features or cues, things that we could see in the stimuli that then we would do a little bit of statistical learning on to figure out how to combine these signals. But with artificial neural networks and deep learning, we're actually learning to do those things all together. And this applies not only to computer vision, but it applies to most things that you could imagine a machine imitating. And so the kinds of things that we've done, like with Google Smart Reply and now Smart Compose, we're taking that same approach, that if you have a lot of text data, which it turns out the internet is full of, what you can actually do is you can look at the sequence of words so far in a conversation or in an email exchange and try to guess what comes next.
You know, I'm going to interrupt here a little bit and get a little more provocative here.
All right.
So you're talking about, neural-inspired machine learning and so forth. And this artificial intelligence is kind of bringing into question what are we humans, and then there's this thing out there called AGI, artificial general intelligence. What do you think's going on here? Are we getting to AGI?
I really don't think so. There's a variety of opinions in the community, but my feeling is that, okay, we've finally gotten artificial neural networks to be able to recognize photos of cats, right? That's really great. We also, it's now can...
Fei, was that AGI when we recognized a cat?
No, that's not enough
Yeah.
to define AGI.
So the kind of thing that's working well right now is this sort of pattern recognition, this immediate response where we're able to recognize something kind of reflexively. And we now have, I believe, machines can do pattern recognition every bit as well as humans can. And that's why they can recognize objects in photos, that's why they can do speech recognition, and that's why they can win at a game like Go. But that is only one small sliver, a tiny sliver, of what goes into something like intelligence. Notions of memory and planning and strategy and contingencies, even emotional intelligence. These are things that we haven't even scratched the surface. And so to me, I feel like it's really a leap too far to imagine that having finally cracked pattern recognition after some decades of trying, that we are therefore on the verge of cracking all of these other problems that go into what constitutes general intelligence.
Although we have gone way faster than either of you ever expected us to go, I believe.
Yes and no. Humanity has a tendency to overestimate short-term progress and underestimate long-term progress. So eventually we will be achieving things that we cannot dream of. But Diane and Greg, I want to just give a simple example to define AGI. So the definition of AGI, again, is an introspective definition of what humans and human intelligence can do. I have a 2-year-old daughter who doesn't like napping. And I thought I'm smart enough to scheme to put her in a very complicated sleeping bag that doesn't get herself out of the crib. And just a couple of months ago, I was on the monitor watching this kid, 2-year-old, where for the first time, I was training her for napping by herself. She was very angry. So she looked around, figured out a weak spot on the crib where she might be able to climb out, figured out how to unzip her complicated sleeping bag that I thought I schemed to do really, to prevent that, and figured out a way to climb out of a crib that's way taller than who she is, and managed to escape safely and without breaking her legs.
Okay, how about AGI equivalent to my cat or equivalent to a mouse?
If you're shifting the definition, sure.
I see, okay.
But even cat, I think there are things that the cat is capable of doing. That,
so I do think that if you look at an organism like a cat from a behavioral level, like how cats behave and how they respond to their environments, I think that you could imagine a world where you have something like a toy that is for entertainment purposes that approximates a cat in a bunch of ways, in that the sorts of behaviors that the human observe, you're like, oh, it walks around, it doesn't bump into things, it meows at me every once in a while. I do believe that we can build a system like that. But what you can't do is you can't take that robot and then, dump it in the forest and have it figure out what it needs to do in order to survive and make things work.
But it's a goal. It's a healthy goal.
It's a healthy goal. And along the way, like you both, at least we all three agree that AI's capacity to help us solve all our big problems is going to outweigh any kind of negative, and we're pretty excited about that, I guess. Like in cloud, you're kind of doing some cool things with AutoML and so forth.
Yeah, so we talk a lot, Diane, about the belief of building benevolent technology for human use, right? Our technology reflects our values. So I personally, and I know Greg's whole team is working on bringing AI to people and to the fields that really need it to make a positive difference. So at Cloud, we're very lucky to be working with customers and partners from all kinds of vertical industries, from healthcare, where we collaborate, to agriculture, to sustainability, to entertainment, to retail, to commerce, to finance, where our customers bring some of the toughest problems and their pain points, and we can work with them hand in hand to solve some of that. So for example, recently we rolled out AutoML, and that is the recognition of the pain of entering machine learning. It's still a highly technical field. The bar is still high. Not enough people are trained experts in the world of machine learning. But yet, our industry already has so much need to, tag pictures, understand imageries, just as an example in vision. So how do we answer that call of need? So we've worked hard and thought about this suite of product called AutoML, where the customer, we lower the entry barrier by relieving them from coding machine learning custom models themselves. All they have to do is to give us provide the kind of data and concept they need. Here's an example of a ramen company in Tokyo that has many shops of ramens, and they want to build an app that recognizes the ramens from different ramen stores. And they give us the pictures of ramens and the concepts of their store 1, store 2, store 3. And what we do is to use a technique, a machine learning technique that Google and many others have developed called learning to learn, and then build a customized model for the customer that recognize ramens for their different stores. And then the customer can take that model to do what they want.
I can write a little C++, maybe some JavaScript. Could I do AutoML?
Absolutely. Absolutely. We're working with teams that they don't have not even C++ experience, and we have a drag and drop interface, and you can use AutoML that way.
Because I really believe that there are so many problems that can be solved using this technique that it's critical that we share as much as possible about how these things work. I don't believe that these technologies should live in walled gardens, but instead we should develop tools that can be used by everyone in the community, and that's part of why we have a very aggressive open source stance to our software packages, particularly in AI. And that includes things like TensorFlow that are available completely freely, and it includes the kinds of services that are available on cloud to do the kind of compute, storage, and model tuning and serving that you need to use these things in practice. And I think it's amazing that the same tools that my applied machine learning team uses to tackle problems that we're interested in, those same tools are accessible to all of you as well to try to solve the same problems in the same way. And I've been really excited with how much how great the uptake is and how we're seeing expanding to other languages. Mentioning JavaScript, quick plug for TensorFlow.js is actually really awesome.
Yep. Oh, and you should probably run it on a TPU.
Yes, exactly.
does give a nice boost. But so you're building, I mean, with machine learning, we're bringing it to market in so many ways because we have the tools to build your own models, the TensorFlow, we have the AutoML that brings it to any programmer. And then what's going on with all the APIs and how is that going to affect every industry and what do you see going on there?
So cloud already has a suite of APIs for a lot of our industry partners and customers, from translate to speech to vision to...
which are based on models that we built.
Yes,
Yeah.
For example, Box is a major partner with Google Cloud, where they recognize a tremendous need for organizing customers' imagery data to help customers. So they actually use Google's Vision API to do that. And that's a model easily delivered to our customers through our service.
Yeah, it's pretty exciting. I mean, Greg, how do you think that's going to play out in the health industry? I know you've been thinking about that.
Yeah. So healthcare is one of the problems that a bunch of people are working on at Google and a lot of people are working on outside as well, because I think there's a huge opportunity to use these technologies to expand the availability and the accuracy of healthcare. And part of that is because doctors today are basically trying to weather an information hurricane in order to provide care. And so I think there are thousands of individual opportunities to make doctors' work more fluid, to build tools to solve problems that they want solved, and to do things that help patients and improve patient care.
I mean, I think you were telling me that so many doctors are so unhappy because they have so much drudgery to do. Is this a big breakthrough?
Yeah,
or?
Absolutely. I mean, I believe that there's been a great, when you go to a doctor, you're looking for medical attention, right? And right now, a huge amount of their attention is not actually focused on the practice of medicine, but is focused on a whole bunch of other work that they have to do that doesn't require the kind of insights and care and connection the real practice of medicine does. And so I believe that machine learning and AI is going to come into healthcare through assistive technologies that help the doctors do what they want to do better.
By understanding what they do in a system. No substitute for the human to human.
No, I don't think so.
Yeah.
No substitute.
Speaking of human, Fei-Fei, do you want to talk a little bit about why you think this humanistic AI approach is so critical?
Yeah, thank you. So if we look at the history of AI, we've entered phase 2. The first 60 years is AI as more or less a niche technical field where we're still laying down scientific foundations. But starting this point on, AI is one of the biggest drivers of societal changes to come. So how do we think about AI in its next phase? What is the frame of mind that should be driving us? Has been on top of my mind. And I think deeply about the need for human-centered AI, which, in my opinion, includes 3 elements to complete the human-centered AI thinking. The first element is really advancing AI to the next stage. And here we bring our collective background from neuroscience, cognitive science. You know, whether we're getting to AGI tomorrow or in 50 years, there's a need for AI to be a lot more flexible, nuanced, learn faster in more unsupervised, semi-supervised, one-shot learning ways, to be able to understand emotion, to be able to communicate with humans. So that is the more human-centered way of advancing AI science. The second part is the human-centered AI technology and application, is that I love what you're saying, that there's no substitute for humans. This technology, like all technology, is to enhance humans, to augment humans, not to replace humans. We'll replace certain tasks, will replace humans out of danger or tasks that we cannot perform. But the bottom line is we can use AI to help our doctors, to help our disaster relief workers, to help decision makers. So there is a lot of technology in robotics, in design, in natural language processing that is centered around human-centered AI technology and application. The third element of human-centered AI is really to combine the thinking of AI as a technology as well as the societal impact. We are so nascent in seeing the impact of this technology, but already, like Diane said, that we are seeing the impact in different ways, ways that we might not even predict. So I think it's really important, and it's a responsibility of everyone, from academia to industry to government, to bring social scientists, philosophers, law scholars, policymakers, ethicists, and historians at the table, and to study more deeply about AI's social and humanistic impact. And that is the three elements of human-centered AI.
That's pretty wonderful, and I think we at Google here, Alphabet, are working as hard as we can to do humanistic AI. You know, you mentioned you know, what we need to be careful about out there with AI and regulatory. What are some of the barriers to, you know, I think every company in the world has a use for AI in many, many ways. I mean, it's just exploding in all the verticals. But there are some impediments to adoption. For example, in the financial industry, they need to have something called explainable AI. And could you just talk about some of the different barriers you see to being able to take advantage of AI?
We should start with healthcare.
Yeah, so I think that there are a bunch of really important things to consider. So one of the things is, of course, we want to have machine learning systems that are designed to fit the needs of the folks that are using them and applying them. And that can often include not just giving me the answer, but telling me something about how that was derived. So some kind of explainability. So in the healthcare space, for example, we've been working on a bunch of things in medical imaging. And it's not acceptable to just tell the doctor that, oh, you know, something looks fishy in this x-ray or this pathology slide or this retinal scan. You have to tell them, you know, well, what do you think is wrong? But more importantly, you actually have to show them where in the image you think the evidence for that conclusion lies, so that they can then look at it and decide whether they concur or they disagree, or, oh, well, there's a speck of dust there, and that's what the machine is picking up on. And the good news is that these things actually are possible. And I think there's kind of been this unfortunate mythology that AI and deep learning in particular is a black box, and it really isn't. We didn't study how it worked because for a long time it really didn't work that well. But now that it's working well, there are a lot of tools and techniques that go into examining how these systems work, and I think explainability is a big part of it in terms of making these things available for a bunch of applications.
So in addition to explainability, I would add bias. I think bias is an issue we need to address in AI, and I see bias from where I sit, two major kind of bias we need to address. One is the pipeline of AI development, starting from the bias of the data to the outcome of the bias. And we have heard a lot about if the machine learning algorithm is fed with data that does not represent the problem domain in a fair way, we will introduce bias. Whether it's missing a group of people's data or biasing it to a skewed distribution, these are things that would have deep consequences, whether you're in the healthcare domain or finance or legal decision making. So I think that is a huge issue. Very nicely that Google is already addressing that. We have a whole team at Google working on bias in this.
That's true.
And another bias I think it's important is the people who are developing AI. It's the human bias. And the lack of diversity is also another bias.
It's so important, and that kind of brings me to maybe we're getting close to the end, but if you, where is AI going? I mean, how prevalent is it going to be? I mean, we look at our universities and these machine learning classes have 800 people, 900 people. You know, there's such a demand. Every computer science graduate wants to know it. Where is it going? I mean, will every high school graduating senior be able to customize AI to their own purposes? And how will, what does it look like 5, 10 years from now?
So from a technology point of view, I think that because of the tremendous investment in resource, both in the private sector as well as in the public sector now, many countries are waking up to invest in AI. We're gonna see a huge continued development of AI technology. I'm mostly excited either at Cloud or seeing what Greg's team is doing, AI being delivered to the industries that really matter to people's lives and work quality and productivity. But Diane, I think you're also asking is, how are we educating more people in AI, right? So
both making it easier to use and educating them, and what's it going to look like? What do you predict?
So, that's a really tough question because at the core of today's AI is still calculus, and that's not going to change.
So I think that from the tech industry perspective or from the computer science education perspective, I think that we're going to see AI and ML become as essential as networking is, right? Like, no one really thinks about, oh, well, I'm going to write some software and it's going to be standalone on a box and it's not going to have a TCP/IP connection, right? Like, we all know that you're going to have a TCP/IP connection at the end of the day somewhere, and everyone understands the basics of the networking stack, and that's not just at the the level of engineers, that's at the level of designers, of executives, of product developers and leaders. And the same thing I think is going to happen with machine learning and AI, which is that designers are going to start to understand, how can I make a completely revolutionary kind of product that folds in machine learning the same way that we fold in networking and internet technologies into almost everything we build. So I think we're going to see tremendous uptake and it becoming kind of a pervasive background part of the technologies. But I think that in that process, the ways that we use AI are going to evolve. So I think right now, you're seeing a lot of things where AI and machine learning adds some spice, some extra little coolness on a feature. And I think that what you're going to see over the next decade is you're going to see more of a core integration into what it means for the product to actually work. And I think that one of the great opportunities there is actually going to be the development of artificial emotional intelligence that allows products to actually have much more natural and much more fluid human interaction. We're beginning to see that in the assistant now with speech recognition, speech synthesis, understanding dialogues and exchanges. But I think that this is still in its infancy. We're going to get to a point where the products that we build, they interact with humans in the way that the humans find most useful, just out of the box.
And I spend a lot of time with high schoolers because I really believe in the future. You know, we always talk about AI changing the world, and I always say the question is, who is changing AI? And to me, bringing more human mission thinking into technology development and thought leadership is really important. Not only important for the future of our technology and the value we instill in our technology, but also in bringing the diverse group of students and future leaders into the development of AI. So, you know, at Stanford, at Google, we all work a lot on this issue, and personally, I'm very involved with AI for All, which is a nonprofit that educates high schoolers around the country from diverse backgrounds, whether they're girls or or students of underrepresented minority groups, and we bring them onto AI, onto campus, university campus, and work with them on AI thinking and AI studies.
And at Google, we're just completely committed to bringing all our best technologies to everybody in the world, and we're doing that through the cloud, and we're bringing these tools, we're bringing these APIs, and the training, and the partnering, and the processors, and we're pretty excited to see what all you guys are going to do with it. Thank you very much.
Thanks, everybody.
This is I/O Live. I'm Timothy Jordan, and I'm at the Community Lounge. This is where anybody can swing by, meet up with old friends, or make new ones. I'm going to go find some certification alumni to talk to them about the program. Hey, Marga. Hi, everyone. How you doing?
Doing good. How are you?
Awesome.
Really great.
I'm sitting here with Henry, Ashesh, and Somya, and they're all alumni in the certification program. I'd like to ask you just a few things about the program, if that's okay.
Yeah, sure.
Let's start with, how did you get involved? Like, what made you want to get certified?
So, actually, before in Indonesia, they have like a scholarship. So they give out the 500 scholarship for the people to take with the Udacity and certifications. And I registered on that one, and I got it. And then after that, I tried the certifications, and yeah.
So your path was some scholarships to certification?
Yes.
Ashesh?
Okay, so if you see the reason I went for the certification, in our professional life, we strive for a few things. One of them is to prove the worth to ourselves, and second is to prove our worth to others. So to proving worth to ourselves, we go for a benchmark, right? We try to achieve it. So for me, that certification was a benchmark, a milestone achieved. And once I've achieved that, there's only one way, that is to go for something higher, right? So this was one reason to prove myself the worth, so that I can, go for more higher things. So certification was a commitment to me, to myself, to go for in search of more knowledge. And second thing is to prove worth to others. So if you see, when you go for the job, there are various phases. There are interviews, there are tests and everything. But the first phase is always the qualification. What degrees do you hold? What certifications do you hold? If you don't cross that door, there's no point. I mean, you might be a very good programmer or something, but to have a certification, you always have a key to open a door. So that was the other thing which I went certification for. So in short, to gain confidence and to be job ready. Right?
Thank you. And Soumya?
So I've been working on Android since 2010. What pushed me to do the certification was probably that, like Ashish said, there's a benchmark or there's a standard with a certification. And after working for so long in Android, worked on various kinds of applications, how do you differentiate yourself from the others?
Thank you. Can you each tell me one thing that has been helpful in your career because of certification?
Sure. So actually, in my current organization, we now have a team of about 20 mobile developers, mobile team more or less. And what I noticed was we had the support of the management for conducting various certifications and things like that. But when we did the certification, and I told my team that, see, I did this and it was cool, and it gave a validation to the team also that how we are doing this. And after that, very quickly, we have almost 10 team members now who are certified already. So that was a big boost, energizer to them too, from a team lead to the rest of the team saying that, oh, you should do this. And then that has worked out very positively for them.
I work for Paradise Publisher saying we're into ebook publishing. So we provide a platform to indie authors. For that, we have an app, Android app. So the thing is that we had outsourced it to some other company. So when we outsource something, we have to engage our resources. And not being a large company, this could be a problem, right? So we had to talk to them about exposing our internal APIs, and then our boss had to sit with them. So this was the one thing which motivated. Like when I was getting into Android, that point of time, I thought, okay, I will try to make the Android app in-house for my company. But the certification was not there, so I was also a little hesitant to ask my boss that to give this job to me, because the app matters as such financially. Once I got the certification and I told my boss, he was very happy about it, and of course he was quite confident. So till now I have developed 2 Android apps for my company that is in-house. So we have more control over the app, especially since I'm working already, I know the back end and everything. And our consumers also get a more robust and something, more user-friendly app. So this certification has helped me to gain the confidence with my boss and to move my career in Android app development.
Before I took the certifications, it's like whenever I apply to a company, I always choose the Android developer job. And then they always give me the interview for iOS developer job. So, and then I try the certifications, and then after I get certified, it's naturally, it just knocked them to their senses that, okay, I'm certified by Google. So then they give me more chance. They give me chance for interview, for the test.
Yeah.
Otherwise, before it, no one, they just give me the test for iOS.
Thank you all so much for sharing your story with me today.
Thank you, thanks a lot.
If you'd like to learn more about certification, head on over to g.co/dev/certification. I'm Timothy Jordan, and this is I/O Live.
Having a technical background or having technical knowledge, do you think that it can help make the creative process burgeon and grow, or do you think it can hinder the creative process?
It can go both ways, but I've definitely found myself early in my career kind of noticing that, yeah, I've started thinking about how to actually implement a design, and that sometimes hindered my design process because I was thinking so much of how to actually make the solution happen.
That's quite a challenging thing. So how did you manage to break through so it's not stopping you, but maybe enhancing the stuff that you actually do?
I think one of the things that I always struggled with is that from a visual standpoint, like, I'm not a super talented visual designer. I've seen some amazing visual designers that I'm just like, oh my goodness, like that is really, really slick, and I love that, and that's not like my strength. And so I was came back more from like the coding perspective, being able to actually implement some stuff in code, which they couldn't. But there was this deciding factor of realizing, am I more of a designer or more of a developer? Like, I'm not necessarily that great at the graphics, but there's still so many other ways of design that can kind of spread in. So really like doing some research and finding out more about UX design and realizing that is really kind of what I wanted to focus on, is kind of what led me to that. So it's it definitely was this kind of process of navigating through it. It's like, where do I fit? Am I a designer? Am I a developer? From the first projects that I started doing, a lot of the time I did a lot of websites, and when people come to you, they go, hey, we need a website built. They don't necessarily say, hey, we need a front-end developer to come do this, especially if you're working with smaller businesses and clients. So you do take on the designer and developer hat to kind of make that happen.
A lot of developers are very afraid to learn about design. It's like, because I get question like, if I was to write an article, the perfect article for the developers would be how to learn to design, or how do you which makes no sense to me, because learning to design doesn't really mean anything. It's just like, what part of design, what discipline of design. But there's still that question of, okay, what is the first step that someone who wants to really, as someone who's gone through this process yourself, what was your first step to say, okay, that's it, I'm becoming a designer?
Right. I think, following a lot of design patterns, at that time I didn't really understand that they were called design patterns, right? You implement them in the sites doing a lot of web work. You kind of take on, okay, the navigation menu, where does that live? And you're following a lot of the patterns that have already been created. And so you kind of learn to explore through that, and then, testing out the site and realizing, oh, this doesn't feel right, like something's off. Let's work on how to make this better. But I think one of the great things that can really help a designer or developers wanting to go into design is looking at a lot of like the material spec guidelines are actually really, really helpful, because not only does it actually tell you, hey, here's some guidelines of what to follow, but it actually does a really good job of explaining why you're doing a certain thing.
And the rationale and logic.
And yeah, exactly. So that actually is really helpful, because then you're able to understand, why was this created? Like, what was the thought process behind adding potentially a bottom navigation, or why would you have a side nav? It's really getting to kind of explaining that, so you're able to learn from actually interacting with something and seeing how they're doing it, but also finding out why they decided to do that. Because I think so much of design is it's problem solving, right?
Yeah.
So many people forget that when they think of design, they think of the finished product, but there's so many different stages of how you got to that finished product. And so a lot of it, being able to understand how someone was thinking through that really, really helps you, from a development perspective, get into that design field of understanding, oh, okay, how do I get from thinking of how do I develop this versus how do I even arrive to the solution? I think that's kind of the big difference there. As developers, you have something that's already designed for you for the most part. I mean, some people get handed things. Some people get handed an iOS mock and said, hey, make this into Android. So then at that time, you kind of become an Android designer in that aspect.
What do you think is like the biggest thing that stops developers really understanding design?
One of the things that we do at Google is we do design sprints. So the design sprints are really great because it brings people from all the different disciplines and specialties together to work into solving a challenge that we have. So you have product managers, engineers, designers, researchers, everyone in the room together and kind of thinking and working through a problem, which is really fantastic because you get all these different ideas. And one of the things that I really notice is as we're bringing in designers, and engineers and all these people together, is when we're walking through the challenge, the engineers are already thinking of the solution and already thinking about how to implement it. They go straight to that, which makes sense. That is their role, right? As engineers, usually you are given something and you have to go, oh, how do I make this happen? How to thinking through problem solving, how to actually get to that solution. Whereas designers, we don't know what the solution necessarily is. So I think a lot of the blockers is automatically wanting to know the answer instead of being more aware and being okay with saying, I don't know the answer to that, but let's explore it together.
Yeah.
So I think that's the biggest hindrance that can really stop developers into getting into design, is wanting to have all the answers. It's okay not to have them.
I mean, and what do you think developers can actually do to get past that? I mean, because I find, for me, it's always sketching and just experimenting. Right. So I suppose it's how does the developer maintain that kind of playful space where they're not thinking, right, here's the library we're going to use to do a whatever widget or a fab or whatever, but what can they actually do that allows them to not thinking about the end result or breaking from that cycle?
Yeah, you actually bring up a great point with sketching. That's probably one of my favorite exercises when I'm working with different people to get them thinking of solutions. So it's particularly if you're developing an app or so, is, hey, let's get some sketches out there, get a Sharpie, and just start sketching out through some ideas. Because that really that doesn't, you can really get some ideas on paper and not be married to them, you know, and not feel like really connected because you spent all this time developing the solution and realizing, oh, it doesn't really work. And so if you start really low fidelity with some sketches, that can really open up your mind in terms of thinking about different solutions, because as you're sketching through it, you're realizing, oh, like maybe I want to use this fab button or something, or everyone loves fab, right? So you want to incorporate it somewhere, and then you realize, maybe that's not the right thing to do, and I haven't spent all this energy developing or even designing this, so then I can kind of toss that and move on and create a different solution. So sketching, I think, is a great resource instead of people go straight. A lot of people like to prototype in the code. But I usually like to challenge people and go, hey, start sketching some ideas, and then once you've landed on something that you think you want to explore some more, then dive into code or dive into Sketch or whatever you're using.
So I suppose for the engineer to really understand design is almost like, okay, just start sketching first and start thinking about the thing you're going to build and the possibilities rather than straight to the end solution.
scroll over a little bit.
All right. Welcome to migrating your Android app to Android O and beyond.
Hi, I'm Fred Chung, developer advocate.
Hi, I'm Dan Galpin, developer advocate.
Hi, I'm Eric, not a developer advocate. I'm the lead software engineer responsible for migrating the Google Play Store app to Target API 26.
Thank you for joining us on the afternoon of the last day. This is where they schedule the most anticipated sessions, except for that funny improv one that we don't record. Sorry, home viewers. So you're here for what is really the grand finale of Google I/O.
Well, let the grand finale begin. So why migrate? There are lots of reasons, but foremost in your mind, especially if you're distributing on Google Play, is that for new apps, by the end of this year, in August 2018, you must be targeting at least API level 26 or Android 8.0. Likewise, for app updates, they must also be targeting at least API level 26 by November of 2018. That is if you wish to continue releasing app updates going forward.
Now, every new Android version introduces changes that bring significant security and performance improvements and enhance the experience of Android overall. And now, some of these changes only apply to apps that explicitly declare support through their Target SDK version manifest attribute, also known as the Target API level. In fact, if you try to upload an APK with the Target SDK less than 26, you'll begin to see a friendly reminder like this.
And I'm here because we wanted to keep updating the Play Store app on Google Play after the November deadline.
So let's go over some basics real quick, everyone. Minimum SDK is the lowest platform version your app is willing to support. It's often a decision tied to market penetration of various Android releases.
The Compile SDK is literally the SDK headers and stub library that your project links to.
And the important one, of course, is the one I'm talking about. The Target SDK version is the platform's way to ensure backwards compatibility. This means that you only have certain behavior changes applied at certain specific Target SDK versions.
So technically, this needs to be true. And this is the typical and recommended case since you probably care about 95% of users out there that are not quite targeting the latest versions of Android just yet, although we are working to improve that.
So if you don't change your Target SDK to at least version 26, you might not have to deal with things like runtime permissions, alarm manager changes, coming up with different ways to handle broadcast receiver actions, and avoiding background services.
But there's a good chance that your app would waste network and battery while making the device experience less fast and fluid.
So if you are migrating from a pre-M version, one of the bigger changes is probably the support for runtime permissions. Runtime permissions are really about user privacy and trust, but it's also allowed for apps to ask for sensitive permissions in context. And that's a good thing for apps because you don't want someone to not install your apps just because you are asking for permission for some sensitive information in one particular flow within your app. So first of all, it's not all permissions are runtime ones, just this simple, easy to remember list.
But worry not, developers. You can think of the permissions the way the user sees them in terms of these broader categories. And the first question you should have is whether the app really needs the permission at all. After all, removing the permission is easy. Now, Eric, how did the Play Store app handle this?
Well, it's simple. All you need to do is make sure that your app is pre-granted the permissions on the system image.
That's not very helpful, Eric.
That being said, we too try and use as few of these as possible.
And of course, just because your app isn't yet targeting M, it doesn't mean that your users can't go and disable any permissions they don't want you to have.
And there are special permissions that you need to redirect the user to settings to obtain. For example, drawing overlay windows, or there could be some per-session permissions like screen capture.
Now, being the work of the UI, runtime permissions actually require an activity or fragment that has overridden the onRequest permission result method. Now, this means that your view layer, like activities and fragments, need to anticipate any permissions actually required by the other layers. All right, here's a great transition. Let's talk about alarms. Alarms in Android take two basic forms. They are literal alarms that allow an app to wake itself up to deliver a notification of some real-time event, such as waking you up, or an upcoming appointment. Or they are a way of scheduling work to happen at some time in the future after the app is closed. And at the beginning of Android, this was a single API. But back in KitKat, we made Alarm Manager not exact unless it was explicitly requested, which makes it better for scheduling future work. Now, if an app needs to notify the user at a precise time, we added the method setExact. And here's where we've implemented a method in the support library to call it on KitKat and above.
We don't use any exact alarms in the Play Store app. The alarms we do use are inexact, which allows the system to batch them for better battery and system health.
Now, Android Marshmallow added doze, which allowed Android to go idle when alarms would normally fire. So we added the obvious method, setExact and allow while idle, to allow ARMS to wake the device from doze. And we've implemented a method in the support library for that as well. And note that it actually calls the previous support library method for setExact on earlier platform versions.
So after all of that exposition, so the takeaways are pretty simple, right? Consider moving future work to GCM, job via Work Manager. Work Manager is the new work scheduling thing that we launched.
Now, Work Manager is a part of Jetpack, and it chooses the best way to run your tasks based upon things such as API version and app state. And when it becomes stable, it will be the recommended API for running tasks, unless we come up with something better before then.
Play Store was able to see our background tasks regularly reach 2% more users on KitKat when we adopted Firebase Job Dispatcher rather than just using alarms. This improves system health and battery usage. If you do have to use alarms, use the least exact ones you can.
Now, remember that the most exact alarms, like while Lido, should only be used every 15 minutes or so. So you should only be using those judiciously.
Oh yeah, Work Manager. So let's talk again about broadcast receivers.
Should we talk about broadcast receivers?
We should talk about
them. That.
Yes.
So broadcast receiver, I think many of you probably know that, right? That's used by the platform to notify and launch apps in response to system-wide events. It's one of the reasons that Android has such a powerful API surface.
Now, with great power comes great responsibility. And in response to the way that these endpoints have been used, most of these can no longer launch your app, at least once you target O.
Well, there are exceptions, of course. It's Android, right? Many of these happen very rarely, such as changes in locale, or in some cases, there are just no alternatives just yet to the broadcast for the apps that need them. For example, like those USB accessory ones. Let's check out an example on how to avoid using broadcasts. So for a job, right, you can do so by setting up the proper execution criteria, such as requiring network service. And then we can have functionality that's comparable to listening to network state change broadcasts. And if you do have code like this in your manifest on older versions of Android, you can disable the listener to the connectivity change and just leave it disabled. And then what are you going to do? You can then enable the receiver by setting the component enable setting in the package manager.
Another exception is if you need to perform any tasks after your package has been updated. For example, rescheduling alarms or updating your database. You can still register a receiver in your manifest for the action my package replaced, which continues to work because it's one of the explicit broadcasts targeted just to your app.
Now, if you really need to do some work in every package update, and you probably don't, because you can no longer be launched by action package replace events, but we do have an API called Get Changed Packages, which allows your app to see what packages have changed since the previous save sequence number. Now, In life, running is usually healthy. I probably should do more. But an Android app wants to run as little as possible. And lazy apps are actually better apps. And I should make a manifesto or something. Fred, what do you think that we should actually...
Sounds good to me. First of all, let's talk about what it means to be in the foreground. Because it's not completely obvious, right?
Wait.
There are some typical cases, like when your app is visible to users, or when you're using foreground servers, or if your app is bound to a foreground app. So your app is also in the foreground in these exceptional cases. Your app is in the background when you're not visible, such as when it's running a standard service, job service, or broadcast receiver. And when you're on O+, starting a service when running in the background will throw an exception called illegal state exception, which is not good.
Now, you can start services when your app is in the foreground, and they'll continue to run for about a minute after your app is backgrounded. And this is particularly important because on O, the system releases any wake locks that your app holds when you have no active components, such as activities or services. And this applies to all apps, not just apps targeting O.
There are a few cases where your app is still allowed to run if it's foreground and start services. For example, in response to notification, action, a high-priority Firebase Cloud message, or in response to MMS or SMS delivery. So let's talk through some solutions for running in the background without background services.
First of all, use GCM Fire Work Manager for background tasks. Now, there are very many good reasons for this. It creates a consistent API surface across many Android versions, for example.
Or, if you don't care as much about having your app behave consistently across platforms, but want to move to O with the least amount of work required, you can also use Job Intent Service.
But seriously, consider using Work Manager. Leverage its constraints and make your life easier.
So, the Google Play Store app didn't have the luxury of using Work Manager because it didn't exist yet. That meant we had to use Job Scheduler and Firebase Job Dispatcher. Now, the first thing we learned is not to use Job Scheduler on Android L unless you really understand how it behaves, and have alarm watchdogs when it doesn't behave as expected. Also, use workarounds. For example, on L and the first release of M, Job Scheduler won't actually run two jobs won't actually run your job unless there are two jobs with the same constraints met. You can work around this by scheduling two jobs with matching constraints.
But seriously, like Work Manager.
Work Manager.
Things do get much better for Job Scheduler on M, MR1, and above. However, another quirk is that you should avoid calling set minimum latency to 0. This can interfere with the override deadline on some releases. The override deadline is a way of making sure that your job runs with a fixed period of time, even if the constraints aren't met.
Or you could just use Work Manager, which doesn't actually have override deadlines, but what you should do is schedule a second job as a watchdog to perform a similar function.
Here are a few things to consider when using Job Scheduler or Work Manager. Android tries to detect captive portal and poor network conditions, but it's an imperfect art. In addition, Android will occasionally wake up your app right before network is available to your app. All this means is that you need to have proper error handling to ensure rescheduling of jobs. When Play Store added exponential backoff to our jobs, we saw 19% more successful background tasks. The key here, though, is let the system do its work. It's easy to make the mistake of rescheduling with the same job ID while also using system backoffs. This can interfere or even reset the backoff rate.
Or with Work Manager, actually, yeah, don't do that either, because it'll have the same result.
So for APIs that require that you use pending intents, you can change the pending intent targets from a service to a broadcast receiver. Now, if your task will execute within 30 seconds, you can then call GoAsync and run your work right within the broadcast receiver, which, by the way, is a super lightweight way of getting something done. Note that you aren't guaranteed to have network or wake logs, so there are still many cases where you should
schedule a job within your broadcast receiver using Work Manager.
So if you have externally triggered time-sensitive events that require immediate user attention, consider using Firebase Cloud Messaging to notify your app. FCM supports high and normal priority messaging. For high priority messages, it'll wake the device from those, which means that a lot of them won't be a good thing for system health. If the task can run within less than 10 seconds or so, you can execute it right away, else schedule a job with
Work Manager. There are actually cases when foreground services are desired or required. Ideally, these are user-initiated tasks that run for a long time and want to supply some sort of constant update to the user. Examples are maps, navigation, fitness tracking, playing music.
In Play Store, we use a foreground service when we restore apps after device setup. This is OK because it's long-running work in response to user interaction.
But it's not as fun as listening to music.
So the good news is that these other things are already impacting your apps, but perhaps you haven't noticed yet. That. So in Android N, new photo broadcasts no longer happen, right? But can be replaced by trigger content URIs for jobs, work. So here's what it looks like using the new Work Manager API.
Now, if your app is running in the background on an Android O+ device, the location system service computes a new location for your app less often, even if your app requests more frequent updates. Even full Wi-Fi scans are only performed for background apps a few times every hour. So if you're called more often, the Wi-Fi Manager cache actually will just provide cached results. Now, if you need to know when the user reaches a specific location, use geofencing. Now, there are only 100 geofences that can be active, so if you need more sites than that, you can actually use regional geofences to swap in and out different sets of geofences as needed. Now, that being said, beacons are awesome. You can use the Nearby Notifications API, and that's important, particularly if you're a certain prolific coffee vendor.
You can also use the batch version of the Fuse location provider. Specify a maximum location update wait time that is acceptable for your use case, and the system will attempt to batch location updates so that your app is woken up less frequently. This will optimize battery use. You can also use passive location. That enables your app to opportunistically piggyback on other apps' location updates, up to the fastest interval specified. Keep in mind, though, that if your app's location updates are tied to any expensive operations, such as network calls, you should throttle those as well.
So, through batching and passive location, we can work with location updates in a power-efficient manner. Next, let's go through some related improvements in the platform. So in the past several releases of Android, we've introduced a series of battery optimization features that are based on deferring and restricting background tasks. So you probably are familiar with some of these already. For example, a device could enter those where when the device is unplugged and when the device isn't being used for quite some time. In those, apps have to finish any pending jobs in some periodic maintenance windows.
On N+, DOS is extended for on-the-go use cases, such as when a device is sitting in the user's pocket. Now, App Standby was introduced in M, where it imposes tax restrictions based upon app usage.
And let me tell you about the brand new stuff. In Android P, usage-based restrictions are applied in a more fine-grained way. You may have already learned about this in the earlier I/O talk. Don't let your app drain your user's battery. Apps will be added to one of the app standby buckets based on usage. The system applies progressively more restrictions to your app as it goes from the active to the rare bucket. Additionally, Battery Saver is enhanced in P. It allows users to have extended battery life by prioritizing battery over everything else. This leads to some degradation in functionality, such as location requests, which are not available when the screen is off. However, this mode is really useful when you need your device to last just a bit longer.
So the features that we just discussed have additive impact on an app's alarms, jobs, sync, network access, and FCM messages. So we really strongly encourage everyone to thoroughly test these scenarios within your applications.
And the good news is that there are tools for that. So for example, this ADB command forces the device into an idle state, making all apps doze.
To test app standby, first simulate unplugging the device, and then you can use the get and set inactive commands to get the device in and out of app standby.
For app standby buckets, you can get and set buckets for a given package using similar AD commands. But remember to simulate unplugging your device before testing. There's also framework APIs available to do that. Finally, these are the commands for testing battery saver. One note is that if your app's UI has the dark theme, you can consider enabling the dark theme when battery saver is turned on to further conserve power on OLED devices. Through Power Manager, you can check with an API and listen to a broadcast to do that.
So there are lots of ways to make your apps do cool stuff in the background without using foreground services. Leverage the new functionality in Work Manager, use efficient location strategies, use the new APIs, and make sure to tell us what doesn't meet your needs by submitting feedback through the issue tracker.
So right after this talk, you'll probably be busy updating your Target SDKs, which is all good. While you're at it, we strongly encourage you to check out some selected modern features on Android that are relevant to your use cases. So you have to add, for example, notification channels to your app on O. Otherwise, well, notifications just won't show, which won't be good. Plan your channels carefully so that your users can selectively turn off notifications that they don't want.
Back one slide, please.
On devices where the Play Store implemented support for notification channels, we see a fewer percentage of users disabling all of our notifications.
So if your app is using a translucent status bar, you can use the inset APIs to make sure that your code doesn't assume that the status bar is a fixed size. Now, if you're using the navigation drawer, this is actually really common. Now, if you target P, you can also do something interesting in that cutout area. Now, public service announcement, you don't have to put your system image on your only device. If you haven't used the emulator in a while, it's pretty awesome. Recently, we've added support for super fast loading along with AR support. On any device with the pDeveloper Preview system image, you can simulate display cutout through the developer options. This ends the public service announcement.
Great. So long aspect ratio screens. So it's become a trend for OEMs to be shipping devices like these with screens longer than 16:9 aspect ratio. Make sure your app's immersive experiences can fully take advantage of these screen capabilities, which is pretty awesome. So as a last resort, right, the system still provides you a way to declare your maximum supported aspect ratio, but it'll display a letterbox around your application.
And seriously, do you really want letterboxes?
With bigger screens comes more responsibility. Now, consider taking advantage of picture-in-picture for use cases such as video chat, movie playback, fitness tracking, or Pokemon Go. Multi-display support also allows the user to launch an activity for your application on a second display. And the only thing you have to really consider here is it has a second configuration, which is going to be different than the one in your app, most likely. So be careful not to make application-wide assumptions about hardware configuration. And in conclusion, Android development has evolved to mean using the latest tools and APIs to enable better battery life, smoother multitasking, supporting the latest hardware and platform features, and taking advantage of Jetpack to build a modern, testable architecture. Thank you. All right. Actually, no. There's actually one more thing. Android is actually restricting the use of some non-SDK interfaces in Developer Preview 1. And you saw this because we actually warned you with like toast and log entries if these methods were used. But you'll notice if you're testing against DP2, some of these methods will just seek to work and will cause your app to crash. So please test and file issues if you don't think there's any way your app can work other than these methods. And to help you out in the future, we've actually added a new VM policy for strict mode that you can use to turn on and detect all non-SDK API usage, which is really important because this non-SDK usage may actually be happening in your libraries. So this is a really great way to actually make sure that your app is going to be compatible going forward, because we don't guarantee the compatibility of any non-SDK API. And so that really is it now. If you haven't been paying attention in the last 30 minutes, that's okay, because clearly my jokes need work.
If you're an engineer, hopefully much of the information shared today was a review for you, and we hope you found the tips useful.
So if you're a PM and if your app is not quite targeting 26 just yet, it's not too late to plan things out, work with your teams to figure out how much work is needed. And in fact, we've prepared a guide on Android developer sites to help people understand, based on your current release, the amount of work needed so that we can collectively push the ecosystem forward. Thank you very much.
So let us know what you think. Now, if you don't ever want to see us present here at I/O again, this is your chance to make sure this never happens again.
Right. So just target straight to P.
So thank you very much.
Thank you.
Oh, if you
Hey there, everybody. Todd Kerpelman here at the accessibility section of the Sandbox, and I am joined by Patrick Clary, who is a product manager here at Google. Hi, Patrick.
Hi, how's it going?
It's going pretty well. So tell us what's going on here at the Accessibility Sandbox.
Yeah, so in the Sandbox, we're doing various things. We're showing demos of Liftware. We're showing off some of our wheelchair accessible transit directions we have in Google Maps. We're showing off our automated captioning for YouTube. We're doing accessibility design reviews over here. And we're also showing a brand new product, which we announced yesterday, called Lookout.
Oh, and what is Lookout? Tell me more about that.
So Lookout is a product for users who are blind and low vision, and the goal is to help them become aware of physical objects in the space around them. For example, people that might be present, text in their environment, and also physical objects or products.
Can we see a demo of Lookout telling us what's in our environment?
Yeah, let's do that. So I have the app here, and I'll go ahead and select the icon. And then for this, I'll select an experimental mode, because that's kind of fun, right? And we'll see what it shows.
Drink with text NB18NOND. ISVO HIMON.
So it detected some text on that, and it read it out. As you can see, it said Murphy, which is the brand of wine we have here. Let me point it at this glass and see what it does.
Wine glass at 12 o'clock.
So what else can you do with Lookout?
Well, one interesting about Lookout is it's designed to basically be worn, so we can put it in a lanyard like this. And this allows the user to be hands-free and just engage in their activity. And there's controls that facilitate this. So for example, if I want to start recognition, I can knock on the device. And then if I want to pause recognition, I can cover the camera. There we go.
And if I'm interested in trying Lookout, where would I be able to get it?
Yeah, so we'll be rolling out to trusted testers pretty soon here. And you can go to google.com/accessibility to sign up for a trusted tester spot. And then later this year, we'll be pushing it to the Play Store.
All right, so be on the lookout. Ha! See what I did there? Be on the lookout for Lookout coming soon to a Play Store near you. Thank you very much, Patrick, for the tour.
Yeah, my pleasure.
You up when you think you're alone, and no one picks up the phone. Forgotten skin and bones. Oh, yeah, I take you home, fill your body with chrome, build a castle to hold. 'Cause you build me up, oh, 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 and you never let go. Oh, 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 yeah, you build me up.
All right, hey everyone. My name's Dan, and this is Matt, and we're both Googlers who work on a product called Dialogflow. So I wanted to say first, thank you so much for coming. We've been having an amazing I/O, and we're super excited to share our talk with you. You've probably heard a lot over the last few days about how important the Google Assistant is to our vision for how computers can help people get things done. The Assistant works across dozens of device types and makes the most of the best features of each device. That could mean the quick at-a-glance display of a smartwatch, And it could mean the benefits of no screen at all. The assistant's now available on over 500 million devices, so that makes this a really important platform to build for. So the assistant is tough, but the real power of platforms comes from their developers. So how do we empower our developers to extend the assistant and do things we never could have imagined? This is where Dialogflow comes in. We've taken what we learned from building amazing conversational experiences, and we've built a tool that allows any developer to do the same thing. This session, we're going to tell you all about Dialogflow. We're going to tell you what it does, where it fits, and we're going to show you how to build a sophisticated action for the Google Assistant in just a few minutes. We're also going to talk about a few upgrades we've made based on feedback we've had from our awesome community. So, as you saw in our developer keynote, we've had really great momentum in growth this year. We've had 500,000 developers use Dialogflow, which is a 250% increase since this time last year. And Google's developers are obviously really excited to use our ML tech in their work. We've also got brands all around the world using Dialogflow, and they're building some really amazing stuff. So if you want to see some case studies, you can check our website to see some of our partners' experiences using the product. All right, let's get technical. So before we go further, let's go over some basics. An action is a third-party experience for the assistant. And there are many ways a user can invoke your action. First, they can just ask the assistant for your action by name. Or maybe the assistant might suggest your action based on its functionality. Once invoked, your action is going to the assistant is going to hand conversation control over to Dialogflow. Dialogflow understands conversational language, and it will hold a conversation with your users based on a structure that you define. You can then connect this conversation with your business logic to make things happen and generate replies. To define this conversation, you'll use Dialogflow's UI, and it's a web app that even non-developers can use. There's no coding required for simple apps, and it takes literally minutes to prototype a conversation. Under the hood, this all uses Google's machine learning and natural language understanding tools, but you won't need a PhD to make use of them. For more complex actions, connecting actions with your code is super easy, and you can even use our embedded cloud functions for Firebase Editor. You just tell Dialogflow at which points the conversation it should communicate with your code. Dialogflow then makes an HTTP request with JSON describing what the user wants. And you can use this to construct a complex response or to look something up and generally make stuff happen. So we want to show you how easy it is to get started with Dialogflow. And over the next few minutes, we're going to build an action from scratch for an imaginary local business. Our business is going to be a bike repair shop. Our action is going to work like a helpful store clerk. And it's going to allow our bike repair shop's customers to check the shop's opening hours and book an appointment to service their bike. So here's what's going to happen during the demo. First, we're going to walk you through how to respond to user queries with a powerful concept called the intent. We're then going to show you how to extract detailed information from users' queries, like times and dates. And we're going to demonstrate how to connect your action to business logic that will store appointments in a Google Calendar. Finally, we're going to integrate our action with the Google Assistant and test it out. So to get started, I'm going to hand over to Matt, and he's going to demonstrate how the finished action is going to work on his shiny new Pixelbook.
Thanks, Dan. Can we go ahead and switch to the demo? Oh, there we go. So before we get started building, I'm just going to give you guys a quick demo of what we're going to build. So right now on the left side of the screen, we have the Google Assistant up on the Pixelbook, and we'll say, talk to my bike shop to invocate our action. So right now, the Google Assistant is handing off the conversation from the user from the Google Assistant to our action, the bike shop. So right now, we're going to set up an appointment, and it's going to ask us what day we want to come in. So we're going to say next Friday. And then it asks us what time, and we'll say 3 p.m. And right now, the cloud function is actually adding an event to our calendar, you can see there, and asking us what kind of appointment. So I'm going to say tune-up. And there we can see our action has confirmed the appointment and has ended the conversation. So now let's build it. So we're going to switch to this Dialogflow here and log in. So this is Dialogflow's console. On the left, you'll see a panel where you have all the main concepts that you need to use to build a Dialogflow agent. And in the middle, we have the panel where you do use all these main concepts. Right now, it's a list of intents. And on the right, we have a simulator where you can try out your Dialogflow agent as you're building it. So let's go ahead and try it out. We'll say hello. So we can see that the default welcome intent here was matched. And if we open up the default welcome intent, you can see that we had the response hi. So that's not quite what we want to say since we have a bike shop. So let's change that response up and say, welcome to my bike shop. How can I help? So we'll try it again. And, oh, we needed to add. So now we're adding a training phrase here so that our hi query is understood. And the agent is training and using this hi example as a training phrase for a machine learning model that's running in the background that will identify incoming requests to this welcome intent. So we'll try hi again. And now we can see that our response is correctly identified, and we send back the correct response. So let's create our own intent now. So we'll go to the navigation panel on the left where it says intents and click this little plus sign to create our own intent. And we'll type in hours. So this will be our intent that we're going to create for any intention that the user has to know the hours that our bike store is open. So for the first thing we need to do is add training phrases. So these training phrases are used as the basis for the machine learning model. So we need to think of things users might say when they want to know the hours of our bike shop. So we'll do a few examples here. How late can I come in? They might say, what are your hours directly? Or they might say, when do you open? So I'll go ahead and save that, and then Dialogflow will start this training process using these training phrases. And while that's happening, we're going to add a response. So down here, we click Add Response, and then we'll say we're open from 9 a.m. to 5 p.m. every weekday. We'll click Save, and we'll try querying this out. All right, are you open now? So now we can see the hours intent was matched down here and sent back the correct response. We're open from 9 to 5 every day. And now I just want to take a moment and notice that the query, are you open now, isn't really similar to any of the training phrases we have. When do you open? What are your hours? How late can I come in? So this is the kind of the power of Dialogflow and really shows off how powerful it is. If you can imagine trying to write a regular expression to match every instance of these 4 examples, as well as the thousands of other ways that someone could ask, when is your store open? This is where Dialogflow just becomes really powerful and allows your users to talk to you in a natural conversational way. So now let's take a closer look at the response. It's a little bit generic. So we're open from 9 to 5 every weekday. We're not actually answering the question, are you open now? And in a normal conversation with someone, you'd expect to have more contextual information. So they might say, oh, we're open until 5 today. So for that, we need to do some sort of calculation as to what the time is and when our bike store, and if that falls within our bike store's open hours range. So for any sort of calculation or API request or a database query, we need to use something called fulfillment. So if you go to the left panel here, we see down here we have fulfillment. So fulfillment is how you connect your Dialogflow agent to code. In this case, we have an inline editor where I've already deployed some code. So we can scroll down here and look at the hours function. We can see we check if the store is currently open. And if it is, we give a response that says we're open now, and we will be open until 5. And if it's not, we tell them when we're open next. So there's one more thing we need to do to connect this code to our Dialogflow agent, and that's go back to our hours intent and scroll all the way down and go to fulfillment and enable fulfillment for this intent. So once we do that, if we try our query again, are you open now? We can see right now that this, so right now, the hours intent is calling the webhook and comes back with the correct response of we're open now, and we close at 5 p.m. today. So that calculation was made and sent back the proper response. All right, now let's try something a little more complex. We're going to create an intent for making an appointment. So we'll call it the make appointment intent. And for this intent, we'll need a few more examples because there's many different ways that a user might say, I want to make an appointment. So we'll go through those right now. I'd like to get a bike tune-up. I'd like to schedule an appointment next Thursday. Can I schedule service for noon? Can I set up an appointment for my bike tomorrow at 2 p.m.? And the last one, I'd like to come in at 9 a.m. on May 11th. So now you can see we have a few things going on here that are different from our previous examples. So Dialogflow has highlighted a few of the entities that are present in our user says examples. So entities in the Dialogflow has several entities built in, so we can extract data from what users are saying and use it for, in this case, to schedule a bike appointment. So all the red highlighted items are times, and all the yellow highlighted items are dates. So if we scroll down, we can see that these are listed as parameters. So we have the date and time listed, and the value that we can use to present this in our responses. So in this case, we want to reflect back the time and the time and date the user has specified, so we can confirm the right appointment time. So we'll go ahead and add a response here and say, great, I've set up your appointment for the $date. So this takes the value from what the user says and puts it in our response. And then at $time, so this will add the same thing for the time value. Oops. See you then. We'll go ahead and save that, and then we'll try this out. So I want an appointment tomorrow at 3 p.m. So now you can see that Dialogflow has correctly matched the make appointment intent and has extracted out that tomorrow means May 11th, and that 3 p.m. means 1500 hours. So it's easily parsable on our webhook, and it correctly inserts those values back into our response. So to actually make an appointment, we need a date and a time. So we need to make sure that the user provides both those pieces of data. So we're going to go to the parameter table and make both of these parameters required. Now, when a parameter is required, we can define a prompt so that if a user doesn't provide a date or a time, we can ask them for it. So in this case, for day, we'll add a prompt that says, what day do you want to come in? And for our time, we'll add a prompt that says, what time works for you? So let's try that out. We'll say, I need an appointment. Oops. Let's try appointment. So now that we've matched the make appointment intent, you can see that the response, instead of our response defined here, we hit one of our prompts that says, what day do you want to come in? So we'll go ahead and answer that question, say next Friday. And what time works for you? We'll say 11 a.m. And now you can see that this has been filled in correctly by Dialogflow, and we get the ultimate response back there. So now that we've set up an appointment, we might want to get some additional information from the user about the appointment. So we might want to know what kind of appointment type. So we'll go ask them a question and say, do you need a repair or just a tune-up? So now we need a way to capture the answer to this question if they want a repair or a tune-up. So Dialogflow already has these built-in entities for date and time, but you can also create your own entities. So we'll go ahead and do that now. On the left panel, again, you can see we have a panel for entities and another plus button. So we'll create an entity, and we'll call it appointment type. And then we'll add entries for our appointment type entity. So in this case, we'll have a service option and a fix option. So we'll enter in the first value, service. And then we can also enter in synonym values for each of these entities. So someone might not actually say the word service, but they might say another word that means the same thing. So we can define synonyms that will map back to this canonical value. So instead of saying service, someone might say overhaul. They might say maintenance. They might say tune-up. Or they might say tune-up with a space in it. And for our other value, we have fix. So someone might say repair, mend. They might say their bike is broken. They might say they have a flat tire. Or they might say fixed. So we'll save that. So now that we have an appointment type entity, we need to create an intent to capture it. And in the case of our intents, we only really want to capture this appointment type entity after our make appointment intent has been matched. So we want to make a new intent that only is matched after the make appointment intent. For that, Dialogflow has something called follow-up intents. So if we hover over the make appointment intent, you can see there's the add follow-up intent option. So we'll create a custom follow-up intent. So this new intent that's listed here with that arrow means that this intent will only be matched after the make appointment intent. So we'll click that and we'll add some user says examples. So for this, we've just asked the user if they want a service or if they want to fix their bike. So we'll enter in some examples of how users might answer that question. They might say, I need a repair. Or they might say, can you service my bike? So now you can see, as before with the built-in entities, Dialogflow has correctly identified our custom entity that we just created. Since we need to know this information, we're going to make it required, and we'll add a prompt for it as well. We can service or repair your bike. Which one would you like? So now for our response here, it would be nice to confirm our actual appointment time and date after they've said what appointment type they have. But if you'll see here in the parameter table, we actually don't have the time or date here. So how do we get this value? For that, we're going to need to dig in a little deeper into how follow-up intents work. So follow-up intents work through something called context. So once we added this follow-up intent to the make appointment intent, a output context was added to make appointment. There are two types of context: output context and input context. Output context attach a context to a session after the intent has been matched. So in this case, after our make appointment intent has been matched, the make appointment follow-up context will be added to the session. Next, let's take a look at our follow-up intent. For our follow-up intent, we have the same value make appointment follow-up context, except instead of the output context, it's in the input context. So this makes the make appointment custom, or our follow-up intent, only get matched once the make appointment follow-up context is attached to the session. So in our case, the only time that the make appointment follow-up context is attached to the session is our parent make appointment intent. So this means that this make appointment custom follow-up intent will only be matched after our make appointment parent intent. In addition to controlling the flow and how intents are matched, contexts also store parameter values. So we can use the value of make appointment dash follow-up to reference the time and date that we previously gathered in the make appointment intent. So we'll go ahead and do that now. We'll say, OK, we'll schedule a $ appointment. So this is grabbing whether they're fixing or servicing their bike, just like last time. And now we want to insert the date. So we'll do pound make appointment follow-up, and then do .date, at, and then we'll do the same context value, .time. So this will grab our time and date values from the previous intent. We'll see you then. All right, now instead of trying this out on Dialogflow Simulator on the right, why don't we try and see what this looks like when you deploy it to the Google Assistant? For that, we'll look again on the left panel, and we'll see a page called Integrations. So this integrations page shows all the integrations that Dialogflow has with other chat and voice providers. So you can use any of these to deploy your Dialogflow agent to your users on any platform. For now, we're going to start out with the Google Assistant. And you can see some information about how Dialogflow works with the Google Assistant. But for now, we're just going to try it out. So clicking Test opens up the Actions on Google Console. The Actions on Google Console is where you define all the information about your action, like invocation name. So for right now, we say talk to my test app. My test app is a special name that's just for you when you're starting to test. But you can enter in any name for your brand once you get into the Actions console. For now, we'll try with just talk to my test app. So
okay,
now,
here's the test version of my test app.
Hi, welcome to my bike shop. How can I help?
So what's happened now is we've invocated our action, and that sends the request to Dialogflow, which matches the welcome intent, which sends back the response we defined earlier. So let's try this out. Can I book an appointment for tomorrow at noon?
What time works for you?
Oh, noon. There we go.
Great. I've set up your appointment for the 11th of May 2018 at 12 hours 0 minutes and 0 seconds. Do you need a repair or just a tune-up?
So now we see it's matched the make appointment intent, and now we're going to try out our follow-up intent. So we'll say, I need a repair.
Okay, we'll schedule a fix for the 11th of May 2018 at 12 hours 0 minutes and 0 seconds. We'll see you then.
So now you can see that it correctly identified the repair word and mapped it to the word fix. So in our response, it says, OK, we'll schedule a fix, and then also grabbed the time and date from the context to surface that to the user as well. So now that we've got an action fully working, I'm going to pass it back to Dan, who's going to talk about some of the new features that we've built in Dialogflow over the last year and some more features I didn't get to go over. Dan?
Awesome. All right, you should take a bow. So yeah, I hope that we've shown you how quickly you can build. In a few minutes, we've built an engaging conversational agent. We connected it to our code, and we've been able to deploy and test it immediately. And the really crazy thing is that after review, this action will be available on over 500 million devices with no install required. People just have to say the name of your action. So conversational experiences are a pretty new idea. And building your first agent can be hard because there's a whole set of concepts that may be unfamiliar for you. So we've built a lot of tools that will help make it easier to get started. Dialogflow comes with 45 pre-built agents that you can use as a starting point when you're developing. We cover a load of different real-world scenarios, like setting alarms, booking tickets, and all sorts of stuff. All you need to do is import the intents and entities and customize them to support and suit your action. In fact, every single Dialogflow agent comes equipped with over 50 system entities. These cover common concepts, including numbers, dates and times, amounts with units, and geography. Dialogflow can extract values based on these concepts with no additional work, so you can understand your customers and help them get things done without a lot of overhead. We also have a growing library of sample agents that demonstrate how to use our features, and these are referenced in our docs and on GitHub. And for I/O this year, we've added a new feature where you can open the sample with one click and try it out instantly. So this will deploy the agent and the fulfillment code, so you can just customize it and be up and running straight away. Speaking of our docs, we've also built in interactive Dialogflow agents, so you can play with real-life examples to help you learn important topics. We're regularly publishing new videos and tutorials to help you develop, and we just published another brief getting started video to our Dialogflow YouTube. Once you've learned the basics, we provide tools to help you do really powerful stuff. So Dialogflow will help you extend your actions over time, so you can improve your customer experience and performance. For example, Natural conversations branch in complex and unpredictable ways. Things that are discussed earlier in a conversation can have an impact later on. And in the past, conversational platforms required you to hard code everything, which was really brittle and difficult to do anything to improve over time. Fortunately, Dialogflow's context allows you to shape the flow of a conversation without having to predict every possible twist and turn ahead of time. This can help you get beyond the idea of a menu-based phone conversation and create genuine conversation between people and computers. Once your action's up and running, you'll have a ton of logs of conversations, and you can use this data to improve your actions machine learning model. Our training feature will show you all of your past interactions, and it helps you assign them as training phrases for intents. You can also create new intents when customers ask for something that you didn't handle. Every feature we add is guided by these 3 goals. We want to create an excellent full-stack experience for our developers. We want the best possible natural language understanding and machine learning. And we want it to be easy to integrate and scale across any conversational platform. We use developer feedback to decide how to evolve our platform, and I wanted to show you some of the features that we've added since last year's I/O. First, we've heard that you want better insight into how conversations are going, so we've improved our history view and made it much easier for developers to see how their agent is being used. Now you can filter on date and platform, and you can search through logs to find particular interactions that are noteworthy. This will help improve your debugging experience and help you get to a better agent design over time. We've also been working really hard to support all the languages that your users speak. And today we support a total of 21 languages and 9 locales. We recently added support for languages including Hindi, Thai, and Indonesian. And we cover all of the languages the assistant supports, plus more. We've also added multilingual agents, so you can build one agent that works for all of your users across the world. Many of our customers have been asking us for an enterprise solution, and so this year we introduced Dialogflow Enterprise Edition. This brings Dialogflow to Google Cloud, which means you get enterprise-grade compliance and customer support on our cloud terms of service. So Ubisoft built their personal gaming assistant, Sam, on Dialogflow Enterprise Edition. And Sam was able to understand and answer 88% of players' requests in the first 3 months of their beta. So I hope you're feeling excited to get started building with Dialogflow. There have been tons of really amazing assistant sessions at this year's I/O, and you can find links to recordings of them all on the I/O website so you can enjoy them at your leisure. You should also make sure you check out our code labs, which will guide you through building your first action. Your feedback is super important to our team, and we really hope you've enjoyed this session. So we'd also love for you to head over to the I/O website and let us know your thoughts. It's super easy to get started with Dialogflow, and we put together a page full of links that can help you get up and running. You'll also find links on there to our online communities where our whole team is hanging out and we can help answer your questions. Also, don't be shy about tweeting our AOG Devs hashtag if you want to share your I/O experiences with our team. So we hope you had a really amazing I/O and that you go on and have a ton of fun building actions for Google with Dialogflow. Thank you very much. Thanks.
It's been a fun 3 days with all of you here at Shoreline Amphitheater for Google I/O 2018. We've checked out a lot of really cool in-person experiences that you might have missed if you just tuned in for the session videos. If you want to experience all the fun again, or for the first time and at your own speed, go to g.co/io/guide. To learn more about Google Developer products, make sure to fill out a form at g.co/dev/form. I look forward to seeing you all next year, on-site and online for Google I/O 2019. Until then, make good things together. I'm Timothy Jordan. From all of us here at Google, goodbye from I/O 2018.